Hi guys, as you know, my name is John. I'm a CCNA trainer, also CCNP trainer. I'm a DevNet trainer. I also give trainings on Python, automation, and DevOps, also on cybersecurity. I'm a graduate from Christ University, Bangalore. After that, I was working for a corporate firm that was called as Networkers Home. That previously, there also I was working as a trainer. Then I was working as a consultant. Then. I'm basically a self-taught person who learned CCNA by reading textbooks of Toad Lamble. That was a previous version of CCNA. Like previously, like we had this version called CCNA R&S and Toad Lamble. Like there was a book for Toad Lamble's routing and switching. So when I was in my university, I got a chance to read those books. Just because like we had computer networkers at that time. So I was very interested. Then I jumped into CCNA. Then I became a trainer, consultant, uh, something which I'm doing in the similar field. Right now, I am focusing all my energy into DevOps and DevNet. Yeah, this is all about me. Trust me, guys. Like when I was doing my first role as a CCNA trainer, I have trained people like who have been doing their majors in Sanskrit, economics, commerce, computer science. I have even trained managers at the same all those people like they were in the same batches at the same time. So the only thing that I tell to everyone, whether you might be managers, so even I worked as an SMB for a long time. So even if you're working as an SMB, you are not even touching the base of so many things. Like even in managerial positions, most of the things that we are discussing over here, you might not be actually working in on a day-to-day basis. So you might not be remembering all those topics. But what I'm telling to all those people like who are experienced, who are not experienced, this is the only thing. Okay, you should trust your trainer like when you're doing this course. Why this trust is important? So if I'm telling you to do something at a certain time, you should do at that certain time. Okay, so in networking, so I did my things under graduation in computer science. So in computer science, there is a subject that is called as data structures. Like once you learn data structures, which is not something which is related to this, but that is something which I am applying to everything that I am involving in my life. So in data structures, it's okay. Whenever you have a problem, like you're basically troubleshooting, you're getting into the core and understanding it. So here, same matters like we can apply over here. Okay, whenever you are saying that John, I'm not able to send a packet from this PC to another PC. So there are like 5 or 6 scenarios that might be the root cause of this. Okay, so if you're doing it step by step, so you just have to follow the procedure what I'm telling you. Okay, in your head. Okay, so some of you guys might have the ability to understand. So out of this procedure, what is the first, like what is that step that you have to take immediately? But this is something that you will get with experience. The more you practice, you will have that quick understanding. Okay, this is the next immediate step. Or else it's very easy. You just have to follow the steps that I'm telling you. Once you follow those steps, you will reach there. Okay, so here we have around like 1 hour of training. So all the training that we are doing over here, it's completely practical from the second week or third week. So once we start with the practicals, I want all of you guys to do the practicals, okay, and share it in the WhatsApp group. We'll be creating a WhatsApp group. The team, the network Kings team, they will be creating a WhatsApp group and they will be adding in. And once we start the practicals, you can share your outcome over there. And there will be like many people like who are in the same batch. So whenever you have a doubt, you can ask with your teammates. If that resolution is not okay with you, you can immediately ping me. I'll be reaching back to you at the earliest. So the only advice that I have to give you is just follow the procedure that I'm telling you. So I'll just give you a basic introduction. What is CCNA? What is networking? And other things. Okay, so before jumping into this course, like what is networking, guys? Like what is your understanding? What is networking? Any of you guys who are okay, for the people like who are experienced, please not answer this question. You might be mentioning with some technical names of any technical devices, but any other people like who are coming new to this, we are learning about networking in CCNA. So any of you guys who are from non-technical background who will be confident to explain like what is networking?
Networking is when data is transferred from one node to another.
Okay. Deep, that is one of the many exam that explanation that we can take. But in simple, what is network? Network is basically a connection between two or more things.
Yes, network is a collection
Yes,
of
sir.
internet.
Centralize the systems.
Okay, just forget about internet, forget about routers, forget about switches, forget about devices. What is network? Network is basically a connection. So
Yes,
your
internet.
your LinkedIn account, that is a network, right? Your Instagram followers, your Instagram connection, that is a network. Your friends, that is a network. You call that as a network, right? So there is a security
Yes, sir.
guard
Yes.
who is right in front of the gate who will be checking your IDs, and you have to show the badge to them. If you see something suspicious, he won't let you inside the gate. Okay, so your friends, your LinkedIn account, the connection that you have, your social group, all those things are networking. Network, or when you are interacting with somebody, when you are interacting for job perspective, also like when you're interacting with someone, you are exchanging information. So networking is what? Networking is basically a connection between like two or more things. When there is a connection between two or more things, like exchange of information will happen. Again, we are not mentioning specifically mentioning about technical transactions like data or packet or any other thing. Like we are just mentioning about like communication will happen, like exchanges of information will take place, like when there is two or more people which are connected. Okay, in this particular course we are talking about computer networking. Computer networking is particularly means the devices in computer, when computer peripherals are connected together, that forms a network, because all those peripherals informations are being exchanged. Okay, so that is what we are learning in this particular course. Okay, how? So in simple words, I mean, you're sending a WhatsApp message to your friend, how the message is sent from one device to another device. Okay, so you might be typing your message in where you might be typing the message in your application layer. Okay, so another person will be reading this message where in their application layer. We will discuss what application layer is for the people who are new to this. But application layer in simple, it is the layer that you are viewing and sending this information. Okay, so but how the message is actually, okay, you might be, so some of you guys who are attending this training, some of you guys are from a different part of the country, so you might have a different service provider. Service provider is the person who provides you internet, so I am having a different service provider. So from how the network is, how that packet or the data is traveling from my network to your network, we are discussing that. Okay, so in order to discuss that, like in order to discuss the technologies, like we are discussing routing. Routing means the process in which we are sending a packet from one network to another. So all those information, all those things we'll be discussing CCNA course. Okay, why the CCNA course is very important, doesn't? Because most of you guys who might be graduated from computer science, like even if you want to apply, like the scope of networking jobs, it's huge. There are huge opportunities for networking jobs, but the right people, the right qualified people who are there to do this particular job, it's very limited because of the lack of knowledge. So then Cisco is considered as, so this course CCN is a course which is developed by a company that is known as Cisco. Cisco is one of the world's largest manufacturer of networking device. What is a networking device? Any, so some devices which will be able to which will help you to communicate over the network using some devices that are basically networking devices. So Cisco manages and manufactures such kind of devices. Okay, so since Cisco is the largest manufacturer of the devices, and they need like many people like who want to work as network engineers, so they thought like there is a huge gap in the industry with the knowledge and with the right expertise. So why don't we develop a course? the initial course that they developed. Okay, so there were many courses, but we can say CCNA is like one of the step one course that you can take. Okay, so CCNA 200 301. When you do this particular courses, you will have a basic understanding. Okay, you will have a basic understanding about how network is working, how LAN is working, how WAN is working, how router is working, how firewall is working, what are the responsibility, what is the responsibility of a router switch. Okay, because you won't have this information just because you are coming from college, and in college like there is no knowledge that you're getting about computer networking. So once you complete this particular course, Cisco has an exam, so CCNA exam. So CCNA exam, it will cost somewhere around no, it will cost Cisco, once you clear this exam, people, the recruiters, they will get an understanding that you have done your CCNA exam, that is 200 301, and you have a very thorough understanding about computer networks, so they can hire you. So they don't have to send the invitation job invites to any number of people. They can just screen the people based on the people like who have done this certification. That is in a nutshell what CCNA exam and why you should do CCNA. Do you guys have any questions so far?
My question first was, you said we are going to learn the basics in this course, and when we write the exams, we can be employed by Cisco to work in their company. Is it that when you have this exam, you can work only with Cisco, or you can work with any other company that requires somebody with this certification?
Yeah, good question. Okay, so this exam, it's conducted by Cisco, but this exam doesn't guarantee that you will get a job in Cisco. Please don't have your mindset set in that area. You might not get, you might or you might not get a job from Cisco based on your qualification and based on your expertise. So this is an exam which will let all other vendors, all other manufacturers, there are n number of manufacturers who manufacture networking devices. Some of the competitors are Aruba, Juniper. Yeah, you can think of that, Aruba, Juniper. So they also have exams on their particular field, but those exams are not so popular. So even using this certification, you can get job requests from those vendors as well. There not might be. It not might be like you will be getting a job from Cisco. Based on this, recruiters who are hiring for network engineer roles, so they might be using different products. But again, you will have to understand this fact. Here we are working with Cisco devices, so there are few changes. Like when you will be working with a different vendor, there might be like few changes that are there. Okay, so that you will learn once you get into a job. Like they will give you a proper induction. Like once you get the induction, you will understand like what are the basic few changes that are there. That things like you can easily understand in like 1 or 2 days, or like in the first 1 month of the induction, you will easily understand that. So it's like little bit of changes in the commands, nothing big. Grace, I hope it's clear.
Yes,
And
okay.
yeah,
My second question is,
Sir Jack, I
yeah, one
Sir
at a
John,
time. Yeah, who is speaking?
I'm Ronald.
Ronald.
I'm
Yeah,
Ronald.
yeah.
Can I ask one question? Sir, what the difference from CCNA and CCNP?
So the first exam that you are taking, that is known as Cisco Certified Network Associate, that is CCNA. Okay, that is the associate level exam. The next level of exam that you will take once you have done your CCNA, and once you have like at least 1 or 2 year of experience in CCNA, you will be upgrading yourself with CCNP. So in CCNP, you will be learning about Cisco Certified Networking Professional. This is an associate. CCNP is professional level examination, and you will be getting jobs based on the professional levels. So here, when we are learning about routing protocols, like we are just learning about RIP, EIGRP, and we don't even have BGP, but we'll just discuss the basics of BGP and OSPF. So even in OSPF, as per the syllabus, like it's OSPF area 0. But in CCNP, you will be dwelling deeper into these protocols, into these technologies. As a professional level, you will be learning all those courses in your CCNP. So those after that, like you do have one more exam that is known as the CCI exam. That is considered as the world's one of the hardest exam, Cisco Certified Inter Expert. So CCI exam. So there is a certain number that you will be getting after your CCI exam. So with those exam, uh, that is a highly valuable exam where companies will come and recruit you if you clear the CCI exam. So in CCI exam, you have a written exam and you have a lab exam. So you will have to clear the lab to be called as a CCI certified networking expert, internet expert. So once you clear that, you will have a huge demand in the market. You will be you can go for the architect levels. So while doing the CCNA course, like the entry, you will be getting an entry level job as an L2 engineer or an L3 engineer, but you will have to go through your CCNP training to get into an L3 engineer. So you might be working for NOC, SOC, or TAC profiles. So basically on those profiles, like what is your day-to-day job is, like there is a site, so you will have to monitor the sites. You will have to keep make sure that the site is always available. But once you clear your CCI, you will be basically designing networks, operating with much architectural level operations you will be handling.
Okay, sir. But one question, sir, only. If you direct to take exam CCNP, is required to pass to CNA or no need?
That is also a very
Hello?
good question. So if you do your CCNP, there is a higher chance that you will clear your CCNA, because simple fact. So when you are in your eighth grade might be something which might be tougher to you. When you push your limit and when you learn your 10th grade, your eighth grade exam will be a piece of cake, right? So like that, if you do your CCNP, your CCN exam is gonna be so easy for you.
Okay, sir. Should be
Yeah,
from step by step. Okay, sir.
yeah.
Thank you so much, sir, for very nice explanation. Thank you so much.
Okay, okay.
So John, there will be no limitation of for CCNA. I mean, if anybody want to do direct CCNP, so it's not required. The CCNA is required for that, right?
Yeah, guys, if you want to write your CCNP exam, so previously, 6 years back, when I was doing my CCNA, so at that time, like if you want to do your CCIE exam, first you have to do your CCNA. At that time, CCNA was CCNA routing and switching. So once you do your CCNA routing and switching, you will have to do your CCNP routing and switching. Then you will have to do your CCI. Okay, so Cisco, they changed the complete rules. Right now, you can directly go for your CCNP. You don't even have to write your CCNA exam. Okay, so once you clear your CCNP, you can directly give the CCI lab exam also if you want. And one more suggestion from my side: if you are an entry level person, you will get a course completion certification from Network Kings. That will be enough and more for you to land in your networking career. Okay, why I'm saying is, if only if you're moving outside India, please take this exam if you're paying the money from your pocket. Because because in India, like there are many proxy exams that are happening, and the exam is not so valid inside India because of the proxies and other thing. And for CCI exam, if you're doing from any part of the world, it's really good because proxies won't work over there. So if you're moving outside India, this exam is highly recommended. So if you're going to US or Europe, you will land a very good job with a very good package just with CCNA. Okay. And if your company is paying for it, go for it, because it's very good to have a certification from your side. But until and unless if you're freshers, I would recommend you to get in some production, like have a hands-on experience on the device, then go for the exam rather than directly going for the exam. So what I would be suggesting is that once you complete this course, you'll be getting a course completion certificate that will be good enough to land into your job. And one more advantage that you have over here, for the, I don't know, like for how many courses they are offering placement support. So if you have placement support, the toughest part for an entry level person is to land into their first job. If you land into your first job, your second job, third job, fourth job, it's going to be very easy. But landing into a first job or first job, that is going to be the most crucial part. Here, the main advantage is that since these people, like they have been in the industry for the last so many years, and they have been tied up with so many good companies, product-based companies. Once you clear the exam, like there might be like in-house interviews, which will help you to land into your first career. Then do your CCNA exam, because once you land into a product-based company, the company will be paying for your certification. So at that time, do as many certification as you can. Yeah.
John.
John, I have one question. So you mentioned about the placement support. Okay. So
Okay,
are we going to
first of all,
have?
just a heads up, I am not the right person to answer it. I'm just an external resource who's coming for the training. We are
Okay.
also working in production right now.
Okay.
So you will have to reach out to your coordinator regarding any information regarding the placement. I just know for some courses they offer placement support.
Mm-hmm.
That's the
Okay.
only information I possess from my side.
Okay, got it.
Hi, John.
Yeah.
Grace again, please. I am a fresher, so don't bother about my questions today.
Okay.
You said after this program, we are going to get a certificate of completion from networkings. But you will not really advise somebody to go directly for the certification, except the person had some kind of hands-on, like experience, lab work. So
Yeah.
can I use the certificate of completion and get myself a company where I can do free will work just to upgrade my experience?
Voluntary.
Voluntary.
I don't understand the last part, but the first part I
Um,
understood.
okay, like can I use the certificate of completion from networking without the CCNA certification? Can I use just that certificate and do a voluntary service in a network company so I can
Yes, of course.
upgrade
Yes,
my
of course.
hands-on, like
So
upgrade
yeah,
my
yeah, I get it. I get it.
experience, then go in for the exams? Is that what you
I get
meant?
it, Grace.
Yeah.
Yes, yes. Yeah, so that's what I'm saying. So in any company that you're going, no matter whether you hold the certification or not, they're going to ask the interview. They're going to conduct the interview. So once they conduct the interview, they will understand like whether you know the concept or not. Because there are many options that you, like I told, like in black markets also, like the courses are available which you can purchase it. So they will understand like once they conduct the interview. So if you have done the course, if you have done your practicals, they will know like once they conduct their interview. So if you know, that itself is more important than any other certificate. That's what I believe. So your knowledge should speak for you.
Thank you very much.
Yeah, guys, for the experienced people, today we are not covering actually starting the topic directly. So there are many non-technical people who are over here. So we're just clearing some of their doubts and concerns. So what I advised before, no matter what, like you just have to trust your trainer in the next 50 hours of your classes, because during that time we'll be covering this course. Okay, so if you're following whatever I'm telling you, you will be clearing this exam. You will be not clearing the exam, you'll be clearing this course easily. Okay, so just to give them the confidence, like clearing their confusions, to because like once I start this course, I don't want to have these questions inside the class. We'll just have to move as a normal professional batch. So that's the reason I'm taking this questions. But if you're done with your questions, we will just give some other introduction. We'll just tell some networking stories.
Yes, sir. Yeah, John. Please go ahead.
Okay. Yeah. Okay. So
Hi, John. Naveen here. See, I mean, I am already working on an organization. I'm working in IBM from last 10 years. So basically, this is for the person who are also wondering about examination. I just want to share my experience here. See, exam is not a big thing. Okay, as per my understanding, the main thing is to understand the concept. Once you will understand the concept, the company will easily hire you. Okay, so I will suggest everyone to understand the concept first and then go for the exam. Please correct me, John, if I'm wrong somewhere.
no, I mean that's a very, very good thought that you
Purpose,
actually shared
because
with the team.
even I faces many challenges while working in my company. So that's why I've joined from the scratch here.
Yeah. I understand. I mean, I understand. I mean, and guys, please understand. He is working for IBM. Like that is one of the biggest company in India, and he's already having like 10 years of experience. Okay, so knowledge is something which matters the most. Yeah. Okay. So make sure that you have your foundation strong. Then you will easily land in the interviews. You can easily clear the interviews. But even if you have your certificate, just because you have your certificate doesn't guarantee you any job or any other nothing. You will be like any other ordinary people, like who are hopeless in their career. Okay, so that's it, guys. We will
Also, John,
discuss.
if I
Yeah,
say 10-year experience, then don't consider me as experience. Please consider me as that I don't know anything. Okay,
that is also a part of it. I mean,
I'm
just
new in networking. Okay,
Yeah,
So
yeah. Naveen, what are you working as?
I am working as a network engineer only, but there are many things which am facing in daily life, okay, daily. So that's why I thought to let's start from the beginning.
Okay,
So
Naveen, I just
basically,
want to
I was
understand.
working as a VMware NSX engineer, but NSX
Yeah.
is something where you can handle it, right? But now all the project has gone, so I'm starting with the traditional things. So that's why I've joined here.
Okay.
So
Now, I mean, correct me if I'm wrong in one thing, because I have also, I mean, most of my career it's been on training, but I also have like a few years of working in production. So I just have to ask you this thing. So, guys, all of you guys also please pay attention. So, basically, you might be having a topology like a site that you will be supporting. So, you might be having an SOP. So, once somebody calls, you might be working as a manager, right?
I am not at the manager level, but
Yeah.
I am somewhere in technical only. So you can say like L2 level also. But I'm already working on multiple technology like F2, F5, switching, routing, NSX,
So,
VMware.
basically, you're troubleshooting, right?
Correct.
Yeah. So whenever you're troubleshooting, you will have a certain SOPs. When somebody says that their site is down, or for example, their site is down, you will be
Yeah, we get a
asking.
several tickets. Like there are proper knock team is there available. The first point of contact is a knock team. The
Yeah.
issue, if they are not able to handle it, they will transfer it to L2, and we are here to solve that. Okay.
Yeah. Okay, guys, understand this thing. So this is why I'm telling you. Just have to trust your trainer. Okay. So whenever you follow the procedure exactly what I'm telling you, you're gonna clear this course easily. Why? Because like I told, so if you're not able to ping from one PC to another PC, so there are like, okay, so there are certain steps that I will ask you to do by step. First, you will have to check your IP configuration. Once you check your IP configuration, you will have to check your default gateway configuration. Then you will have to check your router interface configuration. So once you check your router interface configuration, then you will have to check your routing table. Once you check your routing table, then you also have to check your next stop. Then once you check your next stop, basically you should be pinging to the end devices. So these are like the 4 or 5 steps that we are. I mean, I was just taking an example for you to understand this. So if you follow this procedure can be followed by anyone, whether you're coming from IT, whether you're coming from non-IT background, whether you're coming from commerce, because the only criteria that you need to have in this course is common sense, which I guess all of you guys will have it. So just follow it, follow the procedures until the end of this course. But when you do your CCNP, you can be creative. You can do your own, start with your own troubleshooting methods. That will be helpful for you. Okay, that's all about the information. So let's do a quick icebreaker. We'll we'll tell a networking story now. In no other questions, right?
One question, Sir Jan.
What?
One question again.
Yep. And guys, this
CC,
is the last question. We can
eh,
extend the class after 10 for any other extra questions. Okay, Ronald, you can speak. You can
my
ask the
question, sir,
question
is
now.
CCNP, sir, you will be trainer again?
No, no,
Ah,
I am jumping into automation now,
okay, sir. Thank you so much.
which means I just learned from the textbooks, two language textbooks to be very specific. So I have read that because it's very interesting. I read that over like 10 or 15 times. So if you read that at least like 3 times, you will be a pro in CCNA. You will have to read it. You will have to maintain your notes. I have some of the notes that I have. I had made that into PDF. I also have another command files that I'll be sharing with you. You also have to maintain it yourself. That is one advice that I'm telling you. So when I say I'm self-taught, you guys should not be worried, because every knowledge it's actually self-taught. Even if I'm telling you something, that is telling. If I'm not, you can only teach yourself. So whatever information that you have processing, your brain should be forming that data into an information and constructing that as a knowledge. So don't worry, but please make notes. And guys, all other questions. Yeah, all
Are
other
we going to
questions
get
I'll
it?
take.
Are we going to get the textbooks for free, or we're going to buy them?
You will get the textbooks PDF for free.
Okay, thank you very much.
Okay, these are some of my personal collections that I will be sharing with you. All other reference books also which you should be reading, I will be sharing it with you. Okay. And yeah, okay, guys. We'll take all of the questions at the end. We just have 20 minutes. We will discuss something now. So, like I told, what is networking? Networking is basically the connection between two or more things. So, when I say, so some of you guys might be from a non-technical background. So most of the examples, like 90% of the examples that we are discussing, we'll be relating it with an actual real life scenario which happened in real life. So when I say networking, when I say routing, when I say packet, all those things, you can compare it with literal English. Okay, when I say routing, what is routing? Routing is basically a process when you're traveling from a source to destination. Source means whenever you, if you're going from your office if you're going from your home to your office, that is also routing. Okay, so you might be going in a two-wheeler, you might be going in a bus. The device that facilitate that is known as router. Just for a common knowledge that I shared. Okay, now what are the some advantages of networking? What are the some advantages of networking? So 2015 I did my 10th grade exam. So 2015 is the time that I did my 10th grade exam. So during 2015 internet was not so popular at that time. So popular as in like we still had internet, but we were the people like who were using 2 GB of data per month. But by the end of the month we'll be having like 500 MB data balance. Okay, and we'll be like so eager to finish that 500 MB in the last day because we were saving that data for a long time. How many of you guys have similar experience in 2015, 13? Any of you guys remember this? If yes, please do a thumbs up in the chat.
Yeah, I have an
Like,
experience from the 2014.
yeah, 2014. So
So from
2000,
2014,
yeah,
I'm using with the networking with a lease line of
no,
Tata of 50 Mbps and U broadband. It's also
yeah,
about 50 Mbps and Hathway all near about 100 Mbps and a Geo line.
okay. I
Because
think
I
Rita
have
is
multiple
from the
branches in
new
the all
generation.
over India. I have 24 branches.
Yeah, good, good. We should discuss
24 branches
this.
and almost near about 24 firewalls we are handling.
Okay, good, good, good. We should discuss after
So,
class, Mahendra.
so nowadays
Okay.
is not possible to handle with the Tata and that U and the Geo. So additionally, we had added one two Geo line also.
Yeah. So yeah, that's
Because
enough.
basically,
So
what happened now?
2000, it's enough. Like we need to discuss something.
Yeah, sure,
Uh,
go ahead.
we should definitely chat after the class. Like we can discuss after 10. Okay. So 2013 is a time I was working as a service tech in a nearby shop, like where I started my career when I was in my school as a desktop support engineer or a service engineer, like where I used to service desktops. Some of you guys might have done it, like basically nothing, like just install operating systems and all. Okay, guys, do you know what is the largest network? The largest network is basically internet, right? Yeah, it's
Yes.
internet. You don't have to guess it. The largest network is, of course, internet. So some of you guys might be saying it's Geo, Airtel, but it's internet. Okay. So when we talk about internet, okay, what that is also network that we are also talking about networking now. So what is the advantages networking has brought? So like I told, even in 2015, like we were beggars who couldn't afford network. So 2016 I moved to Bangalore. So even then networking was not so cheap. 2013 I did my 10th. 2015 I did my PUC. So 2015 I joined in Christ for my BCA course. So then I remember in 2017 after demonetization a huge change came into the picture that was known as Geo. Okay, so when Geo came, a lot of things actually changed. Okay, after demonetization, what happened is like digital payments were in trend. Like Paytm was everywhere. Like you will say Paytm scanners. At least in Bangalore, you would have seen Paytm scanners all around. Then after that, like GPay came, but GPay was not so trendy at that time. Paytm was there. Paytm cashbacks were so common at that time. But at the same time, a major competitor, a major revolution happened in the tech industry. The major revolution was Geo. Okay, the major revolution was Geo as in, so when Geo came into the market, Geo was like, guys, I'm going to give you internet for free. You can use it as much as you want. I'm not talking about the low quality internet. I'm going to talk about the high quality internet. till now you guys think that internet is something which you couldn't afford. Okay, so right now I'm gonna give unlimited internet for free only for the Geo users. So at that time, what happened was like all of the people like they took a Geo spare SIM, and since these people like they had this confused mindset, since they used other SIM to call also, so that the number got saved in so many people's phone, and they couldn't change the number and they stick to Geo. But the other time, all the other ISPs they were forced to reduce their prices. But the major advantage that you see there is like a lot of micro businesses they emerged. So a lot of e-commerce platform that generated from Facebook. There are a lot of e-commerce platform that generated from Instagram. So what is the main advantage is that until that time, if you had to start a business, okay, so let's say that you want to start a clothing business, so you will have to rent a place in Bangalore. That is very expensive. You will have to, yep, the rent is expensive. You will have to have so many infrastructure, so many people over there, and you have. You might have to set up a website. You might have to set up like a lot of setup cost. So if you are starting up another company, a lot of setup cost would have been involved over there. So when this internet came and internet becomes so accessible to everyone, so a lot of micro businesses came. So even without having a shop, people used to run businesses in WhatsApp, right? People used to run businesses on Instagram. This become even much more stronger during the COVID time. So these are the times that we should reflect back and think that evolution in tech perspective and also in the thought perspective. Why this is very important? Because in 2013, I remember when I wanted to copy a movie. Okay, so I used to have a hard disk, but some of the guys, you guys can think this as an example. Some of you guys, you might not even have a pen drive at that time, and at that time, like whenever you wanted to copy a movie, you might be having a friend who might be downloading this movie. At that friend who will be download who I mean, in our friend circle in 2013, there might be like only one person who will be having this broadband connection, that to some limited connection. So he might be downloading these movies. We will have to rent a scooter or a bike. We might not have that bike because we were poor, like everyone else. So we used to rent the bike. We used to rent a pen drive. Then go there. We will have to ask that friend. Before going there, we will have to confirm with this friend, bro, are you available over there? So once I come over there, I can copy this movie, come back to my home. I can copy this movie into my computer. Then I have to return this pen drive back to other people. Right. So, but with internet, what got revolutionized, guys? Right now, whenever you wanted to watch a movie, okay, let's say you are still using the illegal way. You might be still downloading the movie from a Telegram. You are not even bothered about like the high quality print that you're downloading because the internet is so cheap right now. And if you want to share a file with some other person, you don't even have to ask that person that whether bro you are available over there. You can just upload the file in a drive. You can share the link to the other person so the other person can download the file from the link. So what are the benefits of using networking? Your time is saved, your net resources is saved, your cost is actually saved. So whenever you're seeing about like what are the advantages of networking, you should be thinking in this perspective. So whenever you are learning a course, whenever you are learning a topic, you should understand like why this course or why this particular topic, why this particular terminology or why this particular protocol is very important to me. You should be relating it with the real life problem, and all of this problem, all of these protocols, all of these methods that we are going to learn, it's actually developed to solve a particular problem. Okay, first you have to understand what was the problem, how we were solving that problem in SDLC, in software development life cycle. First time, like when you are having a problem, you'll be identifying that problem. Once you identify the problem, you will be doing a dry run. Once you do a dry run, you will be trying to optimize your code. Once you optimize your code, you will be implementing it. Once you implementing it, you will be getting the feedback from the user. Once you get the feedback from the user, again you will be innovating, right? So like that, we had like so many networking devices. We are going to discuss about those devices. So initially we had a device that was known as hub. That was we were used to connect network using hub, and people thought that like yep, hub initially facilitated all our basic requirements. But when the network began to scale, it became a problem because it was primarily broadcasting the message. So which was reducing the network efficiency. Then we developed a new device that is known as switch. Then switch was limited to the local area network, so we wanted a new device which we wanted to communicate to outside network. So we developed a networking devices that is known as router. And to understand these devices, to understand all other terminal, to communicate with all the devices, we need an address. So we use IP addressing. So like this, you will have to understand scenario wise what is the problem that we are facing and how we are solving this with a particular thing. Then you can easily understand this course. That's all I have to say. That's a short story. So if you have similar experience, now you can share it with me. So today we'll discuss about Cisco. What is Cisco, guys? Cisco is one of the company who manufacture networking device. What is networking device? So networking devices are the device which we are using to facilitate network communications. Like the Wi-Fi router that we are using, that is a networking device. Okay, we have a lot to talk about that device, Wi-Fi router. That is based. Yep, we'll discuss that. So that is a networking device. Then we have switch router. So in the next day when you're coming, all of you guys will have to find out at least 5 to 10 networking devices. The second assignment that you have is you will also have to find out what are the other manufacturers. So Cisco is one of the manufacturer. Okay, Cisco is not the only manufacturer. That is a second thing that you need to understand. What are the other manufacturers who manufacture networking device? And find out at least 4 to 5 of other manufacturers. Make a definition for networking. What is networking? You can browse as many websites as you want, but when you're writing that definition down, this is for your personal note collection. So when you're writing that definition down, you should be having a clear understanding that you're not actually plagiarizing. This is something from your own understanding that you are sharing or writing it down. So that's the assignment. That's a good. So if any doubts regarding the assignments, you can ask. Or else I'm done from my side. So any questions you have,
Yes,
you can ask.
the
Yes.
last sentence, the last statement, I didn't get it. You said we should find out about network devices, at least 5. And since Cisco is not the only manufacturer of network devices, we should also
Yeah.
find out other manufacturers of network devices. But the last
Yeah.
statement, I didn't get you. So
You need to find out 5 to 10 networking devices. That is first assignment. Second assignment is you need to find out other manufacturers except from Cisco. There are other manufacturers like HP. They manufacture Ariba devices. Then there is Juniper. Then there are other devices. You need to find out who are the other manufacturers who manufacture similar networking devices. Then the third assignment is you need to write down a definition for what is networking. And this definition should be from your own understanding. It should not be plagiarized from one website or from one book. They should be from your own understanding. Before that, you can refer as many materials you want, but when you write that definition down in your notes, they should be from your own understanding. Is it clear now?
yes, sir.
Yeah. And guys, until and unless you tell me that you need any specific help from my side, I won't be able to understand it since we are having like more people over here. So I might not be able to understand your requirements also at the same time. Since this is not school, I won't be asking whether you have completed it individually. I will be asking in generally what is the 5 networking device or 10 networking device, guys. Please put it in the chat. And I will be asking those things. So I won't be coming and checking your assignments. This is not school, and I don't want to be the person who is pushing you. So you also have to take a little bit ownership from your side, and then I'm there with you. So before asking me a doubt, you should first try to troubleshoot from your side. And once you troubleshoot it from your side, and you did all the scenarios that I told you to do, then you can reach out to me. Then I'll be helping you. But the first step should be always from your side. We'll be doing this practicals. So guys, about the practical part, we are doing this practical on a software that is known as Cisco Packet Tracer. So I'll be sharing the software with you. You can download it from the Cisco's website itself. So in the Netcad, you can also sign in from Netcad and download it. So you will have to register for one course and you will have to download it. So once you download the Cisco Packet Tracer, the main advantage is that on the conventional CCNA training institute, you will see networking devices, but they will be having some older version of some networking devices. They might be outsourcing from some production, and those devices might not even be working properly also. So what is the advantage of using Packet Tracer? You can use all the devices that are manufactured by Cisco. You can use multiple switches, multiple routers, and you can also have something that is known as simulation. Okay, so even in fact, I'll just show you some example using this. Okay, this is basically a router which is connecting to two local area networks. We haven't discussed. I'm just explaining the software that we are using to do the practicals. So whenever I'm sending a packet from this network to this network, I hope the IP configurations are already there. So what happens is you can see what are the type of protocols that are involving. In real devices, you won't even see what are the type of protocols. You will just see whether you are able to ping or not. So first you see there is an R packet that is traveling to the network, and once the packet reaches the default gateway is responding back with the R response. And right now we are sending the ICMP packet. Once we send the ICMP packet, we also need to find the second network's address. So we are again, the router is acting as a proxy, and the router is sending this packet, and router now identifies what is the MAC address of the destination device. So we can send the ICMP packet. In simulation, we face few glitches, but you can see now that we have understood the destination device MAC address, we can easily send this packet to the default gateway. So once you open this packet itself, you will understand where are you sending the packet. You can see the ping process starts a ping request. You will see a lot of information which will be helpful for you to understand this course. And you can see the packet reached default gateway. Now they check the routing table. This is a directly connected route. The packet is finally reaching the destination device. Now there are no broadcast packet. It is all unicast packets. You can see the type of packet also involving and the type of communication, whether it's broadcast, unicast, multicast. All those information also you'll be able to see in Packet Tracer. Once you start with Packet Tracer, after you have a basic understanding, you can jump to GNS3, but I wouldn't recommend that. If you have good RAM, for doing this software, you will have to have 4 GB of RAM. I have mentioned the syllabus, and the syllabus is changed. You can check it on the website. Some automation concepts are here, and the official certification guide. And for the people who want Toot Lamble's textbook, please download it from torrent, guys. You can do it. For LiveGen, you will find all those books. And if I have that collection with me, I'll be sharing with you. But just in case if you're not able to get it, I'll add those from my side. Any other question, guys? For the people like who are good, you can slowly leave. And people like who have questions, you can stay back. Hi, guys. Welcome to today's session. So I've given a few assignments from the last class regarding. I asked you to find out like 5 different vendors who manufacture networking devices. Did you find any? Can you please comment that in the chat if you find any?
Sir, D-Link, TP-Link,
D-Link, TP-Link.
manufacturers.
Okay. Manufacturer, Juniper, Network, Cisco, HP, TP-Link, D-Link, Sophos, Aruba. Yeah. AT&T. Yeah. Yeah. So you're right. Any other answers? Only 2 people did it. Sukrit, Ashwin, and Nisa. Okay. And who was ans? Okay. And when you check this assignment, did you check like what are the devices that they manufacture? It's not very important, but just in case if you guys were curious, did you check what these companies are manufacturing?
Yes, sir.
Yes, sir. But exactly no, but we cross-checked that some of companies are making cables and some are routers and switches, different perspective like that.
Okay. Yep, you're right. Some of them are making cables, some of them are making devices. And in today's agenda, what we are going to discuss in detail is we are going to discuss why these devices are manufactured and what are the main importance of this devices. And last assignment, uh, did you find out like any technical definition? I asked you to give a note to find out what is networking, to come up with a definition, and this definition should be yourself. Do you need anything like that? Just giving a heads up. Till 9:05. So until 9:05, we'll just revise like what are the previous day's topic all day, because until 9:05 you have time to join. Exactly at 9:05, I will start the session on all days. Let me check how many of you guys are there. All right. Cisco dealing Juniper, Netgear, Arista. Yeah. Networking is when two or more people or two or more devices connect to exchange data. That is a good definition, Grace. Juniper, Fortinet, why? So, yep. It's good to see that you guys are doing the basic research. So happy about that. 37. So that was the last count on the last day. So I'm going to start now. Network can be local like home or office, or global like internet. That is one definition. But the main purpose, like when I'm saying something like this, it's to encapsulate like whole meaning of what networking is. Okay, we'll just see one definition, but please don't plagiarize this definition. You should come up with yourself. Okay, so what is a computer network? So computer network is a system that connects numerous independent computers in order to share information, that is basically data or resources. So when two people are also connecting, when two people are connecting, like you guys might be connecting over a phone, even that is a network. So when you're connecting, what are you basically sharing? You're basically sharing and exchanging information. So a computer network, in the specific context we are discussing about computer network, a computer network is a system that connects numerous independent computers in order to share information resources. Okay, so you can see there are different people in department A and department B. Okay, suppose if I want to send an information from department A to department B, I need to use some kind of devices, right? Or cables, for that matter, right? If I have to send information from this person from department A to this person in department B, I will have to use some types of cables or some type of networking devices. Even if I'm using devices, I will still have to use some type of cables. But the problem with, since some of you guys already told that you guys are absolutely beginners, so there is something that is connected in the backside of your system that is known as NIC card. So that is basically network interface card. So in this network interface card, this is basically where you'll be connecting your LAN cable. Like so you'll be connecting the internet in this LAN cable. So this is known as your Ethernet port or network interface card. So normally on one computer, you will be having one Ethernet port. So we'll just discuss the scenario back again. So if this person wants to communicate to this person, you can directly connect with a cable. But there is a problem. If this person wants to connect to this person in department B, either you will have to add more ports, network interfaces cards, but that is not something which is scalable, because depending on the number of system, you will have to add that many number of ports, which might not be able to scale in that particular matter. So in that case, we will have to use a networking device. What is networking device? A networking device is a device which will help you to facilitate the networking communication. So we are going to discuss step by step. So the first networking device. So we'll take two computers now. Okay. So I'm taking two computers. In the first case, we will discuss. So we are not starting with IP addressing right now. So if you already know how IP addressing works, or if you have some experience, you can also configure this thing by yourself. Today, the main things that we are discussing in a practical way, we are discussing theoretical concept for you to understand. Once you understand, today and tomorrow, the main agenda will be networking devices, then OSI model. So after discussing OSI model, you will know what is OSI model in few minutes. After OSI model, we will discuss IP addressing. Then we are starting with the practicals. So if you don't know how IP addressing works, how to assign IP address, it's completely okay. But if you're still curious to do this particular lab, you can just practice, do the same things that I'm doing over here. Double click, go to physical, then you can see desktop. Don't go to physical, directly click desktop over here. Then you can see something that is known as IP configuration. So if you are not so familiar with IP addressing, you can please note down this address, network address. This network address, this is my favorite network address, which we will be using throughout this class. This is known as 192.168.10.0/24. This is our network address, which means, so every devices which is operating in the network, you already know we need an IP addressing. So using this network address, I have IP address from 192.168.10.12. So the next network address I have is 192.168.10.2 up to 192.168.10.254 you can use. You also have one more address, IP address, that is 254, but you cannot assign it. We will discuss all those concepts in the IP addressing class. Okay, so let's use an IP which is of this range from 10.1 to 10.254. So you can use any value. So I'm just using 192.168.10.1. So I'm just configuring one PC over here. With this PC, I'm going to assign one IP address. So I assign my IP, close it, will come back. Again, I am assigning. So statically, we are assigning this IP address, that is 192.168.10.2. Okay. So I'll just introduce you to one command now. Grace, where are you lost? Okay, this is the lab side, which I'll explain. If you install this particular software, we can discuss it. So after this class, we can discuss about how we log into this particular software. So basically, when you use the software, you can just double click on Cisco Packet Tracer. You will be logged in. So once you are in Cisco Packet Tracer, you will see all the networking devices that we are going to use for this practicals. So the first option that you see over here on the top, that is network device. Next to network device, you will see end devices. End devices are the devices like PC, printers, tablets. So I have taken two PC from there. That's it. Grace, I hope it's clear now. Can you please confirm?
Yes.
Yeah. Now I'm just simply using a cable. So there are some of you guys already told in this class, some of the networking companies, they manufacture networking devices. So some of the companies, they manufacture cables. For this class, we are not discussing all the cables. So as you know, you need to physically connect these devices with a cable for communication to make this in a network. So I'm just using, if you simply use this lightning symbol, this is the first lightning symbol, this will automatically select. For different type of networking devices, we are using different types of cables. The second cable that you see is a console cable, then copper straight, crossover. So for different type of networking devices, we are using different types of cables. Now, for the sake of understanding, if you press on this lightning symbol, it will automatically choose the best cable for this. So basically, we are using fast Ethernet cables. Okay, so if you want a specific answer, so I've connected this with the fast Ethernet cable. So how do I make sure that I have connectivity to first device to second device? I can simply use a command that is known as ping. So basically, we used to say back in the days we were using Facebook, we used to say that Facebook ping was ping or poke, something was there. I don't remember exactly what was that, but something similar was there. So if you ping, basically in general English, if you ping, that is just checking whether the other person is available. So people used to say, no, let ping me and see if I'm available. So you're using a ping test. So when you're pinging the destination IP. What is the destination here? So this device, it's 10.1. The IP is 192.168.10.1. This PC's IP is 192.168.10.1. And this PC's IP is 192.168.10.2. Okay, these two are two IPs that we are using. So I'm just checking whether I have connectivity to 10.2. Okay, so I'm just pinging on that IP 192.168.10.2. You're basically getting a reply, which means I have connectivity. I sent around 4 packets here. You can see the response. I received 4 packets. There is 0% lost, which means I have communication. So this is a command which also you can use if you type on your CMD. You can just try your ping command. Like you can ping google.com and see whether you are able to ping. You are getting reply, which means you have connectivity to the internet. Or ping the best available DNS over here. We are pinging 8.8.8.8. That is an IP, which means you are in having internet and you are connecting to the nearest DNS server. Okay. So right now you understood that. So this is a small network right now, right? So the next example that I'm going to tell you is I'm going to scale up my network. So initially there was only 2 devices. So on the third device, if I want to assign one IP, what is the best IP that I should be using here? Can any of you guys comment it?
It's a 192.168.10.3.
Exactly. Who answered it? Who gave the answer?
Rita.
Okay. Thank you, Rita. That's the right answer. So you can use any IP, but this is the best IP that we can use. So 192.168.10.3. Okay, before moving further, let me just see my own is not working, but we can troubleshoot it later. Yeah, sure. And I am also adding one more device over here. So the next IP that we can use here is like 10.1, 2, 3, and 4. So 192.168.10.4. Okay. So as you know, if I want to connect to this PC, either I should be connecting like this or this, because if I again, if you check to connect, like I told, this device only has one network interface card. So we click on this device and press here, this cable cannot be connected to that particular port. You will get error message. Okay, so now we are actually doing our introduction to this course, that is networking device. So networking device is a device which will help you to connect to a network. Okay, which is a dedicated networking device which will help you to connect to a device. So I'm just reorganizing this device. So I have 4 PCs here. So the first networking device, as per as our syllabus that we have to discuss, is we will have to go step by step. So that is known as, one second, yeah, that is known as hub. Okay, this device is known as hub.
It is looking like bus topology.
It's looking like bus topology. Not exactly, but since it's single broadcast domain, you can say, but this might be either best suited with star rather than bus. Okay, so now I'm using a hub. Okay, so now if I have to check whether I have connectivity, so here this is the main advantage of using Packet Tracer. This is why I told all your labs should be done. No, repeaters we are not using in any production, and we don't have to discuss that. Okay, so we are going to check whether we have connectivity to the next device. So that is 10.3. So in the simulation model, you can actually see how the packet is also traveling. Okay. You can see a packet is created from this PC. It is coming to hub. Hub is basically sending this message. The message is coming back. It's going to all the devices. And you can see the message is coming. So you are basically communicating to 10.3 and you're getting the messages. 10.4 also if you're connecting using the hub. So this networking device has facilitated you to communicate to all the devices. Right. Now we will have to discuss this device much further. But before that, we have to discuss few theoretical concepts. Okay. So all the networking devices, some of you guys already do this research when I told you to find out what are the few networking devices that we use. You guys already found out that hub, routers, switch, firewalls, access points. You guys have listed so many devices at the beginning of the session, right? You can see D-Link, Juniper, Netgear. Okay, so all these networking devices, they belong to different levels in OSI model. Okay, so different levels as in like we are in OSI we call 7-layer architecture. 7-layer architecture as in just to understand the fact that so today is not the OSI model class, it's a dedicated 2-3 hour session that we are discussing. Today we are just introducing what is OSI model. Why do we need an OSI model is because in today we are going to discuss networking devices. So all the networking devices that we are going to discuss, it belongs to different layers of the OSI model. In OSI model, we have application, presentation, session, transport, network, data, and physical. So I'm just going to summarize what is OSI model in general. What is application layer? So I'm just going to use a simple example. When two people are texting a messages via WhatsApp. Okay, so when you are sending a message via WhatsApp, you will be typing the message where in the application layer. So application layer is just a layer where you see the data, view the data, process the data. Okay, so presentation layer is a layer. Since the data is traveling inside the network to multiple places, the data need to be encrypted and to be presentable. Because the different system they're using different type of file format. So in presentation layer, actually in presentation layer, the encryption and decryption happens and data conversion happens. In the next layer, we have session where we are basically establishing a session between the end user. In transport layer, we'll be just seeing what type of protocols you need to use to transport the data. So here we have the two major protocols like TCP and UDP. And all the things that we are going to discuss further comes in the lower layers that are known as the network, data, and physical layer. Okay, so these are the devices that we are going to discuss. So network layer is a layer which is responsible to forward packet when it belongs to different network. For example, so if there are like multiple networks means in IP addressing comes in this layer that is known as network layer, and MAC address that is known as the physical address which we are going to discuss that comes in data link layer. And also physical layer, we don't have any type of addressing where we have cables. So in the first topology that we discussed, we were basically using physical layer. And there are basically three layers: network, data, and physical. So network layer is responsible when we are sending data using like multiple networks. Network layer is responsible, and we use a dedicated device that is known as router. In data link layer, you have a device that is known as switch. Switch will send and forward information based on something that is known as MAC address. MAC address is known as the physical address of a device. So there are two type of, okay, how many of you guys don't know what is MAC address?
Physical address of devices.
Yeah. The question was, how many of you guys don't know? In all network interface card, so there is something that is known as a physical address and IP address. So the physical address, which will be known as the burned it address. So this is an address you cannot change. It is written in hexadecimal. So this is a 48-byte value. Okay, so when a computer is manufactured, so here I have multiple MAC address because I'm using like multiple VMs, also multiple network interfaces cards are running on the system. So you'll see multiple MAC addresses. So when a device is manufacturing, the manufacturer will locate a certain type of address that is known as, this course was started at 9. Okay, reducing the speed. So when you're buying a laptop, you will be getting an number that is known as MAC address number. So that is also known as the burned in number. So the burned in value that will be known as a physical address. And whenever you are connecting to the internet, you will be using a different type of address that is known as IP address. So in a computer, you will be using two type of addressing. One is logical address and one is physical address. Logical address is IP address. Physical address is a MAC address. Okay. Now, logical address is what? The IP address. Physical address is a MAC address. Now, guys, please pay attention. So this MAC addressing is an address which comes in data link layer, and physical address, in physical layer you don't have any type of addresses. MAC. So MAC address is a physical address assigned to a device when it is named, also known as the burned-in address. It's globally unique. So the first 3 bytes AVE, that is the organization unique identifier, which is assigned to a company when the device is manufactured. So looking at the first 3 bytes, you can understand who manufactured the device, whether it's Cisco, whether it's Juniper, whether any other manufacturer manufactured it. You can understand by the first 3 bytes. The last 3 bytes are unique to the device itself, written in hexadecimal characters. So you can simply check this here. Okay, so this is, so basically right now I'm connected to Wi-Fi. So I'll be showing the MAC address of this device. So basically we are using two type of addressing. One is logical addressing and one is physical addressing. This is a physical address. This is known as the MAC address. And we are also using one logical address, that is the IP address. So these two addresses are needed when you are inside a network. I hope it's clear now. Any questions? Guys, is it clear?
Yes, sir.
Okay. 1 second. You will understand this further even if you have doubt once we discuss the networking device. So this is just to give an overview, a heads up. Okay, so now we are going to discuss different type of messages that are being sent. Okay, so these messages are known as unicast, multicast, broadcast, and anycast. Okay, unicast is when a one-to-one message is happening. So when somebody is sending you an email, that is basically unicast message because there is a sender, there is a receiver. Okay, so there is a sender, there is a receiver. Here, okay, this is hub. It cannot. I'll just demonstrate the labs later. So unicast is one-to-one communication, which means one person is communicating to other person and the other person is communicating directly back to the same person. And multicast is a communication, which means two or more people are communicating at the same time. So in emails itself, you can see the same example because you will be adding CC, or whenever some important messages are happening, you might be forwarding that message to some other people. You can use example of WhatsApp when you're forwarding messages to multiple people. That is basically multicast messages because you're not sending that message to all the people in your contact. You are just selectively sending this message to few people. Broadcast is a communication, which means all the people are getting this message. All the people are receiving this message. This particular class right now, it's a broadcast message because all of you guys are listening. So when you're sending a message in your WhatsApp group, that is a broadcast message. So when you're sending a message to all the devices inside the network, that is known as broadcast communication. So anycast is a special type of communication. So that is, it's also communication to one, but it's a communication to the nearest one device. This, if you don't understand, if you're a beginner, we will discuss this after some time, not in today's session, because if you are understanding like how route DNS works, how the DNS architecture works. So if you're using a cloud-based service or an edge computing, so your data will be distributed to multiple parts across the world. So a person who is accessing the data, who wants to access the data from Mumbai, he will be directing the traffic to the nearest edge server which is possible to him, right? Or the nearest DNS server. If you're using Route 53, you might have observed this. So anycast is also a communication. It's a communication between the nearest one device. So what is unicast? It's communication between one-to-one. Broadcast is communication to all the devices. Multicast is one-to-many. Anycast is nearest one device. We'll see the examples in the practicals. Then there are different types of communication, which is known as the direction of data. One is known as simplex. Simplex means the data can only travel to one side. One side as in when you're typing a message in your keyboard, the data is going to your computer. Are you getting any data back? No. Right. When you're using mouse, the data is going inside. Whether you're getting any data back to the device? No. So that is an example of simplex communication. Half duplex is a type of communication where you can send and receive data, but one at a time. You can send and receive data one at a time. So if two people try to communicate at the same time, collision will happen. Note this point. If two people try to communicate at the same time, collision will happen. Example is walkie-talkie. So when somebody is speaking at the walkie-talkie, so you might have heard this in movies. So the other person is when the speaker is saying over, then only the other person will start responding. If two people communicate at the same time, collision will happen and the data will be lost. And in today's scenario, the 99% of the network that we are using is full duplex, which means communication can send in both ways. It's like a it's like an NH road. Like there's a particular way for incoming traffic and outgoing traffic. So both communication will happen at the same time. For example, your mobile phone, this particular communication that we are having, that is full duplex. So all the type of communication that we use in today's scenario, that is mostly in full duplex, unless you configure some of the interfaces in half duplex, it is always in full duplex. Now we are going to go back and discuss networking devices. If you have any doubts on this, we will discuss at the end of the session. Why? Because once we discuss networking device, you will easily understand what we discussed so far. And we will summarize this at the end of the session again. So just in case if you don't catch up, we'll catch it up again. Okay. So the first networking device that we use, this device is known as hub. Okay. So it operates in layer 1 of Wi-Fi model. What is layer 1, guys? Layer 1 is
Physical layer.
Layer 1 is the physical layer of the Wi-Fi model, where we don't use any type of addresses. In data link layer, we use the physical address, that is the MAC address. In network layer, we use IP addressing. So in network, IP addressing only comes in network layer. MAC address only comes in data link layer. And there is no addresses which happens on the physical layer. Since there are no addresses which we are using, okay, when I am sending a message to, please observe this, when I'm sending a message from PC1 to PC3, you can see this is a standard message header, that is the ICMP packet. So we are sending a message from PC1 to PC3. So if you open this packet, you can see different details are given. So we are sending a data from 10.1 PC to 10.4 PC. So, but this device is not using any type of addressing. So this device by default, it does not have the capabilities to understand who is 10.3. Then how will this device send this message to 10.3? So it used this communication that is known as broadcast. Now, can you tell me what is broadcast? One to
Many,
Many.
device.
many.
Like
One to
all.
all, not many, one to all devices.
One to all. Yeah.
Okay, so the communication is coming to hub. So why hub is using broadcast? Because hub is operating in physical layer and hub cannot understand any type of addressing like IP or MAC. They cannot understand it. So they use this method that is known as broadcast. Now the broadcast message is received to all the devices. Okay, now what happens is, except the legit device that is 10.4, all other devices, they are going to drop the packet. And again, this device, they are going to send a response message. And in this response message, it was mentioned the destination IP is 10.1. But since the device don't know which device is 10.1, they basically broadcasted the message to all the devices. Right now, can you tell me, did you understand what is broadcast message? And did you understood what is broadcast message from this example?
Yes, sir.
Yes, yes.
Yes, sir.
Okay, it's one to all the devices.
All, yes.
Now, can you tell me why Hub broadcasted this message?
Because
It operates on which layer?
what MAC address or IP address?
Exactly. It operates in physical layer. It is not aware about MAC addressing or IP addressing. So when we send the packet, we mentioned all the details like what is a MAC address, what is IP address. So if you look here in the packet, you can see the IP address was mentioned. The IP address was 10.1. You can see the MAC address was also mentioned here. Okay, the layer 2 addresses were mentioned. The source MAC address, destination MAC address was mentioned, but they were not understanding it. Now we'll discuss the theory for this. Hub operates in the physical layer of voice and Hub cannot filter data. It is not an intelligent device. Okay, so it sends message to all the ports. It primarily broadcasts messages, so the collision domain of all nodes connected through hub state nodes. Transmission domain is half duplex. Transmission domain is half duplex means only one person is
Sender and receiver, yes.
communicate at the same time. Sharon, you draw something on my screen now. 1 second. So we were discussing about hub. Hub operates in physical layer of OSI model. Hub cannot filter data. It is not an intelligent network device. It primarily broadcasts the message. Transmission to mode is half duplex. We'll discuss what are the other points. So collision domain means what is basically a domain? Domain is basically a network where you have the maximum area. So collision domain of hub means so if it is one by default, which means all the if two people are trying to communicate at the same time, collision will happen. If two people are trying to communicate at the same time, collision will happen. Okay, 1 second. You can see the packet reached two packet reached hub at the same time. Can you see a burning symbol over here? This is known as a collision. Graphically, they tried to implement this here, but this is basically the collision, guys. And the data will be lost. When two people are trying to communicate, collision will happen and the data will be lost. And it's half duplex, which means only one person can communicate at the same time. Okay. Now, a general question.
Can you repeat again?
So when two people are trying to communicate at the same time, it's a half duplex, right? What is half duplex? You can send and receive data, but if two people are trying to communicate at the same time, collision will happen. It's like when you're traveling in a service road. If two heavy vehicles are coming in the opposite direction, collision will happen, right? None of the vehicles will be able to pass, right? Understanding?
Yes, sir.
Yes. Yes.
Yes, yes,
So
sir.
like that, if you are sending messages from multiple devices, and if multiple packets are communicating at the same time, the two packets reached hub at the same time. Okay, so the collision domain of hub is by default 1. Okay, now if they try to communicate it like this, collision will happen and they won't be able to send or receive data. You can see even the packet data was actually lost because of collision. So collision means when two people are trying to communicate at the same time, if it's half duplex or the collision will happen. So this is a drawback to hub. Okay, before discussing further drawbacks, the major drawback was it primarily broadcasts the message. Can you tell me what is a drawback to it? If the messages are broadcasted, what is the major drawback to it?
The message we get to people who don't need the message and no privacy.
Good example, privacy.
No privacy. Yeah.
Will not get the destination the
Okay.
Now, traffic, so heavy traffic.
Heavy
It
traffic.
shows
Very
hub
good
is a
example.
single source.
Okay. Okay. So the answer is one of the answer that we need to discuss now is high data or heavy traffic. So when heavy traffic is coming, so for example, imagine guys, if there are like 500 devices inside the network. Okay. I'm just going to duplicate this network. Okay. So if this is just a demonstration. So we are connected to these devices also. Okay, so now when we are trying to send a message to this PC to this PC, actually first this message is broadcasted to the second hub. From there also the message is getting broadcasted to all the devices. So if there are 500 devices, if there are like 10,000 devices, this 10,000 devices will get the broadcast message. The other persons, they will come to understand that this person has tried to make a communication to this device. Privacy is a very good point. The second point is that high bandwidth or high traffic. So what is the drawback to it? So the ideal responsibility, this thing you have to keep in your mind. Okay, from now on you have to think like a network engineer. Okay, so network engineer, the major role is like, so some of you guys might be struggling with your budget, right? How to allocate your budget, monthly budget, properly. So the ideal network admin, like they also get the same problem like a finance minister to allocate the budget properly. So they won't get sufficient bandwidth. So within whatever bandwidth that they have, some of they will say this is the bandwidth. So upscaling the network won't be an easy task. So within the resources that they have to optimize this network. So each of this broadcast message, it is going to consume traffic. The traffic is going to consume from where? Our own network, which is not an ideal thing, which is going to reduce the performance of the network, which will bring down the network eventually. So broadcast is not something that is good to us, or the maximum ways we should be avoiding broadcast traffic. I hope hub is clear. So if hub is clear, can I move to the next device? Any questions on hub?
No, sir.
Yes,
Yes,
sir.
sir.
No, sir.
Okay, if you have questions, please shoot now.
No, sir.
It will be better if you could post that in chat, but if you can't, please unmute and ask first. By the time I make the other topology. Broadcast domain is one means, okay, but now you can understand that broadcast domain is the extent where a layer 2 packet can reach. Broadcast domain is an extent where a layer 2 packet can reach. Okay, so which means this basically all the packets, since there are no routers which are involved, so this basically happens in the layer 2 communication. So all the devices, they receive the messages, right? All the devices, they receive the messages. So the broadcast domain is one. So once Rita will come back and discuss your doubt. I hope it's Rita. Who's it? Yeah, I'll come back and discuss your doubt once we discuss the router. I'll have to, it's better that we discuss things practically so we'll understand. Now, the next device that we are going to discuss is, so this was in the early days of networking, right? Okay, before that, there were repeaters, which is something we are avoiding, and we don't have to discuss also. Now, we are going to discuss the next device. So this is the most common device that we are using right now. So why we discuss hub is because we need to discuss what is broadcast domain and also what are the major drawbacks of hub. So that is the reason the new networking technology that came into the picture, that is known as switch. Okay, so delete it. Now we are going to connect the device with the switch. Okay, so now when you're communicating something with switch, you can clearly see this. The messages that are communicated via switch, it is going. What type of communication is this? Unicast, multicast, broadcast, anycast?
This is unicast.
This is
Unicast.
unicast, one-to-one communication. So we are
Sir,
communicating.
unicast.
Yeah, so this is coming. We are communicating from 10.1 to 10.3, and okay, so okay, what type of communication just happened right now? That was broadcast. That is STP packets. Okay, so I'll just remove those packets. Yeah, I'll demonstrate it one more time. So the packet came to the switch. The switch is communicating directly to the destination device. The destination device is directly communicating to the source device. And also, I just avoided that broadcast packet. So all you have to understand that in a networking devices, different types of traffic will be there. Yeah, actually you're right. Now, the major thing about switches, the switch operates in layer 2 of OSI model. In layer 2, what type of addresses we use?
MAC
Address.
Address.
IP
MAC address or IP address.
Only
Personal
MAC
one.
address.
physical address
Only
and
MAC address.
logical.
Only
MAC
MAC
address.
address we'll be using in layer 2. IP address comes in layer 3. Okay. The only
Okay.
address that we use here is MAC address. Okay, so each of the device, like I showed in my device, each of the device they'll be having a physical, they'll be having a physical address. So if you look here, you can see the MAC address of this device. So all the devices they'll be using one MAC address, that is known as a physical address, and one logical address. So this address we'll be using here. Okay, so if you check this 496B, that is a MAC address. So in the packet, if you check, you will see the same MAC address in the source. E256. E2, yeah, you can see E256. This is the source, and the destination device's MAC address also will be mentioned there. Config faster than net. You can see the destination device MAC address will be also mentioned in that packet. So this is the addresses that we use mainly by switch, because this is a layer 2 communication. This is inside local area network, that is known as LAN. Okay, so switch operates in which layer? Layer 2. In layer 2, what is addresses that we use? We use this address,
MAC address only.
MAC
MAC
address.
address only.
So when we tell switch that I want to communicate to this particular MAC address, how does switch understand where this address is located? Or how, okay, in switch, we, as you can see, switch is a device. Okay, since this is an online class, I need to show you how switch is looking, so none of you guys will confuse. Switch is a device which will look something like this. It will have like ports depending on your particular need. So inside this port, you will be connecting the end devices. This is where you will be connecting all your end devices. Okay. Now, all the ports are labeled here. So remember, when you start working in production, so whatever port that is connected to the end device, always you should start labeling that device. Okay. Now, coming back to the actual scenario, all the ports, they'll be having different ports. You can see 0/1, 0/2, up to 24 fast. Not n number, 24 ports are there, fast Ethernet. And gigabyte 0/1 and 0/2, 2 gigabyte ports are also there. Okay, so depending on the models of the switch that we are using, or different types of ports will be there. So all the ports are allocated with, you can see in Packet Tracer, always you will see F0/4, F0/3. This is indicating the port. So now pay attention when a traffic is coming from 10.1. So 10.1 PC is connected to which port? F0/2. F0/2. When the traffic is coming from F0/2, switch is directly sending the traffic to F0/4. How does switch understand this? This PC is connected to F0/4. This is by a process that is maintained by switch, that is known as switch maintains a table. The table is known as MAC address table. So if you want to see the table, you can simply type the command show MAC address table. So what was the destination MAC address we were looking for? The destination MAC address was 007 EC829AC1, right? So when we check inside it, it is connected to, what was the MAC address space? 9AC1. Okay, 9AC1. Yeah, 9AC1. This is connected to which port? So right now when the switch is checking, this is the MAC address. Switch understand that, okay, I know this device, this is connected to my F0/4 port. I can directly send the message. Is it clear up to now what I discussed?
Yes, sir.
Yes, sir.
All of you. All of you.
But why not
So I am going to discuss a
going
little
to
more
another
challenging
devices?
topic. Okay. What was it? What was the last message? I didn't hear you properly. Yeah. If you understand this, I'm going to discuss something that is little more challenging. That is how switch learns this MAC address. MAC address is dynamic because it learns this MAC address dynamically. That is also we are going to learn. Rita, you can pay attention. Now, by default, one second. Yeah. So by default, okay, guys, this is something which can be little challenging to you, but if you pay attention, it's just a piece of cake. So please try to put your concentration here. So when switch is communicating initially from 10.1 to 10.3, as you know that switch by default, right now, if switch is checking this MAC address, okay, one more time. One more time. So initially, when I'm sending a message to 10.1 to this PC 10.4, switch is not aware about the MAC address. Okay, it just so that switch does not have any idea about the MAC address table. So right now, the first packet reached switch. We call switch as an intelligent device. Okay. So right now, if you check how many MAC address switch is aware only about one MAC address. That is from PC0. Okay, switch immediately learned that MAC address, and right now switch is going to broadcast this message. Why? Because the MAC address table was not present there. Okay, right now again, if you check, switch is still aware about only one MAC address, that is of 10.0/2. So right now the message is coming back. But when the message is going back, you can observe this is going as a unicast message, because in the reply packet, we mentioned the MAC address of, this is the MAC address that we are looking. This MAC address is already where? This MAC address is already in F0/2. And if you check the MAC address right now, so switch immediately learn once a packet come back from F0/4, switch learn that MAC address right now. Switch is very adaptive and they learn this dynamically, right? So you can configure MAC address in two ways. Either you can statically configure it, but in 90% of the scenarios, all the configurations will be dynamically. Okay. And the communication reached to 10.1. And right now, from the next message, you can see the next message is coming. The next message, it's going to be a unicast message. Okay, that is an error. That is a glitch, software glitch. The next message you can see now when you're communicating with it, 10.1 to this PC, it is directly communicating because switch learn that MAC address. So all you have to understand is that switch will learn MAC address only once the packet hits the particular interface. Only then switch is going to learn the MAC address.
So before that, it will check the MAC address table, right?
What? Hello, I didn't understand your question.
But it will check the MAC address before sending any message.
Yeah, before sending the message, it will check the MAC address.
In the
So
table,
you can
okay.
see, yeah, you can see. So the packet is coming from PC. So right now they won't check because the packet is not in the switch yet. So once the packet is coming in the switch, the first operation switch is going to perform, switch will check, do I know the MAC address of device which is connected on my port, which is F0/2. If not, I'm going to learn it. Okay, then switch will start processing the packet. Once switch start to process the packet, there is a destination MAC address that is mentioned, that is 9AC1. Switch will check, okay, do I have this MAC stable? Do I have this information inside my MAC address table? If, then I'm going to forward the packet directly to that device. Understood?
So it will
Clear?
check the destination MAC address.
Yeah,
Yeah.
in the MAC address table.
Yeah.
Guys, is it clear?
So it's types of unicast.
What?
The communication says it's unicast or
Yeah.
broadcast.
You tell me.
I think it's unicast, sir.
Yeah, unicast. You're right.
Hi, John.
Guys, just give me 2 minutes. For the people who already understood, they can leave after I summarize these points. So before that, for the people like who already have got an idea, they can just we'll just discuss the theory topic. Guys, all my classes, it will be completely practical oriented explanation. I won't be using PPTs much. So the explanation that we are doing in our class, it will be completely practical only. Like we will open the console, we will perform the operation, then we will start explaining rather than simply reading PPTs. So after that, once I explain practically, I will just summarize these topics. Switch operates in layer 2, that is data link layer of the Wi-Fi model. It uses MAC address to send packets to a selected destination port. Transmission mode is full duplex, which means two people can communicate at the same time. Due to this, collision do not occur. That is all for today. For the people who already understood, you can slowly leave. And for the people who have doubts, you can stay by. So ideally the class should end by 10. So that's the reason I ended. I'm not taking any more topics. Right now, I'm starting to clear the doubts for the people who have it. Yeah, in the MAC address table, we'll store in destination MAC. MAC address table is not stored based on the source address or the destination address. MAC address table is maintained on the basis of what is the MAC address on my particular port. When a traffic is coming to switch's port, switch will check, do I have that MAC address? So it is not storing the information based on, let me complete it. So when I'm sending a message from this PC to this PC, immediately before that, you only have the MAC address of this devices. So once the packet is coming to the switch, okay, that was not the communication I tried to initiate. Try to communicate between this PC to this PC. So once the packet is coming on the switch will immediately learn the MAC address on that particular port. But right now you'll see one more packet. Yeah, all the communication happened in a second. So right now you can see all the MAC addresses are there. So if you look at the MAC address table, switch does not maintain based on source and destination. Switch is going to check what is my port in F0/1. What is the MAC address of the device which is connected? In F0/2, what is the MAC address of the device which is connected? So when a packet is coming, when switch is opening the packet, in the packet, the source and destination address will be mentioned. If you open the packet, this is the packet which is created by the PC, not by the switch. So once switch operates this, when switch opens this packet, when switch sees this packet, switch will easily understand who is the source, who is the destination. If then switch will compare. Okay, so in the packet, this packet is created by whom? This packet is not created by switch, it is created by the PC. PC has already mentioned what is the source and destination. So switch is going to check, do I have the specific MAC address which is mentioned by this PC? If so, I'm going to send the packet to the destination device. MAC address is not unicast or multicast. MAC address is a type of address. Like IP address, it's a type of address that is known as a physical address. It's not unicast, multicast, or broadcast. It's a type of address that is known as a physical address. Guys, I hope the pacing of the class was okay. Do you have any feedback for the speed? Because I think we have to maintain at least the speed because we also have to cover the topics on the completed days.
Yeah,
And
the speed was okay.
yeah.
I just have a little problem with my Cisco Packet Tracker because I can't bring up device. I don't know why. Where do I need to do? What do I need to do for the devices to be activated? When I want to bring up it doesn't come up.
Guys, by the time I need to ask some quick questions to you. Okay. How many layers are there in OSI?
7 layers.
How many? You can comment the answer. You can. Okay. Yeah. There are 7 different layers in OSI model. Okay. Okay. Which layer hub works in OSI?
Physical layer.
Physical. Yep. Okay. And why do we call hub as a dumb device? Or what is the primary mode of communication which hub use? Broadcast. Yep. Hub use broadcast communication. And why does hub use broadcast communication rather than unicast communication? Why do hub broadcast message rather than sending unicast message? Anyone?
Because it just
Yeah,
doesn't understand the configurations.
It doesn't understand the concept of
IPs
IP
and MAC
address or logical address or physical address.
exactly because it doesn't know any type of addressing. It is, or in simple words, you can say it is operating in layer 1. In layer 1, there are no addresses or both IP and MAC addresses. And what is unicast communication, guys?
Node to node.
Node to node or one-to-one communication. Node to node. Both definitions are good. Okay. And what is multicast communication?
One to many.
One to many. And what is broadcast?
One to all.
One to all. Okay. Guys, you guys are doing excellent. The next question. Yep. Can you guys give me an example of simplex communication? What is simplex? The data will only travel to
line.
one direction. The data is only traveling in one direction. So, what is an example of simplex communication?
Yeah, walkie-talkie is the example.
No, walkie-talkie. It's half duplex. You can send and receive data, right?
Okay.
Simplex. The best example that you can take is your keyboard, your mouse. All those are best examples for simplex because you are typing message, but you are not getting any response back to the device, right? But in walkie-talkie, you can send and receive information. That is an example of half duplex. Half duplex means you can send and receive, but only one at a time. If 2 people try to communicate at the same time, collision will happen.
Yeah.
And full duplex, all the 90% of the communication that we are using today, that is in full duplex, which means you can send and receive data. So I'm not asking examples. Mobile phones, laptops, all the devices, switches, routers, all the devices that we discussed so far, they use this communication. And what is the address table which switch maintains? Yesterday we discussed in our session that switch maintains a certain type of table. Based on the table, switch forward the information. Right. So what is address table switch maintains? What is it called?
MAC address table.
MAC address table. The table is known as MAC address table. Okay. And can any of you guys volunteer to answer how switch learns MAC address?
Through incoming request. Node connection.
It cross-checks you with every node.
From port. Port connection.
My MAC address.
When we boot the switch, it will send the echo request to the user, and if
No,
it received,
not like that. Not like that. Are you planning to come up with something that is on the STP deep, or you're right?
Yes, yes.
Okay, just for the time sake, we are not discussing STP, but even then, if you are mentioning STP, there are a few errors in the way that you explained it. Okay, in simple words, I will just explain you. When you open a switch, there are no MAC address tables because right now there are no devices which are present in the device. So right now, if I check it, so I'm just fast forwarding this. So if you want to fast forward the process, you can press here this arrow button. So I'm getting into enable mode and show MAC address table. There are no details that are present. Okay. So right now I'm connecting to device. Guys, just connected to device right now. They are following through the STP cycle. We will discuss what is STP in the coming few weeks, but for the time being, you don't have to worry about it. But only have to worry about it like when you're operating on a device, you have to make sure that the interfaces are up, the switch ports are up. So once the switch boots up, it will take like few seconds. I just speeded it up, so it is in the forwarding state. Once it's in the forwarding state, all the interfaces that you will see over here, it is going to be in the green light. Okay, let me quickly assign an IP 192.168.10.1. Okay. So you can see the MAC address table that switch already learned the MAC address table. It is because, please understand, like Deep said, an STP was a protocol that was happening in place. Okay, for the time being, you just don't have to focus about STP, but you only need to understand that there are certain type of packets that are traveling. Okay, there are like background, so many protocols that are running in background to facilitate the working of the particular switch. Okay, but how does it learn? Okay, let's clear this process. So right now the STP is already complete, or any other protocols that took already completed. So I'm just going to clear it. Okay. So this table, like whatever entry that we are here mentioned over here, that this will only last for like 5 minutes. After this 5 minutes, it will automatically refresh it. So right now, if you check, show MAC address table, there are no details that are present. Okay. Right now, I'm going to send a packet from PC0 to PC1. As you can see, there are no details that are present over here. Once the first packet reaches the switch, okay, so where is the packet right now? The packet reached in F0/1 interface. Okay, so all of you guys are following this fundamentals, basic. You might think it's easy, but if you understood, can you please give me a thumbs up on the chat? Guys, do you understood, or do you don't understood? It sounds cryptic. What is it, Grace? You didn't understand, or you did understand? Guys, the process is, I'm just explaining it again. Okay, so the first packet, okay, so there is a packet. You can see there is this green packet that is created by this PC. Once the packet reaches, okay, so we are connected in switch on the F0/1 port. Okay, if you open the switch, you can see there are like this many number of ports are available in the switch. We are connected on the F0/1 port. Okay, so once the packet reaches the F0/1 port, okay, so switch will immediately check, do I know the MAC address of the device which is connected on my F0/1? So at that time, switch by default, they have no idea what is a MAC address. So we call switch as an intelligent device. The moment the packet reaches on this interface F0/1 port, this is where we physically connected this PC. Okay, the moment the first packet reaches over here, switch will learn it. Okay, as you can see, they still don't know what is the MAC address of F0/2. Okay, and right now we are sending the packet to PC1, but in PC1 they are sending the packet back to this device. So again, if you check, the packet reached the second device, they have no idea what is the MAC address of the MAC address of F0/2 on the device which is connected to F0/2. But you can see the packet is coming and reaching in F0/2 right now. Okay, right now the packet reached where? The first packet that came to the switch from F0 that reached F0/2, and right now, if you check, you can see both the MAC address details. I hope it's clear now. Guys, can you please confirm from your side? Yes. Is it clear now?
Yeah,
Okay.
yeah, John. It's good.
Yeah. Thank you, guys. Now, okay, Hudson, I hope you also understood this. Yep. Then, yep. That is, guys, these are the very basics. Even the people like who have experience, you might please pay little attention also. Why? Because few details you might be missing, and this basics means since you already know like few of the concept, you might find this little boring because you know like the other half of the topic. But this initial days are very crucial because we are discussing all the things in detail. So we can skip because there are other people who are new to this also. Now that is all about switch. Okay, so I'm going to just summarize whatever the things that we discussed in yesterday's class. Switch is a layer 2 device. So what type of addresses switch use? It use MAC address. Okay, and it works in layer 2 and it use MAC address to forward information. Okay. Yeah. So what is LAN, guys? I hope you already know what is the definition of LAN. LAN stands for local area network. So I'm just going to build one small LAN over here. So I take a switch like I have 4 PCs. I connecting all the devices. Here I'm going to use this network address, that is 192.168.10.0/24. Here in this local area network, I am going to use this address, that is 192.168.20.0/24. Okay, so in this 20 network, I will be able to assign IP address from 20.1 to 20.254. Here I will be able to assign 10.1 to 10.254. So this many IP address you can assign for the people who you will understand that at that time. But if you are trying the practicals, you can use the same IP range. So I'm assigning this IP address 192.168.10. one. On the second PC also. To assign an IP address, all you have to do is double click the PC, go to desktop, in IP config, come here, paste it, and change the IP. So, guys, I hope the recordings are already up.
No.
Okay. It's already up anyway.
Alright, we don't have.
Yeah, John, it's up. We can see that.
Yeah. So some of you guys reported in yesterday's session that the recordings was not available, but when I checked with the team, they had already uploaded it. And guys, please look here in the second network. I'm going to start assigning with 20.4 instead of 10.4. Cool. We got 3. And 11.4. Okay. So as you can see, please check with the counselor. As you can see, there are 2 local area networks here. Okay. So I need to communicate between this local area network to this local area network. So far, we discussed about hub. Okay, so hub is a device which does not understand addressing like MAC addressing or IP addressing. So we cannot use hub to facilitate communication between this network to this network. And we cannot use switch also. Why? Because switch is a layer 2 device. So the moment that you're communicating between a different local area network that or a different network, so you can see this both are like 2 different networks. One is 192.168.10.0. The other network is 192.168.20.0. This both are 2 different networks. So definitely you won't be able to communicate between these devices because there is it's 2 different networks. So in that case, we will be using a different networking device. That different networking device that we are using today, or is known as router. The router you will see in the end devices. You can see different versions of routers will be available over here, but you can start using this particular model of router. Okay, and once you connect it, I am just going to connect the devices. Okay, so as you can see, by default, the router, the interfaces are down. Even if you fast forward this, the interfaces will be down. It's because we'll have to understand few details about the router. The router will also is also a device which will look something like switch. But
Hello.
here,
Hello, sir.
yeah.
Okay. There's a lot of routers out there, but you said we can only start with 21 level. Why?
I said use better start using 2.8.1.1.
Oh, okay.
Yeah.
Thank you.
Yeah. So some of the routers they have some few glitches. So this is the best router that you can start using. Okay. So it will be already powered on. This is like the backside of the devices that you're seeing. So here you have basically 2 different. It supports like 2 networks by default. So you can see it. So when you power on a brand new router, so it will automatically ask like this many details. Would you like to enter the initial configuration dialog? No, I don't want to enter it. So router is something which you will have to start configuring first before you actually use it. So the first mode is basically known as the user mode. In user mode, you cannot do much of anything. So in user mode, you can see what you can basically see the details, few details. Okay, so the easiest example that you can relate it with this, when you're walking down in BTM layout in Bangalore or any other place, you might see like beautiful houses on the different lanes. But you might be able to see like the outlook of it, right? But you are not able to see like what is inside of it. So router maintains routing table, but you are not able to see what is a routing table. So like that, you are limited to see few information. The few information that you can see over here is basically this, but you cannot do any changes. You don't have any privileges. It's like just because you see a beautiful house or just because you see that doesn't mean that you can walk inside that house and have a cup of tea, right? No. So from the user mode, if you want to do anything, the first thing that you have to do is get into the privilege mode. So first thing, if you want to get into the privilege mode, you have to type the command that is known as enable. So it will enable you to get into the privilege mode. Either you can type enable or you can type en, both works the same. Or you can also do this thing, en tab, it will automatically fill the rest of the commands. Okay. Now, this mode is known as the privilege mode. Here you can see like lot of details. Today we are not completely discussing everything that on the different modes of the router, just giving an overview. So here you can see the access list, IP addresses, routing table, all those information you can see based on this. So I'm just seeing how many interfaces are there. Okay, so the command to check, please note it down. So this commands you have to keep a note. Okay, so basically a router is a device which is used to separate broadcast domain. We'll discuss broadcast domain in few seconds. So show IP interface brief. This is the command that is used to check the interfaces of the router. What are interfaces, guys? Interfaces are the physical cables that we are used to connect to different networking devices. So the particular model of the router that we are using, it has two interfaces. That is fast Ethernet 0/0 and fast Ethernet 0/1. Okay. So if you see here, this supports like multiple interfaces because that is the primarily the use of the switch is to connect the devices that are present inside the local area network. So the purpose of the router is to connect to a different network. So we don't need that many number of interfaces. So you will see interfaces like 2, 3, 4, and you can add few more custom cables if you want. But most commonly you will be seeing two interfaces. But some of the interfaces that you see will be gigabyte, fast Ethernet, serial. So the best thing that you can try using is show IP interface brief. Please note the command to see the interfaces you are using. So when you type this command, you can see basically you are using fast Ethernet 0/0 and 0/1. In 0/0, we don't have any IP address. In 0/1 also, you don't have any IP address. And it's administratively down. So what we need to do, we need to give an IP address because router is a device which will work only if we configure IP address. Okay. So we are going to configure one IP address. So to configure anything, you will have to get into the configuration mode. So the command is configure terminal. If you type this command configure terminal, you will be inside the device. So right now you are in the configuration terminal. Fast Ethernet is a type of cable, like there are fast Ethernet, it is a cable which supports speed up to 100 Mbps. So gigabyte Ethernet is a cable which will support speed up to 1 Gbps. So it's a type of different type of cables and different types of standards are there, guys. Now, since we know the type of cable that we are using, you can type interface F0/1 or start with the first interface. Okay, so I am going to assign one IP over here. So here I am going to use this IP that is 10.10. Here I am going to assign this IP that is 20.10. Okay, so IP address is 192.168.10.10. After that, you have to enter something that is known as a subnet mask. So the subnet mask for all the networks that we are using right now, that is 255.255.255.0. Please remember this. This is something which we'll discuss in the coming few days of class. So the IP address we added, and we also added a subnet mask. Then since it's administratively down, we will have to make it up. So the command that we're using is no shutdown. Okay, once you type this, it is the command that is used to get inside the interface. So till now, you were in the configuration mode. When you type this command interface F0/0, you are inside the configuration, like the interface configuration. You can see config if this is a symbol, that means that you are inside that particular interface and you assign IP address. You cannot assign IP address randomly. So what is the interface that you want to assign IP address? You have to get inside that interface. So once you assign the IP, you need to exit from that interface. I exited. Then what is the next interface I need to use? Interface F0/1. Okay. And I'm going to assign one IP, that is 192.168.20.10 and plus no shutdown. Now I'm exiting from this interface also. Again exiting. I'm done with all the configuration. Show IP interface brief. You can see you assigned IP address on 0/0 and 0/1, and it's manually up. It's manually up because you type the command no shutdown. Okay, guys, any doubts what we did so far? If so, please let me know. If you have any doubts, you won't understand the next things that we are going to discuss. Any questions?
How many networks can a router connect?
Mostly you will see like maximum 4.
Hello, sir.
Yep.
I'm Ronald. Sir, your configuration from router, how about the switch, sir?
You don't need any configuration for switch as of now.
Okay. Thank you so much.
Yep.
Sir,
Yep.
before you give enable to router, right? Before typing these commands, before that, what command you are given, sir, to access the router?
Nothing.
Like, okay. It's an issue here is that I'm doing same thing that you are doing, but here I'm not going to execute these commands. It's asking me
What is the screen that is displayed to you? Would you like to enter the initial configuration dialog? Is that the message that you're getting there?
Here, enter interface name used to connect to the management network for above interface summary. It is asking like that every time.
Okay, I'll troubleshoot your scenario at the end of the session.
Okay.
Yep.
Thank you.
Yep. But all of you guys, did you understand what I did here?
Yes, sir.
Why do we assign IP address to the router interfaces?
Okay. Who has that question? That's a brilliant question.
And connected to different networks, right?
Yeah. So anyway, okay. So right now, I'll discuss something. Okay. So I'm going to send a message. So you can see the packet, how the packets are traveling. Yesterday, exactly, we discussed that the broadcast domain of switch is 1. So I'm sending a packet from this network to this PC to this PC. So the message is basically broadcasted to all of the ports. It's a broadcast message, right? So if this was a switch, the switch would have broadcasted the message to other switch. Okay, this switch would have broadcasted the message to other switch. Okay, but you can clearly see this router is not forwarding this broadcast message. Okay, I'll quickly add one more segment and I will discuss this. Okay, I'm adding one more switch here so that you can clearly understand this. Okay. So runtime, let the interfaces come up. Yeah, the interfaces are up. Delete this packet. We'll send a message from this PC to this PC. So you can see the message is received by switch. Since this is a broadcast message, this is basically a broadcast message. The broadcast message is broadcasted to all the devices. Please see the second switch be extended over here. The second switch, it's going to send the broadcast message to remaining devices. That is how the broadcast packet was conceived. So you can see the broadcast initially the broadcast but look here. But once the router receives the broadcast packet, the router is actually dropping it. But when switch receives the broadcast packet, you can see the switch is actually not dropping the packet. Switch is actually broadcasting the packet again. So the broadcast domain of switch is 1, which means in simple words, I will explain again. The extent where a layer 2 packet can reach. All the broadcast packets, they are basically layer 2 packets. So broadcast domain is the extent where a layer 2 packet can reach. So as you can clearly see, router is a device which will not send broadcast traffic from one network to another network. Okay, is it clear? That part?
You said the extent where packet can reach.
Yeah, the extent where a packet can reach. The packet, but if I connect one more switch over here, the message would have received over there also. But if instead of this, if I was connecting a router, the broadcast message won't carry it beyond that device. So you can see the message is basically broadcasted only within this local area network. That is basically our entire broadcast domain right now. Okay, so you can clearly see the broadcast is only reaching here. So this is the broadcast domain. But router is a device which is used to connect multiple broadcast domains. So why? Because one thing, you don't need in yesterday's class also we discussed that. So too many broadcast frames, what it will do, it will reduce the performance of the network. One more second.
Sir, can you repeat the broadcast domain once again?
Broadcast domain is an extent where a layer 2 packet can reach. Okay, so you cannot send broadcast packet beyond this router. Okay, when you send a broadcast packet, you can see the broadcast packet, the router dropped it. So till router, whatever area that you were able to communicate, whatever area that the broadcast packet was able to reach, that is known as the broadcast domain. In switch, the broadcast domain is 1. Okay, it's nothing, guys. It's simple. We'll discuss this on the next few days also until you are clear about that. In the initial days, I know because since I've taken batches, I know like in the initial days, as people find this so much challenging. Okay. Let's build a new topology. No, this is enough. Okay, but a router is a device which is used to connect multiple broadcast domain. So multiple broadcast domain as in this is one local area network. This entire thing is one local area network. So you can say that is one single broadcast domain because this entire thing is one broadcast domain, and this is a separate broadcast domain. Okay, so whatever traffic that you're sending from this device, the traffic won't travel beyond F0/1 interface because a router by default it is a device which is used to separate broadcast domain. Why, guys? Look at this local area network, the one which is highlighted in green. Okay, so instead of this, if you were connecting like multiple switches, and if if there was only like one single broadcast domain for all local area 1 network 1 and local area network 2. In the yesterday's session also we discussed broadcast traffic will reduce the performance of the network. It will reduce the efficiency of the network because it is going to consume bandwidth. One IP address is 32-bit, MAC address is 48-bit. So there is like in every packet that you're sending, there is source IP, destination IP, protocol number, source MAC, destination MAC, type field, and the payload. So all the broadcast packet, it is going to consume bandwidth. So the larger the broadcast domain, it is not good. So router is a device. So initially the main purpose of router was to separate larger broadcast domains into smaller broadcast domains. And a router is a device which is working in layer 3. And your actual question was, why do we use IP address for router? Because using this IP address, the router will understand that in which network this belongs to. Okay, so in each of this interface of the router, you should be connecting different networks. Okay, so here we connected 10 dot network, here we connected 20 dot network. So when I type this IP on F0/0 and F0/1, that's how the device understood that. So which network the router is connected, so that a router can form a routing table. You can check the command to check the routing table is show IP router. Okay. Is it clear? Or you can ask questions so that I can particularly answer to that particular question.
John, you said that router can.
Others also, please, you can put the comments, questions in the chat in the meantime so that we can quickly answer all the questions. Yeah.
Then you told that a router can pass the multicast broadcast domain, right?
No, I didn't mention that. Router won't send broadcast. That's what I told.
Okay.
Grace, is it clear to you?
Yeah.
So we
Okay.
can't.
Well, what about others?
John, we can't communicate from LAN PC to the pink color PC, right? Through routers.
We can. That is why we are using router.
But through broadcast message, we can't send.
Yeah, broadcast message. Okay, what the broadcast message? We don't need to send, right? Like we need to only send unicast packets from this PC to this PC. Okay,
Yeah.
to do that, okay, every device. So if you look here, there is something that is mentioned over here. Okay, this might be a little overwhelming, but anyway, just since we discussed so far, I'm going to finish it. So there is something information that is over here that is known as the default gateway. So whenever you want to communicate from between this green network to this ping network, okay, so you need to send the packet to somewhere. Okay, so all of you guys, at least please let me know that you understood that this green and ping, they both are different networks. Can you give me a confirmation at least on that so that I can move forward?
Yes.
Okay.
Yes.
Now, so whenever you want to communicate between one network to another network, so in all devices, in all networking devices, you will use something that is known as the default gateway. So it is like if you want to step out of your room, there is a particular door, right? So this interface F0/0, this is known as the gateway interface. So if the ping network, they want to send traffic, since it's connected wirelessly, you can use common sense to understand this. So the traffic will only pass first to F0/0, right? From ping network, if the traffic will actually first pass to F0/0. And look at the green network. If we want to communicate to the ping network also, the traffic should first reach F0/0, then the traffic should reach F0/1, then only they will be able to communicate, right? So the default gateway is basically the place. So whenever we are communicating something which is outside network, we'll be using default gateway for communication. So you will mention the default gateway here. So that is 192.168.10.10. And in the second device, okay, so if you understood this, can you guys tell me what is a default gateway for this ping network?
20.10.
Dot 20. Yeah.
IP address assigned in the router for the interface.
Exactly. Exactly. So 192.168.20.10. 20.10. In 99.9% of the times, it will be the IP address of the interfaces that we are using, until and unless like you are using some other servers for it. So in 99.9% of the times, the default gateway IP will be the IP that is configured on that particular interface of that network. So for this 20 dot network, this F0/1, this is where we configured. Okay, so I'll do a quick test and I will show you. So right now I'm going to ping the second network IP, that is 192.168.20.1.
1.
Okay, so my first packet will drop and I'm getting reply. If I ping again, I will get all packets communicate. I am able to communicate. But see it from the second device. If I am pinging ping 192.168.20.1, if I'm trying to communicate, you won't be able to communicate. Why? Because, can you tell me why you are not able to get the response?
Because there is no routing.
There is no gateway. Second router.
Exactly.
They have not assigned a gateway. Yeah.
Exactly. There is no gateway. So I'll just ping again and I'll open the packet and I will show you. Okay. So once you open this ICMP packet, you can see the default gateway is not set. The device drops the packet. If so, the PC, they perform some operation. If you learned electronics in college or somewhere, you will understand that there is some AND operation, NOR operation. There are some operation that are performing in the devices. So once PC performs that, once they look at this IP, so the destination IP, they will understand that this is not in the same network. So once they perform that operation, they easily understood that this IP was not in the same network. So they checked whether there is a default gateway. Since there was no default gateway, the PC immediately dropped the packet. Okay, so let's delete that and look at the first PC. We'll ping again from the first PC. So if you open this PC, this scenario, guys, you can clearly see they also understood that this is a different network. So, but the default gateway is set. So the packet is traveling to the default
destination. Yeah.
Gateway. Okay, and a router is a device which is using like switch forwards data based on what?
MAC address.
MAC address. Router send information based on a routing table. So show IP route. You can type this command. So switch when the packet reaches. So you can see the packet is where the packet is currently in the router. So router will check, do I have information regarding 20 dot network? Okay, what is the destination? That is 20.1. So it will check, do I have information which is regarding 20 dot network? So yes, I do have information regarding 20 dot network. Okay, and how do I know? It is directly connected to me on my F0/1. So all I have to do is just forward the packet to F0/1. Simple, right? Guys, is it confusing now?
Can you take it over again a bit?
Okay, let's do it again. So the first packet, since we are trying to communicate to 20.1, that is in a different network, the packet should send to where? Default gateway, no?
Yeah.
Okay. Router is a device which is working in layer 3. Layer 3 is known as the network layer. Okay. We'll do some theory, then we'll come back here. We didn't do for router. So router is a device which is working in the layer 3, that is known as a network layer of Wi-Fi modem. It connects different networks together and sends data packets from one network to another. It transfers data in the form of IP packets. In order to transmit data, it uses IP address mentioned in the destination field of the IP packet. Routers have routing table and it is refreshed periodically according to the changes in the network. In order to transmit data packets, it consults a table, then use a routing protocol. Okay, so we'll discuss all those things, but right now all you have to understand that is that router is a device which works in layer 3, that is network layer. So it uses IP address to send and receive data. So it consults something that is known as a routing table. Okay, based on the routing table, router forwards the information. So once the packet reaches over here, since the data, we send the data in IP packets, and in destination, we were mentioning the destination was 20.network. You can clearly see 192.168.20. Okay, so they will only check the first 3 here because that's what which is representing the network. So 192.168.20.0. This is directly connected on my fast Ethernet 0/0. You need to also see that this is the network of that particular interface or particular router, which is connected. The particular network that is connected on F0/1 is 20.0. So once the packet reaches over here, there, the router checked. So do I know about 20.network? Yes, I know about 20.network. It is connected on F0/0. So I can send the packet there. The packet is sent and the packet is traveling to the device. That's it. Any questions?
Why switch doesn't broadcast now when it received a message from the router?
This is a unicast packet. This is not a broadcast packet. You can see this is not a unicast packet. This is a unicast packet. The previously.
So how did PC2 get to know get to send a unicast packet?
Okay.
They use the IP address and the MAC address of the destination.
Okay. So guys, you have to understand this again. Okay. So in the initial scenarios that the switch broadcasted the message, switch didn't know the MAC address of the device. So it used a different protocol. That protocol is known as. So previously I showed you specifically the protocol that we were using before, that was known as ICMP packet. So right now, if you're pinging the PCs right now in the network, you can see it is broadcasting in the same network. Okay. So let's delete that process. Hi guys. In the last class, we started discussing about OSI model. So in OSI model, how many layers are there?
7 layers.
Okay.
7.
Can you let me know what are the 7 different layers?
Physical layer, data link layer, network layer, transport layer, session layer, application layer, presentation layer. Sorry, presentation layer and application.
Presentation layer and presentation layer and application layer. Okay, so in yesterday's class we were basically discussing about like the first 3 layers, 4 layers, that is application, presentation, session and transport. Okay, so each of these layers I want you guys to remember at least 2 points. So if you think of application layer, what are the key points that you can remember about application layer? Why do we need application layer? And if you guys remember, why do we use application layer? What is the main use of application layer?
We use protocol like HTTP and HTTPS.
Okay, that are just protocols that are running in application layer. Any particular use that you remember? You can say it is acting like a graphical user interface. It is used to read the data, view the data, printing, all of that things.
UDP.
Done. Okay, so now we are coming to presentation layer. Can you summarize at least 2 points on presentation layer? What are the major responsibilities of presentation layer? We can also comment that in the chat. Encryption, decryption, also encryption, decryption.
Information.
Data conversion. Okay, so the major responsibilities in application layer will be basically reading the data, viewing the data, sending the data, basically acting as a graphical user interface. Then coming back to presentation layer, the major responsibilities that happen over there, one is encryption and one is decryption, and also data conversion, because like different vendors, they are using different types of standards. So in presentation layer, what happens is data will convert it to the correct format. Then comes session layer. Any points that you would like to contribute before I summarize it?
With the session layer, it helps in setting up and managing the connection. It's also you can send and receive data.
No, send and receive data. Session layer in Grace, your first point is correct, Grace, but the last points are not correct. You can say you said like it is used to establish a session.
Sending.
You're not sending
receiving of data.
No, you're not sending any data. You're not receiving any data in session layer. So basically, session establishment, like connecting the session, like managing the session, tearing down the session. So all those things happens in the session layer. No data is transferred. In network layer, we actually send the data. It's not in any layer we will be actually sending the data. It is network layer which we are using with the help of transport layer to send the data. Again, transport layer, we are just using facilitating like some protocols which will be transporting the data. So together with network layer and transport layer, we'll be sending the data. Still then the data will still reside inside our system. Now,
but with second layer, can authentication takes place?
Which?
With session layer.
No, different types of authentications are taking place at different layers. So there are like n number of protocols that are happening in each of these layers. So different types of authentications are already. So for example, like different types of encryptions like SSL, TLS. This certification that takes place in different layers. So different types of authentication that take place. But in transport layer, which primarily delivers the data from one end to another end. Okay. Now we are coming back to transport layer. What are the major responsibilities of transport layer?
Transport layer, there are two.
Data are divided into segments.
TCP.
Yeah, transport layer.
I used the TCP or UDP. There are two types of protocol can use.
Yep. That are two protocols that we are using. The first important thing that takes place over there is, I know that you are right, data delivery, transmission of data. Before any of this happens, the first thing that happens in transport layer is what? Segmentation. What is segmentation, guys?
The breaking the data in smaller parts.
Yeah, breaking down a larger data into smaller segments. That is known as segmentation. And what are the two protocols that we use in transport layer?
TCP and UDP.
TCP and UDP. Okay. And what is the difference between TCP and UDP?
TCP is send to data, give the
TCP is reliable. UDP is not reliable. Okay. So UDP is faster. TCP is slower. So you can summarize this in this key points if you want. TCP is speed over TCP is reliability over speed, where UDP is speed over reliability. Okay. So I'll give you a question. Okay. So the particular session that we are doing, this is a Zoom session that we are conducting, right? So is this a TCP or a UDP that we are using?
TCP.
TCP.
Okay, all of you can comment your answers in the chat, so I will have a basic understanding how much you actually got. All of you please comment in chat. Like, I mean, you don't have to give the reasons. You can just answer whether it's TCP or UDP that we are using here. All of you, can you guys please comment on the chat? Okay. Guys, it's just 1, 2, 3, 4, 5, 6, 7. The other guys also who are there. Vinay, Varun, Shiva, Akshay. So majority of you guys actually send me this information. It's TCP. Okay. So there are a few other people also who are here. Okay, let me just check. Rajesh, Chandru, Gaurav, Isaac, Atsan. Okay. Let's just actually see what is the traffic that we're using. So this is a packet capturing tool that you will see. Okay, so Wi-Fi. Okay. what is the major traffic that you see over here? It's UDP traffic. Okay, it's UDP traffic because we are using UDP sessions, not TCP sessions. Okay, why and where is the difference? Okay, in yesterday's session, you guys asked me, so who is deciding it, whether it's developers or is it network engineers who is actually deciding whether we should be using TCP or UDP? Let's see where we have to use it. So let's just come to the like the last point that we discussed. UDP is speed over reliability, wherein TCP is reliability over speed. Okay, so when you want to get real-time information, yesterday's class we discussed that in using TCP, the comparatively the message that you're getting is comparatively slower because of what? Because of the three-way handshake, because of forward acknowledgement, then delayed acknowledgement, and even with the a four-way handshake, it takes like a lot of time to send the data. Okay, so when you're watching a cricket match, when you're attending a live game, or when you're playing a live game like PUBG, if you have played, you would understand that when you're pressing the button, immediately the bullet should reach over there, right? So when you're watching your favorite player who is playing in the match, you will have to see this in live, right? You don't want to get this information later. You want to get this information as early as possible. That is why all those places where we need speed over reliability, we'll be choosing UDP protocol. Okay, so how many of you guys actually watched, when you watch cricket or football, buffering is happening? How many of you guys actually noticed this buffering in live streams? Any of you guys have noticed this before? Yeah, it's because we are using UDP. And what happens after the buffer? You won't get the previous data. You will be immediately skipped to the next live match because you are not actually bothered about like what happened before, right? You are always, very positive person. You're just focusing on the present. So you won't get the previous data because you just want to see like live, like what is lost is lost. You don't have any problem with that. But there are some other scenarios where you need reliability or speed. For example, when you're submitting your work in your company's website. So ideally, when you're submitting your work, the next day you don't want, or when you're sending some money to bank, you don't want the ISP to say that, okay, we were just using UDP protocol and it was not reliable, so your money didn't reach their one place and now we don't know where is the money. Or when you're backing up some data into the cloud, if your cloud service provider is saying that, okay, we were using UDP protocol, but we are not sure about where is your data and your data is lost. It's not acceptable, right? So in that case, we are not particularly focused about speed. We are actually focused about the reliability. In such scenarios, we'll be using TCP protocol. In the scenarios which we want speed more, which we give more preference to speed, we'll be using UDP protocol. I hope it's clear now. Where are we using TCP and where are we using UDP protocol? Guys, is it clear? What? Okay. Now, coming back to it. Yeah, few more questions. Today we don't have much topics to discuss. Today it's the end of our side, and we are not
Hello, sir.
discussing anything. Yep.
Okay, so how can you determine you are using UDP or TCP?
That is what I just discussed, right? So how can we decide? What is TCP? What is the speciality of TCP?
The TCP is reliability over speed.
TCP is reliable, where UDP is faster. Okay. Now, how do you decide? If you want reliability, you'll be choosing which TCP, not UDP, right? If you want speed, you'll be using UDP.
So can you control it by yourself, or a machine will rather choose the one that is preferred?
No, it's actually done by the software developers who are developing the software. They will actually decide. You don't have actually any control over that. As network engineers, you are not even worried about whether it's TCP or UDP. You will just see like the packet. If it's TCP, you will troubleshoot on that basis. If it's UDP, you'll be working on that basis. It's already done by the developers, and you are not doing anything there to change or alter things. Okay. Guys, any of you guys who can give me a solid answer what is TCP three-way handshake and why we use TCP three-way handshake?
Hello. The reason why we use three handshake is to make it a little bit faster.
Who is speaking?
Isaac.
Yeah, Isaac, what is it?
The reason why we are using thread handshake on TCP just to make it a little bit faster.
No, absolutely wrong.
TCP waits for the acknowledgement with all the packets are
Okay.
received.
Okay, no. Next.
For creating a reliable connection.
Exactly, that works. Any other answers? Because that's not just it. I just asked few people. Like I told, we just have 3 more layers to discuss. So I'll just pick out few people from here who I didn't see answering in anywhere. Isaac, you need to watch. Your facts are completely wrong. You need to check on that. Shivam Prasad.
Okay.
Can you answer like why do we use TCP three-way handshake?
Once I need to revise that, John.
You?
I need to revise that concept. Just forward.
Okay. Naveen. Okay. Next. Aju Matthew. Okay. This is a very important part in your CCNA syllabus because this is where the entire few things are actually happening, and this is short interview questions that will dig deeper into this. Yeah.
Should I try?
Yeah, you can.
I think with TCP, all the data reaches its destination faster.
No. Guys, all of you, really? I think, except the
no, it sends all the data. Why UDP?
No,
doesn't.
No. The deep which DP. Okay, deep. Can you just complete like how the complete TCP process, starting with three-way handshake, then forward acknowledgement till four-way handshake.
So the TCP three-way handshake is which involves in 3 steps first. So first is synchronize, then synchronize acknowledgement, and then acknowledgement.
Okay. So hold on there for a second. And what is the main purpose of this?
The main purpose is to determine.
You can simply say, guys, all of you guys, you can simply say it is used for connection establishment. There are a lot of information that are happening in the background, but you can simply say this is for connection establishment. This is a place in which we are not actually sending the data. In this process, in this three-way handshake process, we are only establishing a connection between sender and receiver, and we are synchronizing few information. To synchronize this few information, we are actually using TCP three-way handshake, and like Deep told, it's sync, SYNAC, and ACK.
Yes, it also shares the initial sequence number. Then it establishes the connection.
Connections. Then, okay, what is the next step that happens? Deep, you are done. You're good. Dileshwari.
Yeah, John.
Yeah, what is the next step after connection establishment?
It's
Okay, guys, enough. I will discuss this one more time. This is the first step in TCP process. Okay, so in the first step of TCP process, first we will be sending, first the client will be sending the receiver. You can say sender or server or sender or receiver, sender or client, whatever you want, you can use those terms. So it doesn't matter. So it is sending and receiving mission for simple terms. So it will send a synchronized message. To the synchronized message, the client will send back a synchronized message with an acknowledgement. To this, we will be sending an acknowledgement. This process is known as TCP three-way handshake. The sync, SYNAC, and ACK. This process or this message, this is known as the TCP three-way handshake. The major responsibility of this is for connection establishment. To establish the connection, we will be using to synchronize few information like they are really like different bandwidths, different MTUs will be using, different types of segment sizes will be there. So all those information, this will be synchronized over here. This is not actually where we will be sending this information. And most of you guys, when explaining here, you actually told this is to speed up the process. This is not to speed up the process. Okay, this will actually make TCP slower compared to UDP, because it just added like 3 more extra steps. Okay, then the next process that is involving in the data transfer, where we'll be sending a segment. For that segment, we'll be getting an acknowledgement. Then only if we receive this acknowledgement for the next segment, we'll be sending the next segment and we'll be getting the acknowledgement. Only after we get an acknowledgement, we will bother to send another segment. Now, to reduce this time that is happening over here, we have delayed acknowledgement process, in which we'll be sending a group of segments, and for the group of segments, we'll be receiving a common acknowledgement. Okay, this is done by a method that is known as windowing. So what is windowing? The amount of segments that you can actually send without receiving an acknowledgement. Okay, so depending on your connection speed, depending on the number of users who are active there, your window size will increase and decrease. Then you have so whenever you are failed to send an acknowledgement, the receiver mission, they will give us a proper message in the acknowledgement, so that we will retransfer the data, just in case if we lost any particular data. Once we complete sending all the segments, we'll be using a 4-way handshake to terminate the session. Why this is very important? Because the segments will reach there not on like the first segment will go there, first segment will go there first. No, it's not going on the base of that. It will be going on the base of priority. So the segments have, there's a 10% chance that the segments that you're sending will be shuffled, and you will have to reshuffle and arrange the segments back into the original form. Okay, so with the help of after 4-way handshake, so they will be cross-checking with the checksum and make sure that all the segments are received there properly. You don't have to explain this. This is just for your understanding purpose. But if somebody asks you what is 4-way handshake, you just have to say this message that it is a process in which client is sending a FIN message. FIN is to this, the server will be responding back with an acknowledgement, and after few minutes or after few seconds, the server will again send back a FIN message. To this, we'll be sending an acknowledgement. You can say at least this much. Now, do you have any questions on this, how TCP is operating? If yes, I will repeat it again because this is a very important topic.
Hello, sir.
Yep.
Can you please explain the 4-way handshake again? Because I think you move faster a little bit.
In the 4-way handshake, the client is sending, after sending the segments, the client is sending a FIN message. To the FIN message, the server will send an acknowledgement indicating that the server understood that client stopped sending the segments. After some time, the server, then it will jump into a closed wait state, and server will send a FIN equal to 1, which means that server has completely accepted all the segments that is sent by the client. To this, the client will send an acknowledgement, which means that client also understood that the server accepted the terms. So you can just use the terms FIN, FINAC, FIN, FINAC. FINAC, FINAC, FINAC.
Thank you.
It's not worried about whether it's wired or wireless. TCP is a common protocol that is used to transfer the data. Even if it's wired or wireless, if you're configuring TCP, TCP is used to send the data. It's not dependent on whether it's wired or wireless. Now, you have UDP. The UDP is basically used for streaming media, real-time multiplayer games, voice-over application that do not require reliability mechanisms. Because so here, the major scenario where UDP actually fails is because of low bandwidth or any congestion. So congestion issues are very rarely reported these days, or very rarely seen in UDPs. But the major cause of UDP failure is because even the segment loss is just because of poor bandwidth. So it is always advised to use good so wherever, if you're having like good bandwidth, like your frames won't drop, your messages won't get lost, or your segments also won't go lost. Okay, so it is commonly used in streaming media, real-time multiplayer games, voice-over application that does not require reliability mechanism, even if hindered by them. Then here you have a client and server. The major difference is that whatever TCP does, it's completely opposite of it. TCP uses a 3-way handshake to establish the connection, where in UDP does not. And TCP has connection state, here no connection state. UDP does not maintain connection state as TCP. used for which was basically used for reliability and flow control. And server can support more active clients when not maintaining state information. Here, it can actually send information to multiple people at the same time. So here you can see it will be sending the UDP segment. Right after that, without any acknowledgement, they will send another UDP segment, again UDP segment, UDP segment. So not on UDP, there is an issue with multiple applications over UDP. UDP offer no congestion control. Congestion control is needed to prevent network from entering and staying in a congested state. If all application were using UDP, because of congestion, very few UDP packets would be delivered, and this would cause TCP traffic rates to dynamically decrease. So basically everything which is opposite of TCP. So in a small nutshell, you can say that if you want speed, you will be using TCP. And the most common scenarios that you can see is when you're going in a live, because then and there you should get the information. So right now I am speaking something, then and there you're asking me a question. Because of what? Because we are using UDP protocol. The data is reaching then and there. So it is very important that we should be using. And if you look at this TCP header, okay, so this is how, if you open a TCP packet, this many informations will be there. So here we had TCP packet. Yeah. So if you open a TCP packet, so these are the details that you will see over there. Okay. Source port, destination port, stream index, connection completeness, TCP segment, sequence length 1, sequence number, row sequence, acknowledgement number. This, if you use a tool like Wireshark, you can actually capture it and you can read it, and you can see flags, windows. So in flags also you can see the reserved, accurate, congestion, urgent, acknowledgement, push. Basically you will see all the flags as not set. With 0, which is not set. If there is a 1, which means it's a positive value, like I told in yesterday. So the acknowledgement is actually given. So mostly the flags won't be set, but in some cases when QoS is implemented, you will see flags which are implemented. Let's see what are the flags that we are discussing now. Now, first is source port and destination port. Okay, source port and destination port. Okay, so I am typing something like Cisco. I am getting response back on this particular tab. Okay, guys, you have to pay little attention because we are discussing. If you are new to this term might sound confusing. So I am typing the term Cisco. I am just used a keyword Cisco to type in my search bar, and I responded on this particular tab. As you can see, there were multiple tabs which were open there, and I got this response on this particular tab. Okay, so if you are new to this, you might be actually confused if I ask you on what basis the okay, so this message was actually carried forward by my ISP. Then the request they searched in the internet, and Google actually responded back. So how does Google understand that? So you can say that my search engine is Google. Okay, no problem. It doesn't matter anyway. So, but how does Google understand that I have to get this information back on this particular search bar? Or when I send this information there, the information reached back on this particular tab. So there was actually like multiple tabs which were opened. Okay, it is done by something that is known as port number. Okay, so every time when we are browsing something, when we are browsing something, this computer, this operating system, they will be creating a random port number. Okay, so the random port number, and will be marking as a port number inside the TCP segment. And the destination port number, it will be a standard port number. Standard port number as in standard port number as in. So when I typed Cisco, what is a type of services that I actually used? HTTP or HTTPS? I'm using a web services, right? So whether this is an HTTP or HTTPS, it's always HTTPS.
HTTP.
It's always HTTPS because for security reasons, HTTP is not secure. We are using HTTPS. Okay. So the destination port number will be HTTPS. So HTTPS has a certain port number, that is 443. Okay, so the destination port number will be 44. And if I was using HTTP, the port number would be 80. If I was using some other services, for example, the first query was actually for some DNS query. So when I type, so this is a topic which we are going to discuss at the end of the session, that is basically DNS. So when I type www.google.com, so this is from my source port number that I'm typing. So my source port number, my computer does not understand, or the internet does not understand what is google.com. So the internet has to understand what is an IP which is associated with www.google.com. They don't remember it. So they use the internet phone book, that is basically DNS, to find out what is the IP which is involved in google.com, and they'll respond back to it. So that is a service that is used by DNS. So if that packet was actually initiated, we would have been using the destination port number. The port number would have been 53. So if we were using, if you are using, if you are trying to access your company's website, some of you guys might be, or at least you might have worked from home in some point of time, right? So you might be trying to access your company's server remotely. So at that time, so whether you will be using telnet or SSH, telnet you shouldn't be using, and in companies they won't configure telnet also. So they will be, for security purpose, you will be able to use SSH. So the destination port number will be 22. The destination port number will be always a standard port number. So we will be accessing. So if you want to access the company's resources remotely, you'll be using remote desktop protocol. So based on that, the port number is allocated over here. I hope you understood what is source port and destination port. Any questions? This is the TCP segment that we are discussing. Any questions on source port and destination port? Okay. Now, the second thing that is actually happened over there, that is known as a sequence number. We already discussed what is a sequence number. Based on the sequences, we'll be splitting a larger segments into smaller segments, and we will be sending it in a sequence. So the sequence number for every sequence will be getting an acknowledgement also. Then there is data offset field, which will be always off, and then there is reserved field. So it's a common value which is used to reserve some other fields. Then you have fin. So fin is something which we are actually using. So whenever a TCP connection is terminated, we will be using fin message. Sing message is basically these are the TCP flags. If you see here, I just showed you something that TCP flags. These are the flags that you can see over here. So commonly you have reserved, accurate, congestion window, ECN, urgent, acknowledgement, push, reset, sync. So most of the values will be set as off. And then you have reset, push, acknowledgement, urgent. Okay. So reset is something like whenever you find something which is not right over there, you will be immediately terminating the session. You will be using reset. And from application layer to pass the information much faster, you'll be using this push flag. Then there is an acknowledgement for flag, which is indicating that. So whenever you wanted to get send a packet, which immediately you will be turning on this particular bit in the flag, that is urgent. So if the urgent flag is turned on, the data will be treated in the highest priority. Then you have window size. In window size, you will be actually mentioning what is the window size, what is the size of the segments that can send without receiving an acknowledgement, that will be mentioned. Then there is a checksum. Checksum is used to identify that, like I told, the data will be shuffled once it reaches the destination device. So it will use the checksum value to reshuffle the data and arrange it back. Then there is urgent pointer. So if it's set, this segments will be considered in the highest priority again. And then there is option field, which mostly you won't see, but there's an option field which is of actually 32 bits. So the source port number, it is of 16 bits. Destination port, it is of 16 bits. Sequence number, it is of 32 bits. Acknowledgement number, it's of 32 bits. Window size, it's 16, as in pointer 16, checksum it's 16, and offset field, it's actually again 32 bits. And there's a small assignment for you. Why do we use CWR flag and ECE flag? These are other two flags also that we are using over here. Why do we use that? Now, any questions? What are the details or any questions that you want to ask me? Guys, any questions on TCP flag? Okay. The UDP header is pretty simple. Source port, destination port, then there is length, and there is a checksum and data. The source port number, the sending port number, destination port number, the port which is actually receiving the services, and then the length of the data, checksum, and the data if you want to send. That is all we are using over there. Then comes the network layer. The next layer is network. So what is the major responsibility of network layer? The major responsibility of network layer is, as you can see, all the square brackets over here that are actually different networks. So we'll be using a device here that is known as router, which will be helping us to connect between multiple networks. Okay. So what is the major responsibility of network layer? The network layer is used to connect between multiple networks. Okay, and we are using router. So router sent destination message from one network to another based on the routing table. So if this first network wants to send an information to the last network, so router maintains a table in the router to process the information how I can reach this message to the destination network. Okay, so all the router, they maintains a table. Okay, so in the table there will be also a metric cost, then there is a routing table. So based on this, the device will be used to take forwarding information. The network layer manages device addressing, which means IP addresses. So the device address that we use in network layer is IP addressing. Tracks the location of the device, which again we are using IP address to do that. Determines the best way to move the data. Here we are moving the data in the form of IP packets, which means that network layer must transport traffic between devices that are not locally attached, which means, so with the help of network layer only, you and I are connected now, which means we are not directly connected, right? So with the help of network layer, you belong to a different network, I belong to a different network. So based on the network layer and based on the devices that are available in the network layer, we both are actually connected. Routers are specified at network layer and provide a routing services within a network. So here you have data packets, then that will be actually sent. Then we are discussing something that is known as router protocol. Data packets used to transport user data through the internet protocols to support data traffic are known as router protocol. So like I told, all the data that we are sending, it is in the form of IP packets. So in router protocol, we have IP version 4 and IP version 6 because we are only using two major versions of IPs. One is IP version 4 and one is IP version 6. And currently, we are in the process of getting more IPv6 address because by 2019, we actually ran out of IPv4 address. Okay, so all the IP addresses that, again, if you're new to this, we will discuss this in IP addressing class. So currently, there are two major versions of IP addresses. That is, one is IP version 4 and IP version 6. Okay, so till 2019, IPv4 was commonly used everywhere. Even now, IPv4 is commonly used, but the service providers like Geo, they have adapted mostly to IPv6 right now because it's much more easier to manage that. So that is basically known as router protocol, like I told. So in network layer, what are the major responsibilities? Manage device addressing, that is IP addressing. So what is the type of IP addresses we have? Either it's IPv4 or IPv6. Hi guys, welcome to today's session. In the last class, we were discussing about transport layer, also network layer. So basically, those were the two layers that we were discussing in yesterday's session. So today we will start discussing with data link layer and physical layer. Then we will finish that in another 10 to 15 minutes. Then we'll start with IP addressing. Okay. So look here, guys. So in the last 2 days of classes, we were primarily discussing about OSI layer. In OSI layer, how many layers are there? There are 7 layers: application, presentation, session, transport, network, data, and physical. Okay. So what this is used, why this is used? This is known as a reference model in which we can know and understand what are the protocols that we are using and what exactly happens in each of these layers. In application layer, it's just acting as a user interface. Presentation layer, encryption, decryption happens, data conversion happens. In session layer, you basically establish the session. In transport layer, you decided on by using which protocol you'll be transporting the data. Either it's TCP or it's UDP, you'll be deciding that in the transport layer. So in network layer, so based on the routing table and with the help of routed protocols, we'll be sending the data from one network to another. Can you tell me what is routed protocol and what is routing protocol? And if you guys remember, what is the difference between routed protocol and routing protocol? Anyone?
Routing protocol.
Can you give me an example of routed protocol? Routed protocols are yes, Amir. Good work. Router protocols are IP version 6 and IP version 6. Currently, these are the two router protocols that we are using. And what are the routing protocols that we are using? We discussed few. If you remember, you can comment that in the chat.
OSPF,
OSPF, EAGRP, all those protocols. Yeah. Yeah. So please don't say RIP because it will really sound like RIP because RIP is currently in RIP state. So people will get confused. RIP. Yeah. So what are the router protocols? Router protocols are either it's IP version 4 or IP version 6, in which we'll be in that forms only we'll be sending the data from one network to another. Okay. So once the data reaches in the data link layer. Okay, once the data reaches in the data link layer, we'll be using the help of MAC address to deliver the data. Okay, so here you can see I am pinging a message from this PC to this PC, which means they both are in two different. Okay, 1 second. The devices need to turn up. Yeah, so I'm sending a message from this network to this network. So the major operations that are done in the network data link layer, one is the use of MAC address. Okay, so here till now, even now, we are sending the packet to default gateway, which means right now our network layer operations are completely done, and we are sending the details to the data link layer. As you can see, the data has reached the network layer. The network layer delivered the packet to the current network. Okay, so there are some configuration issues with this topology. We are not troubleshooting that. We'll use some other topologies now. I hope, yeah, this one has the details. Okay, so let's edit filter. Bring out of it. We are pinging from this 10.1 PC to 20.1 PC. So whenever we are communicating, since we discussed this in the previous session, we are still discussing about the network layer. the packet will reach to the default gateway. In default gateway, whenever you want to communicate between multiple networks, you use the help of the router, right? So I wanted to communicate to 20.1. So router use what is the best path that it can reach this traffic to 20.1, and it checked whether they have any routing table. Since when it checked the routing table, it had an idea about that. Okay, so enable show IP route. The destination we want to reach was 192.168.20 network. So in the routing table, it's mentioned that in order to reach there, you can send the packet to 10.0.0.20. Okay, so we send the packet to 10.0.0.0.20, and once the packet reaches there, we'll be using the data link there to communicate between the next network. So we'll just see how we do that. So network layer's responsibility is to send the packet to the correct network. So we send the packet to the correct network. So right now the packet is in 20 dot this network. So 192.168.20.0 network. The packet reached there. Okay, now we are actually moving to the data link layer. In data link layer, we will be forwarding the information based on what? So from now, only if you want to communicate between different networks, we'll be using network layer. Okay, so whenever you're communicating inside the network, which layer you'll be using? Right, which layer we'll be using? Data link layer. And how does data link layer forward information?
Using MAC.
Based on the MAC address. Based on the MAC address. Okay, so you can see the packet reached this device. It's because the switch maintains a table. In the table, it was mentioned what is the MAC address of the destination device. Show MAC address table, the destination device MAC address was mentioned. So switch forwarded that information based on the destination device MAC address. So the major responsibility of network layer, data link layer, is to forward the packet inside the local area network and find out what is a MAC address which is responsible in it. And there are so many layer 2 principles that are involving, which we will discuss in the practical session. Okay, because there is one more protocol also. There are a few other layer 2 protocols that are there. So all the layer 2 protocols, once we start discussing the labs, we will practically see, and we will discuss all those things. Now, let's go back to the theory. So the data link layer provides the physical transmission of data and handles errors, notification, network topology, and flow control. Okay, so flow control is it will make sure that if the two people are trying to communicate in the node at the same time, so if two people are communicating at the same time, they'll be using a mechanism of CSNA bar CD to make sure that there is no collision that is occurring. And again, it handles the errors. It handles the errors as in just in case if some data is missed in the transmitting process. So again, they will handle the error. They will retransmit the data, all those operations that happens in the data link layer. This means that the data link layer will ensure that the messages are delivered to the proper device on the LAN using the hardware address, that is the MAC address, and will translate messages from network layers into bits. So now, in order to send this message, here, in order to send this message to the end device, you can see right now the message is in the data link layer. It is sending the message to, okay, before that, you can see the message was actually right now you just saw the data link layer send the message to the end device using the physical layer. In physical layer, we don't have any device, we just have cables over there. So physical layer, they don't understand any type of addressing. So the data link layer will convert the data into bits. The data link layer will convert the data into bits. Bits means zeros and ones. Okay, and they will add a source MAC address, destination MAC address, all those things will be mentioned in bits, and they will be sending that message to the destination device. The data link layer formats the messages into bits. It's also called data frame, and adds a customized header containing the hardware address and the destination source address if needed. The data link layer consists of two main parts. One is MAC address, the physical addressing that we are using, that is of 48 bits, and there is something that also happens in the data link layer that is known as logic link control. So previously we discussed all the error controls, all the retransmission, making sure that the data is reaching there in that device. All those things are actually taken care by the logic link control, responsible for identifying network layer protocols, then encapsulating things. So there are a lot of network layer protocols that are running. So STP, CDP, are all those layer 2 protocols that are running in the data link layer. So logic link control, they will be identifying that and encapsulating on the basis of the correct order. Then we have switches and bridges that works on the data link layer. Switch is considered as a hardware based bridging because it is used special hardware application with integrated circuit. So which is basically using for to send the data between two nodes. The data link layer functions are framing and deframing. So once the packet reaches from the switch, the data will be already in frames. So they will be reframing the data and they will be sending to the end device. And once the data is reached from the device to send the data to the network layer, they will be framing the data. Then MAC address discovery, they will also find out what is the MAC address of the destination device that we are using. So this is something which we'll be discussing in depth, that is done by a protocol that is known as R. But we will include that for another class because that's a big topic. So R is a big topic that we will include in a separate class. Then switching, whenever you want to communicate between multiple switches, there are other lot of layer 2 protocols are involved. VLAN, SPER, VLAN, P, spanning tree, all those protocols that are done over there, that is done in the switching part. Then layer 2 addressing scheme, that is the MAC addressing and error checking mechanisms. So all these operations that are done in the data link layer function. And in the physical layer, we don't have anything. It just sends data in bits and receives data in bits. Hub works in the physical layer. Hub is really a multiple port repeater. So this is the reference model. OSI is basically a reference model that we are using. The current model that we are using in the standard industry, that is known as TCP/IP model, in which we have application, then host-to-host layer, internet layer, and network access layer. So application, presentation, and session in OSI, they are known as application layer in the TCP/IP model. And then the transport layer will be known as the host-to-host layer, and the network layer will be known as the internet layer, and network access layer is known as the data link layer and the physical layer. So all those things that will be encapsulated over here. So there is a book that is, if you want to know more about this, there is a book that is known as TCP/IP Protocol Suite that is available in Amazon. It's a very good read. Yeah, TCP/IP is the actual protocol that we're using in the industry. And again, TCP/IP protocol, so when developers, they made TCP/IP protocol suite, so they made, so you can develop your own customized TCP/IP protocol suite. You can build it. The developers are building their own TCP/IP stack. Okay, so they give a lot of provision for the developers to customize their application based on their requirements. That is why I said, if you watch that, if you know like how Spotify reshuffle their TCP/IP stack, that is because of it. They have low latency. That is about OSI model. If you have any questions, you can ask me, or else we are going to start with a new topic, that is IP addressing. Any questions on data link layer and physical layer?
What is that diagram in the previous slide? The TCP/IP, that green color diagram.
That is the actual model that we're using. Application, presentation, session in the OSI model, that is actually replaced with application layer in TCP/IP model. So OSI was, okay, I told you in the beginning of the class, OSI is known as a reference model. OSI is not the actual model that we're using. But even now, when people are developing like more protocols, people are still referring to OSI. So in terms of exchanging information also, we are still referring in terms of OSI model only. We are discussing. That is why in your production, you might be referred as layer 1 engineer, layer 2 engineer, layer 3 engineer. All those things are actually referred on the terms of OSI model. Really, that is a standard reference model that we're using in the industry. But the actual working model that is there in the industry, that is the TCP/IP model, something that is known as IP addressing. Okay, somebody is drawing on my screen. Okay, come here. You can see I'm checking my IP address. So, okay, this is a new service provider that I'm using now. So you will only see IPv4 address. So when I was using Geo, I had IPv6 also, but you can see something. So in today's class, we are focusing on IPv4 addressing. So you can see in the place of IP, you can see this IP 192.168.1.11. Okay, so this is basically a reusable IP. This same IP sometimes you might be having inside. This is not a global IP address. So in case if you copy this IP address, you cannot do anything much with this IP address. Okay, so all you have to say is in the place of just before that, you have seen that IP version 4. Okay, some of you guys, when you are using your IP configuration, you might be getting this in IP version 6. Some of you guys might be getting in IP version 4. Some of you guys might be getting this IP address in both in IP version 4 and IP version 6. Please don't, this is not the IP version 6 that we are talking about. There's a different IP version 6 address that you will see, like just like IP version 4 address. Okay, so what is IP? Internet protocol address. That is a fundamental address that we are using for routing to identify our identity in the network, internet. This is the address that we are using. It is basically IP address. So this IP address is something which is developed by IANA. Okay, so IANA basically developed IP addressing. So they are known as Internet Assigned Numbers Authority. So any changes, any public changes, like I told, like previously OSI was used, right now it's TCP was used. All the major changes in the industry, all the major protocols. So they discuss like different versions of IP. So the different versions of IP was submitted by a group of researchers in different RFCs. So before making anything in public, before the crowd actually started using, before the public people, they actually start using these technologies. So they will publish this RFCs. Okay, so RFC means request for comment. This is basically the official documentation. So if you look at any protocol, for example, some of you guys already told, in routing protocol we have RIP, EIGRP. So previously, before EIGRP was deployed to the public, so EIGRP was actually submitted in RFC, that is known as request for comments. And a lot of people, like there are like a lot of people who are from a lot of very big organizations, they're coming to that, they're discussing the advantages, disadvantages, and once they make sure that this is the better method, then they will officially publish this RFC and the public can actually see it. So whenever you are learning a protocol, you can actually go to the internet and check what is the RFC for that particular protocol, and you can read the official documentation. So at beginner, I wouldn't suggest you do it, but it's very good if you are trying to use it. Okay, so here IANA, the global coordination of DNS route, IP addressing, and other internet protocol resources is performed as an Internet Assigned Numbers Authority, IANA. Okay, these people, they are actually responsible for the DNS route. DNS route is something which is acting like the backbone of internet, which basically allows you to communicate between all the internet network, and IP addressing, which is your identity in the internet. All these are developed by IANA. So here IP addresses. Okay, so currently there are two types of IP versions. One is IP version 4 and one is IP version 6. So in January 1983, IP version came into the picture. Around 2018, we already ran out of almost all the IP version 4 addresses. So right now we are currently using this IP version 6 addressing. Okay, so whenever you are requesting a service, your service provider, they will be giving you an IP address. Okay, a public IP address. Based on that, so whenever you are requesting, so your service provider who is responsible for, who is giving you the internet, they will come and they will give you the IP address and you are able to access the internet. Okay, they will also provide internet connectivity if you are using broadband connections. or else you will be buying public IP addresses from one of the service provider who will be leasing or who will be giving you this IP addressing. So how the IP address is actually used? Okay, in IP addressing, we are actually using decimals. Okay, so when I say decimals, everything in the computer network or computer, all the things are actually done in binary only, but let's keep it in decimal form for a while. Okay, so in IPv4 addressing, what is IPv4 addressing? It's basically a string of numbers which are separated by a dot. It's basically string of numbers by a dot. Okay, so in decimal, the numbers are ranging from 0 to 255. Okay, so how it is separated by a dot? In IP version 4, we have something that is known as octet. Okay, so we might be, so let's take the highest value over here. So we have in one octet we have around 8 bits. 8-bit means either the value can be of what is a possible value that we can have in a bit, guys? What are the two possible values that we can have in a bit?
1 or 0.
Yeah, so bits are either 0 or 1. Okay, that is why in binary the base is always 2. So in one octet, in IP version 4 we have 4 octets. Okay, so in one octet we have 8 bits, that is 1 2 3 4 5 6 7 8, or we have 1 2 3 4 5 6 7 8. Please don't count it, just in case I missed it. Like that, we have 4 octets, which means 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Here also we'll be having 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 8. Okay, so I'll teach you the conversion now. So if I'm writing the value in binary, you'll be getting the value as in the value will be starting from 0 dot 0 dot 0 dot 0 dot 0 up to 255 dot 255 dot 255 dot 255. So this is how your IP addresses will be ranging, which will be starting from 0 dot 0 dot 0 dot 0 to 255 dot 255 dot 255 dot 255. Okay, so which means how many number of IP address are there in total? Okay, so any of you guys who are good in maths, can you tell me how many IP addresses that we can have in an IP version 4 address? In what is the base of this? Base is 2, right? In binary, what is the base? The base is 2 because we have 0 and 1. So how many number of IP address we have? We will be having 2 to the power of 32. Can somebody calculate that in and let me know the answer? Yeah, Naveen, you're so fast. Okay, this is the value. Okay, so this is around, can somebody pronounce this value? How many billion?
Like 429 crore 49 lakh 67,296.
Okay, 429 crore 49. Yeah. So this is the maximum number of IP addresses that we have in an IP version 4 address. Okay, so we have around like twice or thrice of the population that are currently living in this world. Okay, why this is very important is because you as a person, how many IP address you are using? You are having a mobile phone, you are having a laptop, you are having any other gadgets. If you're having like security cameras in your home, in your offices, forget about your offices, in your home. If you are having any other IoT devices, they all use IP addressing. So on average, every person they will be using at least 2 IP addresses, right? So the population of this world is twice of this. Okay, I'm not saying everybody is having the internet, but and there are other companies, corporates who are using this IP addresses. So by 2018, 2018 or 2019, we actually ran out of this IP addresses. We don't have any more IP addresses that we can assign. So we predicted this long back. When people developed IP version 4 address, they didn't expect this. But later, after 10 years, they easily understood that this would be easily exhausted in few years. So they developed a new protocol that is known as IP version 6, which we'll be discussing in the end of the end of the syllabus. So our major discussion and will be a major configuration of usage from the exam perspective. It will be of IP version 4 address. And let me take the presentation. Now I will start. So IP addresses. IP address is a unique address that identifies a device on the internet or a local network. IP stands for Internet Protocol. An IP address is a string of numbers which are separated by a dot, which is like, for example, 192.168. Please don't say comma, please don't say point, it's always dot. 168.32.1. Okay, so it has 4 octates. What is an octate? A string of numbers up to 8-bit. Octate is each octate is how many bits? Each octate is 8-bit, guys. Okay. Now, when we are writing the value in bits, either it can be 0 or 1. So the maximum value that you can have in one octate, that will be 0. If all the values it's 0, 0.0.0.0.0, it's basically 0. And the maximum value that you can have in one octate, that is known as 255. The full IP addressing range goes from 0.0.0.0 to 255.255.255.255. This is the maximum value that you can have. The total number of IP addresses that you have in IP version 4, that is known as 2 to the power of 32. This is the maximum value of IP address that you have in IP version 4 address. Any doubts in this? Any doubts how we got any of these values? Any questions? Okay. Guys, how many bits are there in an IP version 4? How many bits are there?
32.
32. So what is the base of binary?
2.
2. So 2 to the power of 32. It's 32 binary bits. So you can have 2 possible combination in permutation, either it's 0 or 1. So 2 to the power of 32. That is the maximum value that you can. Okay. So classes in IPv4 addresses. Okay. In classes of IPv4 addresses as in. So you might be heard about this in before if you already work in anywhere which is related to IT. If not, it's completely fine. So classes in IPv4 addresses is like, so all students are students, but when you go to schools, you will see you are actually labeling them based on their qualification and based on their properties. Some of those people, like, they might be studying computer science, some of them might be studying mechanicals, some of the other people, they may be studying electricals. All the students, like, they have different attributes, right? Like that, here you are actually separating different ranges of IP addresses. So different ranges of IP address, which means IP address will be starting from 0.0.0 to 127.255.255.255. We actually putting that into class A. Okay, why we put that into class A and what are the specialities we'll be learning. But now all you have to understand is that 0.0.0 to 127.255.255.255, it is an address which is used in class A. And IP address which is ranging from 128 to 0.0.0 to 191.255.255.255, it is belonging in class B. IP address which is ranging from 192.0.0.0 to 223.255.255.255, it is belonging in class C. And IP address which is ranging from 224.0.0.0 to 239.255.255.255, it is belonging to class B. And IP address which is ranging from 240.0.0.0 to 255.255.255, it is belonging in class E. Okay, now you have to remember, when you are assigning an IP address to end devices like printers, cameras, desktop, mobiles, whatever tablets, whatever devices that you're using, you will be using the classes that are ranging from class A, B, and C. For multicast purposes, for basically we'll discuss this in multicast purposes. If you need to send information via multicast, you'll be using this class B address, that is from 224.0.0 to 239.255.255.255. And class E, basically it's not used, it's basically called for research purpose, but nobody is actually using this IP addresses. Okay. Any doubts, any questions you want to ask me now on this, the classes? I think it's self-explanatory.
John, hello.
Yeah.
John, actually, in the previous class, they said class A range is 0 to 126.
Okay, who said?
In previous class, I think Ekas is said that IPv4 class A is 0 to 126.
No, the class range is from 0.0.0 to 127.255.255.255.
Okay.
Understood? Okay. But 127 has a special property, which we will discuss in the next slide. We also have the continuation for this. Okay.
Okay.
127, it's a loopback address. Okay, 127 is a loopback address as in. So in class A address, we will be taking 127. Okay, any IP address that are actually starting from 127.255.255.255 or any IP address. Okay, so it is used for loopback purpose. It's basically configured to your own interface. Okay, I'll show you. Thing 127.0.0.1. Okay, you're getting a reply. So, but this address is taken from where? This address is taken from class A. 127.0.0.2. So all the address which are ranging in that network, it is basically used for class A. So basically you're pinging your own local interface and you're getting the reply. You're on basically the loopback that is being inside your system. So that's where the loopback IP is gone, but it's used from class A. I hope it's clear. There's a little confusion, but you're almost right. Clear?
Yeah, clear.
Okay. Hi guys. How many people are in 99? So in the last class, we were discussing about IP addressing. In IP addressing, we have 4 different classes. Class A, Class B, and Class C. And an IP address is a 32-bit number. It's separated into 4 different classes. And what is the range of an IP address in one octet? What is the range of an octet? Octet is ranging from 0 to 255. 0 to 255. Yeah. So the total number of IP address that you have is 2 to the power of 32. The last class we were discussing decimal to binary, decimal to binary. So now we'll just practice one more thing. It's not something too complicated. It's binary to decimal. Okay. Anybody who joined today? Okay. So I'm just giving you one binary number here. The binary number is 1100112446. Yeah. 10. No, let it be 01. Yeah. So can you tell me what is a decimal equivalent to this binary number? Anyone? How do we do that? Decimal number is 205. Okay. Yes. Anybody? Any other answers? 205 is the most common answer. So let's see. So it's 128 plus 64 plus 0 plus 0 plus 4 plus 0 plus 1, right? So 128 plus 64, 192, then 200, 204, and 205. So you get the answer as 205. Okay. So again, the next question is 0, 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8. What is the number? I think by default you might be able to figure it out the answer. What is the decimal equivalent of this binary number? I'll just pick some people. Grace, what is the decimal equivalent of this number?
137.
137. Yeah, you're right. Okay, the next one is 10 1 0 0 1 0 0 3 5 8. Yeah. What is the equivalent value of this? Sutrit, What is the decimal equivalent of this value?
128 plus 0 plus 32.
Yeah, that is 160.
And 168 probably.
164.
164. Okay.
164, yeah.
Yeah. So you can count it from the backward also. It's 124, right? So
yeah.
the moment that you got 160, you can do it in any ways which is convenient for you. But I hope you understood the logic behind it.
Yeah.
Anybody who have a doubt in this? Because in tomorrow's session, you might find difficult if you don't understand this process yet. So I hope all of you guys are okay with it. So I'll be moving back to the actual topic. Okay. Can any of you guys give me the class A range? Class A range is starting from
0 to 127.
127. It's 126.
0 to 127. Okay. Class A range is 0 from 127. So what is the speciality of 127? 127 is a
loop back.
Look back.
Loop back address, and 0 you cannot use. Okay. So after this, how many addresses are there?
126.
126.
1 to 126.
126 networks are there in class A. Okay. So okay. Now class B range is starting from 128 to
171.
191.
191. Okay. And class C range is starting from 192 to
224.
223.
223.
223. Yeah, it's 223, not 224. Okay. Let me see the response in the chat. Yeah. Yeah, 223. This is enough. This is all I would also ask you to memorize it. Apart from that, you can just find it easily. So this addresses you can think on the range of the bits power also. Actually, the first one is starting from 0. The second bit will be like 128. Then it will be like 192. Based on that, the powers of the bits that we were operating before, you can memorize it like that if you particularly want. But that's just the gist of it. So, okay, guys, look here. When you convert any decimal number, which is of class A, always the first bit will be marked as 0. Why? Because if there is a value in the first bit, the range will be more than like class A range. So we cannot put value in the first bit. So always the first bit will be 0. Okay. So starting from the least value to the highest value, always the first bit will be 0. So when you do this, this is just a small observation that I am asking you to observe. In class B also, always the first 2 bits are actually reserved. Whenever you do a conversion, since if you put values in the first 2 bits, the value will reach to 192. So we cannot allow that. So the first 2 bits will be always known as the reserved bit. You cannot use it in any operations. In class C, the first 3 bits will be reserved. So this 110 will be constant everywhere. The same will happen in class D and class C. In the class D, the first 4 bits are reserved. That will be known as 1110. And in class E, you can see the first 4 bits are reserved, and it will be like 111. But you don't have to focus on that, but you have to focus on what I just told you. How many bits are reserved in class A? That is the 2 bits. The first bit in class B, 2 bits, that is the most significant bits here. We cannot use it. In class A also, we have 3 bits, that is 110. Okay. So in every address, in every IP that you see, there is an address that is known as a network address. There is an address that is known as a host bit, and also something that is known as a subnet mask. So before that, let's just understand what is network address. Experienced people, just understand that this is for the absolute beginners to understand what is a network address so that they won't confused. Okay. So imagine network address is like a complete address of a network which is used to identify that particular network. Okay. In networkers home, in networkers kings, they offer CCNA, they offer CCNP, cyber, DevOps, other some of the programs. We are not going and discussing all of it, but these are the few programs that are there. Okay. Imagine there is a in colleges you will see a student ID is mentioned. The student ID in the student ID, if you are looking, you can see the particular year that they are joining, the particular batch they are in. Even in your ID card and employee ID card, like there are a lot of factors which is used to represent the particular session that you are actually working with. Okay, so every student who is coming, who is joining for the CCNA program, which is starting on 2024. So C24 24 8, no, this is the 10th month. So and again this is starting it. Okay, so and we also use two more identifiers. This is known as the network address. Okay, so when someone is joining, when the first person who is joining, let's take a name from here. When when Grace is joining here, Grace is getting a student ID. The student ID is C241001. Like that, as a different person is joining in CCNP. So here their ID is starting with NP 241000. The next person, he have actually joined in the CCNP program. So the network address will be NP 241000. So one more person who is joining in this CCNA batch, so their network address will be C241002.
Yeah.
When the next person is joining in the CCNV program, they're getting this network NP 241002. Okay, this should be 01.
Yeah.
If you observe here, the NP 2410 is common in both addresses, right? Okay, here you can see the C2410. This is also common. Okay, so like that if when the third person is who is joining, they'll be getting an ID, student ID, that is C24100304. All the places it will be going. But what you need to understand is that there is something that is constant in all the IDs. All the IDs, C2410 is common, NB2410 is common. So using this, you can easily identify that whether a person is belonging to CCNA batch or CCNB batch. Again, the same thing, same operation you can actually perform while looking at an IP address. Whenever you get an IP address, you can just check in your IP configuration. There are a lot of details that I'm actually mentioning, which is helping us to identify in which network, which class this IP address belongs to. So whenever you check an IP address, after an IPv4 address, always you will see something that is known as subnet mask. Okay, so the subnet mask is used to identify. Okay, so in subnet mask there are two portions. One is a network portion and one is a host portion. The network portion will be constant. So in this example, the C2410 is the network portion, and 00, the 0102, these are the host portion. This host portion will be changing. So in subnet mask is used to identify in IP address how many bits are there. In IP address we have 32 bits. So using the help of subnet mask, we will be able to understand how many network bits are there and how many host bits are there. So you can see this is an IPv4 address which is starting at 192.168.1.36. Okay. So let's take an IP address. This our network address 192.168.10.0. This is our network address. When the second person is joining, we are assigning 10.1. When the third person is joining, we are assigning 3, 4, Fine. As you can see, the network portions remains the same. Okay, the first address in the network, the first address is always the network address. All the addresses, the remaining address, they are used for the host addresses. Okay, so the last address in this range will be this IP, that is 192.168.10.255, and the second last IP will be 10.254. We will get into that. How do we find out? Okay, so while looking at every IP address, you will also get something that is known as subnet mask. In subnet mask, it was mentioned as 255.255.255.0. Okay, if you check in your IPv4 address, you can always see what is the subnet mask. Okay, here in the subnet mask, it is mentioned as 255.255.255.0. So what is the use of it? So using the subnet mask, you can clearly understand that how many network bits and how many host bits are there. Okay, so this is an IPv4 address. In this IPv4 address, how many addresses we have? We have around 32 bits. In 32 bits, it is representing that 255.255 means writing in binary 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay, so which means that 24 bits are reserved for network and the last 8 bits are reserved for host. So the first octet is how many bits, guys? The first octet is 8 bits. The second octet is 16. The third octet is 24. So using the subnet mask, we were able to understand that how many octets were reserved for network and how many octets were reserved for host. But to be specific, you always have to mention this, how many bits are reserved. Okay, there might be changes in the scenarios. We'll be changing the subnet mask. I hope you understood what is subnet mask, network address, and IP addresses.
A little bit too fast. Please, can you repeat it again?
So network address is an address which is used to represent all for the complete network. For example, so there might be 60 people who will be working for your IT department. You are buying one network address. So when you're buying this network address, you will always have a network portion and host portion. Okay, so imagine that we bought this 192.168.10.0 network for the IT department, and in this network we have around 255 IP addresses. So in total 256 IP addresses. Out of that, we can use 254 IP addresses. So looking at every addresses, you will see a network portion and host portion. So in every IP address, you will get a network portion and host IP address. So using this 192.168.10. portion, I was able to understand that this belongs to IT network. Okay, yeah. And I have around 250 because so that portion also you will understand in the next slide. We are anyway going to explain, because it is mentioned that the last octet is reserved for host. Okay, in subnet mask, this 1 is the bit which is representing the network portion, and 0 is the bit which is representing the host portion. So I can understand that looking at this IP 2 to the power of 8, I have 256 IP address. I will be easily able to understand by looking at the host bit. I will be able to understand that how many bits, how many host networks are present in this IP address. I will be easily able to understand that. Okay, I hope now it's clear.
The 20/24, you didn't give me the explanation of that one.
Okay, you just have to count the number of ones. Okay,
I mean,
in one octet, how many? Yeah, in one octet, how many 1 bits are there? 8. The second bit, how many bits are there? 16. The third bit, the third octet, it is 24. Rather than writing 255.255.255.0, you can simply write /24. Which is basically indicating that 24 bits are reserved for network.
For network, okay.
Yeah. So in class A network, okay, in class A network.
Sorry, and what 0 is representing what?
0 is representing the host portion.
Okay.
Okay, we'll get into that. So in class A range is starting from 0 to 126. Okay, so the class A IP address is starting from 0 to 126. So the default subnet mask for class A is 255.0.0.0, which means how many bits are there for network, guys, here?
Only
8-bit.
8-bit. You can write this as /8 if you want. Okay. And how many bits are there for host here?
24.
24. Understand now?
24.
Understood now. Okay. So which means how many number of networks we can create from 0 to 126? We have around 255. That is around 8 bits we have, right? The first octet, if you expand it, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So we are going to find out how many number of networks we'll be able to create with this 8 bits. Okay, in class A, which is from 0 to 126. Out of that, we cannot use the first bit because we just shown that the first bit will be always represented as 0. So we cannot use that. Understood? So remaining, how many number of networks are there? So remaining, so 2 to the power of 2 to the power of 7, you have around 120. It's 128. No, 128. No, it's 126, I guess. Yeah, 128. Out of that, you will have to subtract 2. We'll just see why. So you will get 126 network addresses. Okay, we are going to discuss that. Before that, let's see about different classes. There are different subnet masks. Okay, so in a class B network, the default subnet mask is 255.255.0.0, which means how many bits are there for network and how many bits are there for host?
16 bits.
16, 16.
16 for network and 16 for host.
16, 16.
Yeah.
Yes, sir.
And for class E, it is 255.255.255.0.
24
24 for network and 0 for host.
24,
Yeah.
8 hosts, sir.
Yeah. Yeah. So right now, looking at the subnet mask, you will be able to understand which class this IP address belongs to. It's easy for you now, right?
Yes.
Yeah.
Okay. Now we are going to find out. We just saw that how many number of networks are present from 0 to 126. So we are going to find it out. Okay. So in class A, we have around 8 network bits and 24 host bits. So you can see the number of network bits is 8. The host bits is 24. We are going to find it out from 0 to 127. Here, available number of network bits that are 8. We have to subtract the first bit, that is why 2 to the power of 7, you will get 128. Why the first bit? We cannot use the first bit because the first bit is reserved here. You can see the first bit is always reserved here. You cannot put any value over there. So 2 to the power of 7, you have 128 networks. Out of that, 0 and 127, you cannot use. So you are subtracting that. 0 and 127, you cannot use. So you have around 126 networks in class A. I hope it's clear.
So there are 126 different network portion along with the host portion, right?
There are, okay. In each of this 126 networks, you will have 24 network host bits, which means 2 to the power of 24, you will get 16777,216. Out of that, you will be subtracting 2. One is for the network and one is for the broadcast. Let's see how it will look. Okay. So let's take one IP address. This IP address is 1.0.0.0. Possibly this is the first IP address that belongs to class A, right?
Yeah.
Okay. So how many, which means the subnet mask is 255.0.0.0. So which means how many network bits are there?
8, sir. 8.
8 network bits. Okay. But since the network bit is constant, we cannot do anything now. So we need to find out how many number of hosts are present in this network. Okay. The first IP address will be 1 dot. Okay, we already saw we already saw the number 2 to the power of 24 number of hosts can be accommodated in this network. So the first IP address will be 1.0.0.1. Why? Because the host portions will start writing it from the last octet to the first octet. Network portion will travel from the first octet to the last octet. So this IP address is known as the first valid IP. This is the network address. Okay. The second address will be 1.0.0.2. This is the second valid IP address. Then the third address is 1.0.0.3. And what is the last value that I can accommodate in this octet? That will be, I'm not writing all the values, I'm just reaching to this value now. 1.0.0.254. And what is the next value, guys?
255.
1.0.0.255. You are right. And what could be the next value?
1.0.1.
257.
No, it's 1.0.1.
1.1, sir. 0.
It will start
Zero, sir.
from 0.
Yeah, it's 1.0.
0, sir. 0.
Yeah. The next value will be 1.0.1. 1.1. And the next value will be 1.0.1.2. And it also reached to 1.0.1.254
and 255.
Yeah. No, let's write it. You already understood, no? What would be the next value?
1.0.2.0, sir.
2.0.
1.0.2.0.
2.0. Right. Okay. So what can be the last value? That will be 1.1.255.255.255.
Yeah.
This is known as the broadcast address. Okay. This is known as the broadcast address. And one address before the broadcast address, that they will be known as the last valid IP address. 255.255.254. Okay. This is the last valid IP. Okay. So I'll just show you a few details.
So 1.0.1.255 is also a valid IP, right, in this network?
It's not a valid IP. That is what I'm going to show you. Okay. Look at this scenario. Here I am using this network 192.168.10.0 network, and this is the last address, that is the broadcast address 192.168.10.255. This is my broadcast address. I haven't assigned that IP to any of the device. That IP address you can see it from 10.1 to 10. The IP address are assigned is 1 to 10.4. If you are just going to desktop command prompt, you can just ping 192.168.10.255. Okay, this will go infinite. So I'm just pressing Ctrl C. Coming to simulation. Now I can show you. A packet is created. This packet is basically broadcasting this message to all the devices. So this is a broadcast packet. Okay, this is basically used to communicate to all the devices in the network. That is basically used for broadcast. This broadcast IP is an IP which is used to communicate to all the devices in the network. You can see the ICMP packets, it's individually going to all the devices. They are coming back and giving the reply. You can see it. So this broadcast IP is an IP you cannot assign to any device. And the first IP, that will be the network IP, which is used to identify the network address. That is 1.0.0.0. You cannot assign this IP also anywhere. So you will have to in the host numbers, you will have to subtract two numbers. That is, one is for the network address and one is for the host address. After that, you will be getting 167.77.214. So when somebody is asking you the number of hosts that you can accommodate in a class A network, I don't want you to memorize this value. You can just say 2 to the power of 24 minus 2. Okay. How many number of networks? 2 to the power of 7 minus 2. Or this only works in class A because we have to subtract 0 and 127. So let's see one more example. Okay. So we have a huge requirement of an IP address. We wanted like more than 1 lakh of an IP address to accommodate in our sales team. Okay. So this is our company. Our company's name is Pluto. Since we wanted to assign lot of IP addresses, lot of people we want to add it to a network, our network administrator, they bought one network address. The network address is the second IP address that you will see in the class A address, that will be 2.0.0.0. They purchased this network address from the ISP. So this is the network address. So this is used to communicate to all the 1 lakh devices. To identify that, you will be using this network address. You cannot assign this. Okay. And the subnet mask is, as you already know, in class A, it's 255.0.0.0, which means 8-bit for networks. So how many number of networks I can able to create? It's already one. But in class A, you can assign 0 to 126. But this is just the second network from 126 network. Okay. So the first IP address that you're going to assign is 2.0.0. Okay, this is the first address, that is the network address. Okay, so that you can take notes. First address will be 2.0.0.1. The second address will be 2.0.0.0.2. Like that, it reaches to 2.0.0.255. 255. Then what would be the next value? 2.0.1.0. Yeah. And what would be the last value?
2.0.1.25.
2. No, how 2.0?
255.
No, what is the last value? The last address.
2.255.
255. Yeah. And the last valid IP address will be 2.254. 254. Okay, no, sorry, 255.255.254. So this is the first valid IP, and this is the broadcast address. Okay, so these two addresses you will have to subtract from the number of hosts in, that is what you were seeing. Okay, this address and this address, the first and last address you cannot use anywhere.
So broadcast address is something which will be assigned to the router, right?
No, that is by default present inside the network.
Okay. If we send any message.
Yeah, for broadcast purposes, if you want to communicate to all the devices, for example. So this is a very important tool. Okay. So when we discuss ping, you can easily understand. Okay. So if you you might have seen this in your office. The moment that your system is going down, before you report to the IT team, sometimes the IT team might be already knowing that, and they might be contacting you first. Why? Because in most of these companies, in small companies, in big companies, you don't have to do that. In small companies, you can see that from the IT admin's PC, there is a continuous ping test that is going on, which is to make sure that are you still connected. Okay, so you can basically ping on which IP? You can basically ping on the broadcast IP. So if you're getting reply from all the devices, you can understand that you have communication. You have communication to all the devices. The moment that you stop receiving it, so here I was pinging all the devices. You got reply from 2, 3, 4, which was basically the old devices. Also from 10, that is a default gateway. Again 2, 3, 4, 10, which means I'm still connected. If you keep this ping won't stop. This ping will be basically pinging to all the devices inside the network until you actually come out of it. So you can actually know the moment that any of this is dropping, again you get a message from 2, 3, 4, 10. So the moment that any of this is going down, you can clearly understand that one of the devices is down. You have to immediately find out what is the cause behind that. So broadcast IP you cannot assign to any particular devices. I hope it's clear. Any confusion?
I have a question.
Yeah.
Is the broadcast IP reserved for particular purposes in a company?
No, we are not reserving it. It's by default, that is a property of a broadcast address. You are not you don't have to assign it. You don't have to do anything with broadcast. But you just have to understand what is a broadcast IP in that particular range.
It's still
Okay.
confusing. With time on this.
Yeah. What is your confusion?
What is the purpose of the broadcast IP?
We just showed what is the purpose of broadcast IP, right?
In case there is a downtime in the company,
I mean, that is just one of the device. That is just one of the many benefits of using a broadcast IP, Grace. The main purpose of broadcast IP is that if you're using broadcast IP, you will be able to communicate to all the devices inside the network.
That is the main purpose, but it's not used.
Okay. What?
But it is not used.
It is used if you want to communicate to all the devices. For example, you can send a message to me in the WhatsApp group. Also, you can send me a direct message. Okay, both serves the purpose, right?
I got it.
Yeah. So, but in two scenarios, there is a use of WhatsApp group so that other people also can contribute their feedbacks to it, right? So, like that, if you want to communicate broadcastly, you might have communicated over WhatsApp, or else you would have sent me a direct DM. Okay, as of now, in the syllabus, you're not going to use anything with the broadcast IP. Now, what was our intention is, in class A, how many number of networks we have? We have 126 networks. In each of these networks, we have 167.77.214 host for each network. So out of how many networks are there? 126 network. Each of the networks will be having this many number of hosts. I hope that's clear.
Okay. That means you can have 1 million. What is this? 1 million. Oh, this is 1 million. So many. I don't know how to pronounce this out.
Yeah, I prefer to say
this number of, for example, PCs in this network.
Yeah.
And host. Yeah. Okay.
Not PCs. This number of IPs will be available if you're using a class A network.
IP addresses.
Yeah, IP addresses.
But I thought IP addresses are assigned to each end host. Each IP address.
You have to assign IP from this range.
Okay. Okay.
Now coming to class B. Okay. In class B, how many number of network bits are there? 16 bits. And number of host is also 16. Okay. So you need to see how many number of networks you'll be able to create with class B. So ideally, you have to understand this is a standard equation, guys. The standard equation is 2 to the power of the number of bits. Okay. So how many bits are there actually there? 2 to the power of 16 bits are actually there.
16.
But we cannot use 16. Why? Because the first 2 bits are reserved there. You might have seen that it's 1 0, right? So if you convert any value which is in class B, you will see the first 2 bits are always 1 0. This is constant, which means this is the most significant bit, and you cannot use this bits. So after that, how many bits are there? 14. Yeah. So you have to understand it's 2 to the power of 16
minus 2.
Minus 2. You have 2 to the power of 14 number of networks you have in class B. And you have 2 to the power of 16 number of hosts per network. In class B, you have the number of network bits is 16, number of host bits also it's 16. So available number of network bits it's 16, but the first 2 bits are reserved, that is 1 0. And after that you have 14 bits, 2 to the power of 14, you have 16384. This many number of networks you will be able to create in class B. Okay. And in each of these networks, you will be getting 2 to the power of 16 number of hosts, that is 65,536. So out of that, you will have to subtract 2. One is for the network and one is for the broadcast. So can any of you guys give me one class B address? Any class B address that you think? What is the range? It's starting from
178.
128 dot 128 dot 0.0.0. Okay. Okay, that is an IP. So you can say anything with 128 and the first 2 octet it's fine. After that it's 4 bits, so you cannot use it. So what is the default subnet mask for this network?
255.255.0.0.
255.0.
0.0, which means the first 2 octets will be constant, right? You cannot change anything.
Yes.
Okay. So the first IP address will be 128.0.0.1.
1.
Then it will be 128.0.0.2. It reached to 128.0.0.25, right? What will be the next address? 128.0.
1.0.
Yeah. Again 128.0.1.1. It reached to 128.0.1.255. Again the next value will be 128.0.0.2.0. And what will be the last value, guys, here?
128.0.255. 0.255.25.
Exactly. This was a little tricky, but I'm glad you got it. Because the first 2 bits are for network. Network bits won't change in the network. Only the host bit will change. The host bits are only the last 2 octets. So the last valid IP address will be 128.0.255.254.
So how many IP addresses are available?
Okay. What did I just tell you? So everything happens on the base of bits. So here the base is 2, and 2 to the power of how many host bits are here? 16. We have 16. So 2 to the power of 16 number of hosts you will be getting. Out of that, you will have to subtract 2.
Minus 2.
Minus 2. Why? Because 1 is for the network that I just marked 128.0.0 and 128.0.255.255. You will have to subtract. So you will get this value 65,536 minus 2, 65,534. This many number of class B addresses are there.
In one network.
In one network. Okay. Guys, what is subnet mask? Why do we use subnet mask?
To identify the classes.
Okay. We can identify the class. That is one of the many use, but that's not the main use of subnet mask.
To reduce the IP addressing.
No, subnet mask. Subnet mask.
To identify the network bits.
Exactly. To identify the network bits in an IP address. So how many bits are there in an IP address? 32 bits. Right. So in a 32-bit IP address, we use the help of subnet mask to identify what is a network portion in an IP address. Network portion will always remain as 0. Okay. So what is the default subnet mask of class A?
255.0.0.0.
0. Which means how many bits for network?
8 bits.
8 network. It's for class B?
255.255.
No, 0, 16 network. It's class C. The default subnet mask is 255.255.0. It can be for network. It's okay. So in yesterday's class, we were discussing. Okay. So how many number of networks you can create in class A network? So you know that the class A range is starting from, what is the range of class A? 0 to 127.
127.
Yeah. How many number of networks you can create in class A? 2 to the power of?
2 to the power of 8.
6. 2 to the
To the
power
power
of
of 16.
Minus 2.
Minus 2. 14.
No, we are talking about class A, guys. In class A,
2
how
to
many
the power
network
of
bits are
8
there?
minus 2.
2 to the power of 8 minus 1.
Minus 2. 1.
Minus 1.
Okay.
Why?
Why, man?
Why? Because all the binary, the maximum value that you can create if you're writing this value in binary, the highest value will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is basically 127. Okay, so the first bit will be always remaining as 0. This is a network portion we are talking about. So total we have how many bits? Total we have around 8 bits. So 8 minus 1, so you have 7 number of networks. 2 to the power of 7, you have 128 networks. Okay, this is also one. Yeah, this is 127. Yeah, so you have 2 to the power of 7, 128 minus 2. Why? Because you have to subtract 0 and 127 from it.
127. Yeah.
So you get 126 networks. And number of hosts is equal to 2 to the power of how many host bits are there? 24 host bits are
24, sorry.
there. Yeah.
24.
Okay. And 2 to the power of 24. Once you've done that, okay, minus 2, you get number of valid host. Okay. Yeah. So we were just revising things. Now it's 9:05. We'll start the topic. Okay. Yes, in today's class, we are going to discuss a topic that is known as subnetting. Okay. The topic that we are going to learn today is subnetting. Subnetting is a process of dividing a larger network into smaller network. Okay. Imagine that we are creating a company. Okay. So in this company, we have IT department, which there are around 30 people. There are 30 people who are working in IT department. In sales, we have 60 people who are working. In admin, we have around 5 people who are working. And in accounts, you have 10 people. Okay. So in order to communicate to the internet, they need an IP address. So the network administrator, they need to purchase one IP address. Okay. So all you have to understand is that the different departments over here, the different departments, they need what different network addresses. They can't operate in the same network. Why? Because if it's the same network, so much confusion will happen. Like you already read that IP address is a unique address which is used to identify the network, the device, the location. So based on the different network address, we are identifying the different network. Okay, for example, in the IT department, which class IP address I should be using, whether I should be using a class A IP address or class B IP address or a class C IP address. Guys, which class IP address? Class C. Okay, why? Because if you're using class C, how many hosts we can create in class C? 256 minus 2, you get 254 IPs you can create in class C. So if you look at class B and class C, like you will be getting more number of IP addresses, and you don't need that many IP address per network. So you can know that the easiest method is to reduce the maximum wastage of IP. To reduce the wastage of IP, you can use a class C IP address. Okay. So if you use a class C IP address, for example, for this IT department, I put this address. This address is 192.168.10.0. This is the network address for IT department. So there are around so many people who are working. The IP address will be ranging from 192.168.10.12. Here you have 192.168.10.30. Up to here, you are using IP addresses. So here, how many IP addresses wasted? 256, 254 minus
224.
is equal to 224.
Yes.
Waste. Okay. So you wasted around 224 IPs. For sales department also, I'm not starting to write it, but you can understand the first network address will be if I am using a 200.200.200 network, it will be 200.200.200.1. So anyway, the valid IP address, since we are using class C, it is only 256. We will use the valid IP. So 254 minus 60. How many IP address you have? How many IP address are you wasting? 254 minus 60?
194.
194.
194 IPs are wasted. Okay, guys, can you see that there is admin department which needs 5 people, accounts department which needs 10 people, and if you are using a classy address, a lot of IP addresses are getting wasted. Since we already know that we cannot afford to waste IPs, what is the best thing that we can do? Okay, again, the idea that we are discussing over here is subnetting is a process in which we are dividing a larger network into smaller areas. Okay, so you might have also done that in some other mechanism which you will be able to relate. Okay, so how many of you guys eat pizza over here? How many of you guys like pizza? None of you eaten pizza before?
Sorry, what is the question?
How many of you guys like pizza? Pizza.
Everyone.
Everyone
Most
likes
of
pizza,
them.
right?
Yeah.
Okay. Yeah. Okay. It's good. So when you are ordering a pizza, okay, for example, you might be calling Domino's for ordering a pizza. So when you're calling Domino's, you might be eating how many pieces? Like, what is the maximum number of pieces somebody can eat over here?
Maximum 4 slice.
I can eat hardly one, but yeah, two. Yeah, see you see the variation, right? Some of you guys want two, some of you guys want four, some of I just want one piece. So when we are ordering pizza, so you won't be calling Domino's and saying that, bro, I just need one slice of pizza, right? You can't order like that. Okay, first you will see what is the size that you need, how many people are there. So based on the size, what you will be doing, you'll be ordering one large piece of pizza, one more extra large pizza. Once the pizza is here, you won't leave the burden to the Domino's person. What you'll be doing, you'll be taking the pizza, dividing it and sharing it with other persons, right? So everybody's need is fulfilled and there is no wastage which is done. The same process happens over here. Okay, so here, see this address. Okay, so here I need 2 networks. In IT, I need around 60 IPs. Sales, I need 30 IPs. Admin, I need around 10. And HR, I need 5 IPs. Okay, so if what I am doing is I am going to divide by a class C network address. Okay, so this network address is 192.168.10.0/24. Okay, so in yesterday's session, just to put the confusion outside, in class B, you already know that you have 2 to the power of 14 number of networks, that is 16384. Okay, and in class C, you have 2 to the power of 21 number of networks, that is 2097152. Okay, so the IP address that I've written over here, this is just one among the many IP address that are present in class C, that is among 2097152 IP addresses, the network address that I written is that is one among the this many number of networks. Okay, so we already also know that the fact that in this network we have around like 2 to the power of 8 number of host bits, which means 256 IPs we have. Okay, so I bought this large, imagine this is the large piece of pizza that I am buying. Okay, so if /24 is 255.255.255.0, which means again 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. This is it. Okay, using this, so what is the only option that I have? The only place that I have is the last octet. The rest, all the octates, it's constant because we are using /24. We cannot change any of the network bits. It's completely full. 255, we cannot do any change. 255 also, we cannot do any change. This 255 also, we cannot do any change. It is completely full. So there are no host bits. So this is the only octet that is remain to us. Okay. Using this octet, please observe, this is like a container. Okay. This is like a container where the starting IP address will be 0 and the ending IP address is 255. So in this container, you can assign IP address like from 192.168.10.0 to 192.168.10.255. Do you have any doubts up to here? Please let me know, because once I move forward, please don't ask me to come back.
No. Can you please explain again this box?
Okay, so Grace, this box is nothing. This box you can imagine like a container. You can assign IP address which is starting from 0 to 255, right?
Yeah.
So this is the 8 net host bits. So you only have option to assign IP address in the last octet. This last octet, just to put this in a metaphorical way, I use this box. So in this box, what I mentioned is that you can start assigning, imagine like a box or a bucket. So you can start assigning IP address starting from 192.168.10.0 to 168.10.0 to 192.168.10.255. The last octet is something which I represented in the form of the box. Okay. Okay. Imagine you are having your lunch, and some of you guys might have seen that your colleague is not having lunch because they're busy and they didn't order food. Okay. And you have a large piece of pizza. What you will do? You will be sharing one portion to your friend, right? I think most of us do. We'll be sharing a portion from our plate of pizza to the other person. So we'll be dividing it on the basis of like quarter, half, based on the particular portion that you find which will be fulfilling for you, also which will be convenient for the other person. Okay, look here. Here, using this many number of network bits, you just have one network. Okay, so you don't have more places to create another network. Subnetting is a process in which we are dividing, making a larger network into smaller network. Okay, so to do that, what we are doing over here is we are again going to change the network bits and the host bit. Okay, it's 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Okay, now we can only do alteration in the host bit places. What I am going to do is I'm going to borrow one bit. Okay, so 1 2 3 4 5 6 7 8. So we are going to borrow one bit from the host bit, and we are going to make this as the network bit. This bit will be, for our reference point, this bit will be known as a subnetted bit. So right now, what is a slash value? So right now, what is a subnet mask value?
255.255.255.254.
128.
128.
128.
128. Okay. Now, when we borrowed one network bits, we need to find out how many number of networks we can create since we borrowed one network bit. The number of this networks that we are going to create, these networks are known as a subnetworks. Number of subnetworks is equal to 2 to the power of subnetted bit. How many bits we borrowed?
Just one.
One. So 2 to the power of 1. How many networks you have?
Two.
2. Okay. You can understand that when we were having one network, how many hosts we were able to allocate? 256, right?
Yes.
Network.
So in one network we had 256 IP address, right? So in this we were having 256 IP address. Right now we divided that into 2, which means I divided this container into 2 equal parts now. Okay. So the first network will be starting at 0 to 127, and the second network will be starting from 128. So you can simply understand this by dividing 256 divided by 2. But trust me, this is just for the visual representation. We are not going to use this method. 256 divided by 2, what is the answer?
128.
128. So until now you had 256 IP address, you just divided that into 2, you have 128. So 128 will be the second network that you are creating. So right now you subnetted and you created 2 networks. Are you able to understand that? You borrowed one host bit and made that as a network bit. So right now you have 2 network portions. Okay. So the first network will be starting from 192.168.10.0, and the second network will be starting at 192.168.10.128. And the first valid IP address in the first network will be 192.168.10.1. And in the second network, the IP address will be 192.168.10.129. Okay, this is the first valid IP address for both the networks. And the last valid IP address is 192.168.10.127. Okay, this is the broadcast IP, not the valid IP. And the broadcast IP for this network is 192.168.10.255. And the last valid IP address also we'll mention 192.168.10.126. And the last valid IP over here is this network is 192.168.10.254. 254. Okay. That's just been missing. Okay. So this is the network address, 2 network addresses. This is the broadcast addresses, and network address, valid IP range, broadcast address. Any doubts? Any questions?
John, I have a question.
Shoot.
What is the reason for the first IP, for the first network ending at 127? What is the explanation?
Okay, because the second network is starting at 128, right? So I cannot have my last broadcast address in the second network. It should be ending at where, imagine this like a boxes. Okay. So when you are dividing this box into 2 equal parts, you cannot still argue for the same length and breadth. Okay, so you know that like this is the block and this is the first block and the second block. There is an ending portion, right? The second block is starting from here. Okay, the second block is starting here. The second block is starting on the place which is marked as red. So the first portion should end where? Here, like on the green border. So the second network is starting 256 divided by 2. You know that the second network is starting at 128. So you know that the first network should end one IP address before the second network. I hope that explanation might work rather than the picture that I draw. Guys, are you okay with the answer?
Yeah, I'm okay.
Okay.
So John,
Guys,
actually, I have
one more
question.
thing. Oh, yeah, please.
So John, actually, we have already 256 valid IPs, right, for a host?
No, 254.
Yeah, 254. So why we need to take the 2 networks? If already 10.0, we can start with 10.1. We can keep it 10.255, right?
No, why? Because this is a separate network and this is also a separate network. So right now, using this value, using this value. The second, so this network is slash subnetted with, this network won't be codeless. So right now the new network address for this is 192.168.10.0/25. It's not 255.255.2550. It's previously it was 255.255.255.0. Now it's 255.128, which means we have two networks. We need two networks. Okay, we can't assign IP address in the same network. For example, if I'm sending a message, for example, this is an ITT. Okay, this is sales team. So whenever I'm communicating something with the IT team, so if I was using one single network, so all the messages that I'm sending to IT department will also send it to sales department, right? All the messages that I'm sending in sales will also be received in IT department. We don't want to do that. We wanted to separate different networks with different departments or different sections with different network for better assignment of IP address and to track the devices, to manage the devices, to make the network more effective. So this is the common mechanism that we use. So different departments, we'll put that into different networks. Is it clear?
So we get
Yes.
two
One thing
broadcast
more.
heads.
What?
One thing on I want to ask now: how we divide that two network into four departments? Like IT has 60 person.
No, we
sales
didn't
has
divide it
30.
into we didn't divide it to four. We only divided it to two networks.
Two networks. Okay.
Yeah. So if you want to,
In two networks, we have to. In these two network, we have now in these two network, we in both of two network, we in one network we put two departments, and in another network we put two departments.
no. In one network, we divided that one larger network into two smaller sub networks.
John, may I ask you something?
Yeah, sure.
Okay. Actually, I'm not. I'm actually new here. This is my first class today. I'm not sure that if you have already told this or not. May I be? You told that first network address for any subnet is going to be the first one, and the last one is going to be the broadcast address. I am familiar with the network address. It is the it is how we recognize that particular subnet. That this is that particular network. May I know what is the use? How do we use the broadcast address? I know that it is used to send broadcast messages across the whole network, but how do we practically use that?
Practically, we use it to communicate to the whole network.
Yeah, I got you. I mean, how? I mean, how do we send a message through this
So
network?
it
For
is not
example,
mostly done by us. The only operation that you can do from your side is to send a message to. You can do a ping test on the broadcast IP. You can so that you can see whether all your devices are up. So if you don't receive any ping reply back on any specific
okay.
IP which is mentioned in the broadcast, you already know that that device is down. That is one method for troubleshooting real-time application purpose. So other uses of it, like some other routing protocols like EIGRP, OSPF, when they are sending routing updates, so they can use this broadcast IP so that they are not sending the information to the particular network interface, so that they are just sending the network to so some updates if the other routing protocols, if any other. So this broadcast IP is mainly used by other protocols, major protocols that are not used mostly by us. The only common use that you can do from your side, again, which is a great help, that is used to ping the broadcast IP. If for the system admins, network admins, they will keep putting that in their continuous ping test so that they will get an update when system is down. So before the customer raising a ticket, so they will know that the issue has already created and they will immediately start resolving it. So that is one method that you can think of. Other things are done by the protocols, not by us.
Okay. Okay. Thank you.
Yeah. There's any other questions?
No, sir.
Okay. Now look here. One 192.168.10.0. I'm going to so the original subnet mask is 255.255.255.0, which means 1234567.8.1234567.8 dot 1234567.8 dot 1234567.8. Okay, previously I borrowed 1 bit. So right now I am borrowing 2 bits. So this bits will be my network. This bit will be my subnetted bit. Okay. So can you tell me what is the formula to find out how many number of subnetworks we can create? So by default we had 1. So how many number of subnetworks we can create using this?
We are going to
Number of
2 to the power
subnetworks is 2 power?
2 to the power of 2.
2 to the power of 2. So you know that you have 4 networks.
4.
Okay. Okay, now I will give you a basic tip to do subnetting. So what I can promise you is that like by tomorrow or day after tomorrow, I'll teach you how to subnet with Mind. Okay, so in CCNA exam, you will get hardly like 30 seconds to finish a subnetting question. If you really want to pass the exam, you will get like hardly 30 seconds. So within 30 seconds, you need to subnet. So most people use different mechanisms. So to learn subnetting, there are n number of mechanisms which are out there. Okay, so I don't restrict you going and referring to all, but if you are confused, I would recommend to follow my method because I find this is the most simplest method that we can do to subnet. Okay, so what I can guarantee is that like by tomorrow, I'll make sure that you can subnet without by just looking at an IP, with just looking at a subnet mask. So you will be able to do the subnetting from your mind itself. So can you tell me what is the coming back to it? Can you tell me what is the subnet mask in decimal value, the subnetted value? So right now this is 255.0 and we are subnetting
255.
Yeah.
255.255.255.64.
255.192.
192.
Guys, this should be very important. Okay, so the only thing that I ask you in return for what I promised is you need to find out. So whenever we are borrowing 1 bit, 2 bit, 3 bit, 4 bit, you immediately should understand what is the default subnet mask value. So if you're borrowing 2 bits, it's 1 second. It's if you're borrowing 2 bits, 128 plus 64, 192. If you're borrowing 3 bits, 192 plus 64 plus 32,
Plus
224,
32.
240, 248, 252, 254, 255. Yeah. So who was asking the question?
Yeah, actually, here you are writing zeros 5 bits. Are you replacing the zeros with 1 or you putting that borrowing numbers with the 8 bit of zeros like that?
Yes, I am borrowing the bits from the host portion because 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So you already know that the network portion is constant. You cannot change anything which is there in the network portion. You can only, so I want to create 4 networks right now. So what I do is that if I know that if I borrow 1 bit, I can create 2 networks. So to create 4 networks, what I did was I just borrowed 2 bits. So 2 to the power of 2, it's 4. I already know that. So from where I can borrow, I can only borrow the bits from the host portion, right? So I borrow 2 bits from the host portion. Clear?
And when you borrow 2 bits, John, how many zeros are supposed to be behind? Because I'm seeing here 7.
Extra 1 0 you
4,
put it
5,
in.
6. It's 4 plus 2. Yeah. Please
Okay.
don't count.
Now okay.
Now it's
Yeah.
Now
You
okay.
guys are counting the zeros.
Yeah.
Okay. Very good. 2 jobless.
Because it was 7.
Actually, it's a little bit confusing. That's why I'm asking.
So I keep repeating this thing like please don't count the zeros and ones. You guys are still doing it. Okay. The number of subnetworks is 4. Okay. The first tip that I'm going to give is the first network will be always the network address. That is 192.168.10.0. This is the starting portion, right? So now we need to know that what is a second network. Okay. This is the tip. Okay. So in order to do that, so previously we were using like 256 divided by 2. This only works in class C. So we use a standard formula. Standard formula that is known as to find out the block size. To find out where exactly one block is ending and where exactly one block is starting. So the equation is 256 minus subnet mask value. Okay. So what is the value? 256 minus what is the value that I should be subtracting?
2, 4.
192.
192. 192. What is the answer?
64.
64. Yeah. So my second network will be starting on 192.168.10.64. My third network will be starting at 192.168.10.64 plus 64, 128. And 192 plus 168 plus 10.128 plus 64, 190.
92.
Yeah, 192. Okay. And the first valid IP address here is 192.168.10.1. And the first valid IP address of this network is 192.168.10.65. The first valid IP address of this network is 192.168.10.129. And this network gets 192.168.10.193. And the broadcast IP is 192.168. Can you tell me what is the broadcast IP? 10 dot?
10.63.
63.
63. Yeah. 63. So one IP before the next network. So if it is helping you. So what is the broadcast IP of this network? 192.168.10.127. 127. Yeah. Of this network, it's 192.168.10.191.
191.
191. And this network, it's 192.168.10.10.
255.
255. Brilliant. Now, the last valid IP address is 192.168.10.62.
62.
And here it's 192.168.10.126. Here it's 192.168.10.190. And here it's 192.168.10.254. Okay. If you want, I would recommend at least take note for one of it or take a screenshot, whatever which is convenient for you, so that when you're practicing, it will be helpful. Network address, valid IP range, and
Broadcast address.
broadcast address. Okay. So the next question that I'm going to give you is 192.168.10. Hello.
Okay, so the addresses that we have been divided into four, what will be the subnet mark if you want to put it? If I want to assign an IP to a PC with the address that we have been divided into four, what will be the subnet now? The subnet marks for the address that we have given.
I didn't understand your question.
Okay, for example, with the 192.168.10.1, what would be the subnet mask for that IP? Since we have divided
Okay.
into four.
Okay, you tell me.
That is the reason why I'm asking.
Okay, what is the subnet mask value we changed? We changed it to 255.255.255.192, right? So this is the subnet mask we will be using. So this is the new subnet
Okay, so
mask,
this
right?
is the
So when you are assigning this IP to
that
a
would be
PC, so this will be the subnet mask value. Okay. So this
for
is the
all
new
the IPs that
yeah, for all the IPs. Good
okay.
question anyway. So this is the subnet mask value that you should be writing. Okay. Now, next question that I want to give you is 200 dot 200 dot 200 dot 68. Okay. Slash 27. Okay. I want you guys to find out in which subnetwork this IP address belongs to. In which subnetwork this IP address belongs to. How we can do that? First, we can easily find out what is a network address. So, what is the default network address of a class C address? It is
192.
Yeah, class C
subnet mask
address.
value. Subnet mask value. What is the default subnet mask value?
255.255.255.0.
255.0, which means 0. So, which means the actual network was 200.200.200.0. Okay, which you subnetted. This you understood, no? How we find out the actual network address, because this is a class C address. So we already know that this is the default subnet mask, that is 255.255.255.0. So we easily understood what is a network portion and what is a host portion. We understood that the first 3 octets are completing the network and the last octet is for the host. And you are subnetting that with /27, which means what is the subnet mask value? 255.255.255.27. What is the value? 27 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please don't count the 1. 1, 2, 3, 1, 2, 3, 4, 5. Okay. What is the value here? 192 plus
224.
224. Okay. So now this is just one of the IP that is belonging to the subnetworks. Okay. So number of subnetworks. What is the equation that we use? 2 to the power of subnetted bit. How many bits we subnetted? 3. So how many networks we can create? 8. Right? So how do you find out what is from where the second network is starting? We use a standard formula. This is the easiest and most convenient method. 256 minus what is the subnet? 224.
224.
Hello. Hi, good evening, John.
Good evening, guys. I hope all of you guys are doing good. So in yesterday's class, we were basically discussing about subnetting. What is subnetting? Subnetting is a process of dividing a larger network into smaller networks. This is to reduce the wastage of IP address to effectively manage the network. Okay. But if you see this thing, okay, let's take an IP address 200.200.200.0/32. Can I use this range to subnet /32?
Yes.
Okay. If I use /32, the subnet mask it's going to be 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Network portions are represented by 1 and host portions are represented by 0. So is there any space for host? Is there any host that we can accommodate if we're using /32?
No.
No, right? So what about 30 /31? Okay. So can I use /31? Guys.
Yes, but 0 host.
Okay. But again the answer is if I am using /31, so I have 2 network portion basically. That is, my IP address will be starting from 200.200.200.1 to 0 to what? 200.200.200.2.
254.
No. How? What is the block size?
Okay.
Okay. What /31 means? What is the value? That is 250. Okay, this is not 1. This is not 2, guys. This is 1. Okay. 250 6 minus 250.
254.
Okay, the answer is 2, which means the next network will be starting from 2. So your first network, so basically you have two IP addresses, that is 0 and 1. Okay, so which means the first address is by default for the network and the last address is for the broadcast. So can I assign any valid IPs in this range? Of course not. Okay, so what is the last slash value that you will be using inside a network? So inside a network, the last value that you could use is /30. Why? Because how many valid IP addresses you'll be getting? You will be getting 4 IPs. Out of that, you will be getting 2 valid IP. So when you are using a point-to-point connection, you can use /30. /30 will give you 4 IPs. One is for the network, one is for broadcast, and you have 2 valid IPs for the host options. Is it clear, guys?
No, John, that was a bit fast for me to understand.
So what I said is, if you use /30, you will get 4 IP. So which means you will get 2 IPs. One is for the network, one is for the broadcast. Also 2 IPs you can assign. But if you use any other values like /31 or 32, you cannot use. That is what I was saying.
Okay.
Okay. Any other questions? Okay. Now it's time back. We'll start discussing class B subnetting. So let's take an IP address. Can you guys tell me what is the range of class B? 128 to
128 to 191.
191. So 128.1.0.0/17 is okay. This is my network, which is by default 255.255.0.0. What I want to do is, what is my objective is that my objective is to create 2 networks. By default, using the subnet mask, how many networks we have? We have just one single network. So what I want to do is, I want to create 2 more networks. So how many bits I should be adding? How many more bits I need? I just need 1 bit to add 2 networks. Okay.
One bit to have 2 networks, sorry. Yeah.
Yeah. So if I add 1 bit, the subnet mask will become 128.1.0.0/70. So /70 means it's 255.255.128.0. Okay. So now how do we find out how many number of networks we can create? So number of subnetworks is equal to 2 to the power of 2 to the power of 2 to the power of 1. The answer is 2, which means you have 2 networks. By default, you already know that the first network will be the same network address. So 128.1.0.0. The second network, how do we find out? What is our golden formula that we use to find out what is the block size? Any of you guys remember the equation that we used to find out the block size? 256 minus subnet mask value, that is 256 minus 128. The answer is 128. So the second network will be starting from
129.
No, 128.0. Okay, so what I was emphasizing is, so in which octet you should be adding this 128. So /17 is coming in which octet, guys? So /17 is coming in the third octet. So all you have to understand is that the network portion will travel from the first octet to the last octet. Like this, the network portion will fill. The host portion will travel from the last octet to the first octet. This is how the host portions will be traveling. Network portions will be traveling from when you are assigning. But you can use a standard mechanism that /17 is coming in the third octet. So you assign the block size over there. So my first valid IP address is 128.1. Can you tell me what is going to be my first IP address?
0.1.
0.1. Go outside it. It was good. Now, what is going to be my last IP?
128.1.0.127.
126.
127 will be the direct broadcasting address.
128.1.127.
254 or 255.
255. Okay, 127.255, and the last valid IP address is 128.1.127.25. So this is my last valid IP, and this is my broadcast IP. Let's come here. What is going to be my first valid IP address in this network? That is
128.1.1.0.129. Okay, that for that 128.1.
128.1. So I told the host portion will be traveling from the last octet. So right now we are not adding networks, we are filling the host portions, right? So first we'll fill this portion, then after 128.1, 2, 3, 4, then 255, then we will jump into where? Then we will jump into 129, again 0 to 255, then again we'll come back, then 130, then again so 12255, then 31, like that. What is going to be my last IP, broadcast IP? 128.1.
255.254.
255.255. I'm asking the broadcast IP. Broadcast IP is the last IP, right?
Yeah.
You said the last valid IP. 254 is the last valid IP. 128.1.255.254. Network address, broadcast address, and the valid IP range you will see here. Okay. Next question you have to do it. Then you have to let me know the first valid IP, second valid IP, last valid IP, and what have we did so far. You will have to do it. So the question is 180.2.1.2. Okay, in the next question we'll do that. Okay, 2.0.0 slash. Okay, by default the subnet mask is 255.255.0.0. Okay, and you need to subnet this with, which means right now the default subnet mask is /16. So I want you to subnet with /18. Okay, and please don't send the answers in the group chat. You have to individually share this answer with me. Okay, so there is an option when you're going for the chat, you can personally DM me the answer. Okay, so you need to find out. The first question is number of networks, log size. Once you find out the log size, network 2 and network, network address, IP, broadcast address. So for this, you need to find out and you need to share it with me. Okay, this is the question. If you want time, we can also take a screenshot of how we did this before. Okay, you can take a screenshot of this and take a reference. I'll give you 10 seconds. Okay, what I am expecting from your side, I'll show you. Okay, how you need to give the answers. Okay, this was our question. That deleted. The first question is number of subnetworks, that is equal to 2 to the power 2, that is 4. Okay, then you need to find out the log size. Log size is 256 minus subnet mask value. So /18 the subnet mask is, so /18 the subnet mask is 192. So
192.
So 256 minus 192, you got the answer, that is 64. Okay, so how many number of networks we have? The first network is 180.2.0.0. Okay, guys, all of you clear with this? How we found out this first network?
John, please, I have a problem.
Okay,
when you
my
put
question is a
slash-
direct question. Please answer to my question first, then I will answer to your question. So, do you understood this process?
The first network, yeah.
Yeah. Okay. Now you can ask your question.
When the first example you used 2 raised to the power 1, which was 2. Now you use 2 raised to the power 2. How do you do you use the slash? I have a confusion there.
Okay.
How do you come up with this number?
It's simple. It's /18. Okay. How many bits are there in a class? How many network bits are there in a class B, Grace?
32.
No, it's 16.
In the class B.
Yeah, in class B it's
16.
It's 16. Okay.
Yeah, 8 plus
So
2, yeah.
yeah. So what is 18 minus 16? What is it?
2.
2. So that is the 2 power 2. So in the previous example, what was the slash value that we were using? 17. 17 minus 16, that is 1, right?
Can you please jot it somewhere so that we get it in the notes, please?
Okay.
When I'm doing the replay, I'll be able to follow up to know where it is coming.
Okay. You have to understand this fact first. Okay. So you also need to brush up your basics. Okay. If you don't brush up your basics and come here, you will not be able to do this. Okay. So please remember this ranges, everyone. Okay. In class A, in yesterday's class also, I have written this. Okay. In class A, the range will start from /8 to /15. Okay. So the default subnet mask is 255.0.0.0, which is what we are writing as /8. Yesterday, we have written this for all the networks, for all the class A, B, C. For class B, the default subnet mask is 255.255.0.0, which means /16. So the ranges will be going from /16 to /23.
20.
Yeah. Class C ranges will be going from /24 to
32.
/32. Okay. So /32. Now the subnet mask is 255.255.255.0, which means how many network bits are there? This is 24 network bits. From the day one of IP addressing, we are repeating this. What is the subnet mask of class A, B, C? So you know that is 255.255.0, 255.0, 255.0.0.0. But please use the common sense to understand that 255 means 8 bits. If it's 255.255.255, 8 plus 8 plus 8. So that is 24. Okay. So when you are actually subnetting, when you are actually using subnetting, so when you're mentioning /18, so in order to find out the block size, okay, guys, please take a screenshot or notes if you want of this 180.2.0.0, and the subnet mask of this is 255.255.0.0, which means it's 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. This was the previous subnet mask. Okay, right now, which means I can write this as /16 right now because 255.255. Now I want to change this value to 18. This is the /16 is the default subnet mask. So when I'm changing this to 18, I am adding 2 more network bits. This bit is known as my subnetted bit. This bit is known as my subnetted bit. And if I write this value in decimal, I will get 255.255.192.0. Okay. So now number of subnetworks is equal to 2 to the power of subnetted bit. How many bits we subnetted here? We subnetted 2, sir. 2. Yeah. So the answer is
4.
4. Okay. Now, how do I find out the block size? 256 minus subnet mask value. So what is the value? The value that we are talking about is 192.
192.
So 256 minus 192, you get the answer as 64. Okay. Now you can find out the first network, second network, third network, and fourth network. So the first network it's going to be 192 dot no 180.2 dot 2 dot
0.0
0.1 0.0. The first network will be always the network address. Okay, that network only we are starting. So the starting portion will remain the same. So the second network is we need to add the block size. 180 dot
2 dot
2 dot
64 dot
64.0. Okay, again 180 dot 2 dot 64 plus 64
128
128.0. Okay, now the next question is no, the next network is 190 dot 2 dot 190 2.0. Okay, now I'll only write the broadcast address here 190.2.63.255. Okay, here the question is 190 dot 127.2.127.255. Here it's 180.2.191.255. Here the broadcast address is 180.2.255.255. Is it all clear? Anybody who didn't understand this? Anybody any doubts? What?
Yes, sir.
So that the second network we got the 128.2.127. Sorry, 180.2.64.0. So we are calculating as a block size, right?
Yeah.
Okay, that's how we are adding the block size. So we'll get 128 and 192.
Okay. Rahul, when did you join for the class?
It's starting.
Okay. Can you please take a screenshot or notes on this? Okay. Once you give me a confirmation, I'll move.
Done, sir.
Okay. Grace, please take a screenshot. Okay. Okay. Next question, guys. I want you guys to solve this the same way that I solved. Okay. Take use your paint to do this, and you can share a screenshot to me in the chat. Okay. But I want all these mechanisms, and especially for the people who didn't understand. First, you make sure that you follow all the procedures that I have listed over here. Then also, if you don't get, I'll troubleshoot. But your procedure should be there, so you can put that in the paint and let me know. Okay. So the next question is very simple, but I'm not think you are prepared to do that now. So one more question before that. 180. Okay. 155.2.0.0 slash 90. Same thing, you need to find out number of networks. Okay, so to be specific, number of subnetworks, block size, then you need to find out at least the first 4 networks. You have 7 minutes time. So okay, and also please take a screenshot. Once people start sharing these answers, I'll stop the screen sharing. Sandeep, this is the format. Who is sharing this answer? Please share in this format. It doesn't matter if you don't write all the ones and zeros, but at least the number of subnetworks, block size.
Sir, I have typed in chat.
Okay. Please use paint so that I can see your steps. If you make a mistake, so that it will be helpful for you also, no? So that I can see your answer, then we can rectify it where you made the mistake. So this is why I'm telling, when you don't know something, when you know something, it's completely okay. You can follow whatever method you want. But if you don't know the method, just follow the procedure and see if it's working for you. Okay, then if there is a problem, we'll find out on which procedure, on which step we had an issue. Then we will rectify. If you're just randomly throwing me the answer, I also won't be able to help you out.
Okay, sir.
Grace, I didn't get your answer.
I'm still writing.
Okay. So you will complete it here. So 155.2.0.0. The subnet mask is 90, which means what is the subnet mask value here? Here is 255.255.255 dot. How many bits? 3 bits. It's 2 to 4.
2 to 4.
Yeah. Good work. Yeah. Good work. Number of sub networks is equal to 2 to the power of 3. So that is 8.
8.
Block size is 256 minus 224. The answer is 32. So it's simple now. The first network is 195.2.0.0. The second network is 155.2.2.32.0.
32.
Yeah, 155.2.64.0 and 155.2.64 plus 2, 66, 90, 6.0. You got the same answer, right? All of you?
Yes.
Oh. Okay. Guys, if you understood this, now I am going to teach you something that is important, but it will only work if you understood the previous topics. Okay. So the next question that I'm going to give you is 10.0.0.0 slash 9. Okay, what is the default subnet mask? What is the default number of network bits?
8. 8.
8. Yeah, it's right. Okay, 8. And how many bits we changed?
1.
1.
1. Okay, so I'm not doing anything, guys. Okay, so I just want to find out the first network, the number of subnetworks. So I just changed 1 bit. So how many networks I can create? 2 to the power of 1, that is 2, right?
Yeah.
Yeah. So in order to find out the first network, I can simply write 10.0.0.0, which means I don't even have to do any calculation to find out the first network. So I only have some problem which I need to find out on my second network. So if I want to find my second network, what is my equation? I just have to add my block size. So how do I find my block size? I already know the fact that block size is 256 minus subnet mask value. If I use 9, what is my subnet mask value? It's going to be 128.
28. 128.
It's going to be 128. So 256 minus 128, the answer, the block size is 128. So the second network is 10.128.0.0. So simple, no, right? Okay.
Yes.
Now let's discuss a different method. 20.0.0.0 slash 8, 9, 10. Okay. So how many number of networks? How many number of networks we can create if I'm writing slash 10?
4.
2. So 2 to the power of 2. How many networks?
4.
4 networks. Okay, so the first network, no doubt, just writing 20.0.0.0. Second network, I need block size. So if I'm using 10, what is going to be my subnet mask value?
192.
192. So 256 minus 192, 64.
64.
Yeah. So the second network is 20.0. No, 20.64.0.0, then 20.128.0.0, and 20.128 plus 64, 190.
192.
Dot 0.0.
0.0.
So in CCNA exam, you will get hardly 30 seconds to solve this. Okay, so this is the only suggestible method which I will tell you to do. Okay, So basically, you need to subnet. So while looking at an IP, while looking at the slash value, you should be able to identify. You should be able to identify the number of networks and what are those networks. 192.168.10. 201.168.0/28. Okay. How many number of subnetworks you can create while using a /28 value?
2 raised to 4, 16.
2 raised to 4, 16 number of networks. And what will be the block size?
256 minus 4 bits is 240.
240, it's 16.
16, yeah.
16, okay.
Yeah, correct.
I'm not asking the number of networks, subnetworks and all, because you can easily figure it out. Okay, but just to clarify, can you tell me the first network?
Subnetwork of this?
No, first network. First network will be the same network, no? 201.1.1.3.1.
Yeah.
.0.
2.0.
Okay. Yeah. Now, the second question, we'll revise till 9.5 to 9.5. Yeah, it's 9.6. Okay, we'll do 2 more questions, then we'll move on. Okay. So it's 172.16.0.0/90. Okay, all of you guys, I'm not calling names individually. How many number of subnetworks we can create and the block size? It would be better if you could paste that in the chat. Number of networks, subnetworks, and the block size. And what is okay? 19 to the power of 3. It's 8. And what is the block size? Block size is 32. Okay. This topic that we are going to discuss, that is known as classless subnetting. Okay. Classless subnetting. First, we are going to start with the class. First, we are going to start with the class C value 192.168.10.0/9. Okay, which class IP address is this? This is a class C IP address, and in which subnet we are actually doing the changes, and we are doing the changes on the second subnet. And so this slash value, which this slash value belongs to which network? Class A, right?
Yes, sir.
Okay. Yeah. So the network address, when you're writing the first network address, the network address will be 192.192.0.0.0. Okay. In this case, whenever you are working with a classless subnetting, so the first thing, the one and only thing that you will observe over here is in which class this slash value belongs to. The slash value means it's /9. So /9 means you know that it's a class A range. So class A, the default subnet mask is 255.0.0.0. So you are subnetting on the base of 192.0.0.0. And /9, what is the value? That is 255.128.0.0. And now you're doing the number of sub networks, that is equal to 2 to the power of 1. The answer is 2. The first network will be 192.0.0.0, and the second network will be 192.128.0.0. Why? Because we also know the block size. The block size is 256 minus 128. You get the answer also as 128. Okay. Guys, any confusion on this?
No, sir.
Okay. Now, then can I give you a question now?
Yes.
Please do the subnetting with okay, 10.0.0.0/27. Okay. Yes, please comment the answers. Exactly after 1 minute. I'll start. Breathe, you're right. Okay. Next one, subnet mask is Block size is 32, number of networks is 8, and dot 0.0.0. Okay. Okay. Rahul, you made a small mistake. The small mistake is slash value comes in, slash 27 comes in which octet? The last octet. You should be adding the block size on the octet where we are doing the subnetting. So slash 27. Always be mindful of in which octet we are doing it. You are right. So, no, slash 27. So 27 is coming in the fourth octet, bro. 25 to 32. It is coming in the fourth octet.
Yes.
Yeah. Okay. I'll start doing this. Okay, so first and foremost, the only thing that I have to follow over here is slash 27. So slash 27, it's coming in the slash 27, it's coming in the class C network. So, or I can say it's in the class C range. So I know that my first three octets will be the same. 10.0.0.0 will be the same, and I'm doing subnetting. So the changes is actually happening on the fourth octet. So it's 0 slash 27 means 255.255.255.1 no 2 to 4 3 bits.
Yeah,
Yeah.
3 bits.
Number of sub networks is equal to 8. Log size is equal to 32. And the first network is, you know that first network is by default the same network. And second network, how you can find out? You can find out the second network simply by adding the log size 10.0.0. So slash 27 is coming in the which octet? Slash 27 is coming in the fourth octet. So I'm adding 32 here. And the next octet is, next network is 10.0.0.64. So that it goes on. Okay. Now, next question. 20.128.128.0 slash 26. This is the question. The written subnetwork is not 8. This range belongs to a class C network. So it's 20.128.128.0 slash, no, it's like the value itself, 255.255.255.
Zero.
It's 26, which means 192. And now number of subnetworks is 2 to the power of, no, number of subnetworks is 4. Blocks size is 64. So you know that the first network is going to be 20.128.0. The second network is 20.128.64, and the third network is 20.128.128, again 20.128.192.
192.
Yeah, these are the networks. I hope all of you guys. Grace, do you understood this? Yeah.
Yeah.
Your answer is also right. Okay. Now I'll give you some questions. Okay. I'll give you some questions. So I was preparing a quiz, but I didn't get the time to fill it. But this one, so these are some of the questions that actually came on the CCNA exam. So I was just curating few of it. This I'll paste it in the chat. So we'll have it hands-on. So we are done with subnetting. So we practice until everybody is really comfortable with it. Enter the last valid host on the network 172.31.97.192/27. This is the first question. You have 3 minutes time, then we will slow it down each of the time. Enter the last valid host on the network 172.31.97.192/27. Okay, so this 192, it's a common number that I'm getting. So 254, I think that's an absolute guess. Okay, anyway, let's find it out. Okay, so /27 means, so this is a class C subnet mask value. So we are not bothered about which class this IP address belongs to. We are just looking at the slash value. So looking at the slash value, I can easily understand this is the block size is 25, 26, 27. So the block size is 128, 64, 32. So block size is 32. Now, what is going to be my next network? 192 plus 32. The answer is 224. Okay. So my next network is going to be, so my first network is 172. This network, my current network is 172.31.97.192. And my next network, I know that I just have to add my block size to find out my next network. So the next network is 172.31.97. What is the value that I got? 192 plus 32?
244.
22?
224.
Yeah, 224. This is my next network. So I know that on my current network, I can simply get my broadcast IP. If my broadcast IP will be one IP, which is previous to my next network. So 31.97.223 is going to be my broadcast IP. Can I use this IP? This IP is not usable IP. So the usable IP that I should be using is 172.31.97.222. This is the correct IP address. This is the right answer. All of you guys understood this? It's no, it's not 223. It's broadcast IP. Rohit. Okay. Vinay, do you understood this?
John,
Rohit
can you
also?
explain to the block size 32? I will get the 32 size.
Okay, you need to watch the previous day's recording. Okay.
Okay.
So, what is the Class C range? Class C block size range. Okay. So if you don't attend the last 2 days class, you basically you won't understand anything. So anyway, I'll just explain. So /27 means it's okay. In simple words, I'll explain. So I'm just writing that in decimal. That is 255.255.255.255.27. It's 224. Okay. So I'm just writing the network bits and the host bits. So what is my equation to find the block size? 256 minus 256 minus subnet mask value, that is 32. The subnet mask value is 224. That is 32. Bro, you need to watch the previous 2 days recording. This whatever we are discussing, it's a continuation. If you attend in the middle of IP addressing class, you won't understand.
Once I read the videos, I will
Yeah, so go through the videos and just if you have any confusion, any doubts, just ping in the group. So if I will be able to answer it on time, I will be answering. If not, other people are also here. They will also help you out. But just in case if you didn't get any response, like just text me again. So I will revert back to you at the earliest. Okay, so Saturday and Sunday. So tomorrow we are actually finishing the IP addressing. We are just discussing some basic things. So I want all of you guys, your basic concept should be strong on coming 14th. Your packet tracer should be installed. We are discussing things in practical ways. and we are covering more topics on the same day. So I want you guys to have the basics of OSI, IP addressing, networking devices, and whatever we discussed so far. So just in case if you think any of the concepts that are weak, please revise it. And if you have any doubts, please reach out to me. I will be happy to help. But in the middle of a session, it will be very difficult.
Okay.
Yeah. Okay. Can somebody share the WhatsApp group link in the chat? If nobody is sharing, I will share at the end of the session. Okay. So, how many of you guys actually understood this question? Any doubts? Any direct questions? Grace, do you understand this?
Yes, John, I understood that.
Okay.
The only problem I had was the first address, the first question, but I sorted it out when you gave the 10.00.0 then /27. So I sorted out that /27 is in the range of class C. So I had to switch it like that before I could get the answer. But it was confusing at the beginning here.
Yeah. All right. Now you solve this. This is the question. So this is how your exam questions will look like. Okay, basically it's like the same questions that we saw just before, but they will try to confuse. So just take a moment, breathe. Okay, just one tip. This is not the network address. This is just a host IP in that network. So the first you have to find in which network this IP belongs to. Then you have to do it. Okay. Yes, please pay attention. Like I told, this question will look like tricky, but it's not tricky at all. So 172.22.38.69 slash this is 255.255.224, which means it's 16, 17, 18, and 19. So this is /19 basically. Okay, so which means that we know that we only use, first of all, this is a host IP. This is not a network IP. It's clearly mentioned that host on the network, which means this is an IP address which belongs in that host. So first of all, we need to find out what we need to find out the network address. How do we find out? With the help of subnet mask. So /19 means 1234567 dot 1234567 dot. So 8 plus 8, 16, 17, 18, 19. So again 12345.12345. Okay. So which means 172, that is the first update. There is no change. So 172 dot 22 dot. So the change is actually happening in which update? In the third update /19. Okay, so we are going to write that value in binary. Okay, so what is the value of 38? Okay, so the first bit it's 128, so we cannot put value 0. Then the second bit it's 64, again 0. The third bit it's 32. Okay, so 1. So we only need 3 bits because currently we achieved 8 plus 8, 16 plus 3, we are in 19, 17, 18, 19. So rest all it will be, okay, otherwise also it's 0 only. So 1, 2, 3, 4, 5 dot 1, 2, 3, 4, 5. Okay, so the network address is going to be 172.22.0010. If you're converting from decimal binary to decimal, you will get which value? You will get 32.0. Okay, now it's /19. So it's very simple for us. We just have to find out the first IP address, that is 172.22.32.1. This is the first valid IP on the host. How many of you guys understood this? 172.22.
Can you please repeat it again?
Yeah, sure. Okay. Guys, first of all, there are two ways that you can find out in which subnetwork this IP address belongs to, right? So you can either follow the yesterday's method or you can follow the today's method. Okay, so yesterday also we discussed the two methods. So I'll discuss it one more time. Okay, so it's first of all, we have to write down the IP address, that is 172.22.38.69. Okay, and first up, so we know that this is a host IP, that is host 255.255.224.0, which means this is slash 90. Any confusion till the process, the step one? Any confusion till step one?
No. Okay.
Okay. Okay. So step two, we need to find out the number of net. So how do we find out the step two is find the network address. So how do we find out the network address? So we know that how many bits are there? We know that we have 16 bits. Okay, so 16 bits means if you convert 190 to 172 into decimal, what is the answer? Any idea?
Into decimal or binary?
In binary. In binary, what is the value of 172?
172 is 128 plus 64. No, 128 plus 32 plus.
Okay, so I'm going to write all the values in binary. So the first one is
1101100.
Okay, 10101100. Okay, this is the value. Okay.
Yeah.
Now I'm going to write everything in binary. So 22. So 128 it's 0. 64 it's 0. 32 it's 0. 16 it's 1. Okay. 16 plus 8 it's 22, right? No, it's 16 plus 8 it's 24. Okay. 20. Okay, so it's 0. Then 16 plus 4, that is 20, then 22, then 0. Okay, cool. The third one is again 128 0, 64 0, then 32 it's 1. So we need 4 and 2. Okay, so 16 0, 8
It's 0.
4 0, 4 1 and 2 1 0.
2 1 0.
Okay, now coming to 69. So 69 means what is the value? 69 is
0 0 1.
0 0 1 0 1. So it's 64. Then 4 plus 1. So 0, 32 0, 16 0, 8 0, 4 1 0 1. Okay, so this is the binary equivalent of 172.22.32.69. Okay. Okay, any doubt on this step to convert the IP address to binary? Any doubt? This is basically decimal to binary conversion. Guys, any doubts?
No.
No.
Okay, everyone. Okay. Now I'm going to write the subnet mask value. So subnet mask, which is equivalent for 255.255.224 is 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is my first update. Okay, 1, 2, 3, 4, 5, 6, 7, 8 dot. So 16 plus 16. So we have value 16 network bits. We need 3 more network bits. That is 1, 2, 3. Rest all bits, it's going to be zeros. That's how subnet mask is looking like. So 1, 2, 3, 4, 5 dot 1, 2, 3, 4, 5, 6, 7, 8. Then 3. Any doubt on step 3?
It's clear.
It's clear. Okay, 1 second. Let me just finish, then you can start. Okay. So what I am going to do is I am also going to count the number of network bits. Okay. So in my IP, so the last value that is mentioned here that is my IP, which we initially converted. So this is my 16 network bits, 8 plus 8 plus 16, then 3. Now we are actually converting whatever value we just, so the network bits we are converting back into decimal. So the value will look exactly 172.22.22.32.0. This is the step 4. Okay, any doubts on step 4?
What you done in step 4, you get 0.
Okay, so we are only worried about the network bits, right? So if you look at the subnet mask, so the rest all bits, so except this 19 bits, the rest all it becomes in the host portion, which is equivalent to 0. This is my host portion. This is my host portion. This is already 0.
Okay.
This is 0, right? So what is subnet mask? It's because again you're forgetting the basic. What is subnet mask? Subnet mask is used to understand the network portion in an IP address. How we are understanding the network portion? Network portions are represented by 1. Check how many bits are represented by 1. Only 19 bits. That is what it's written in /19. That is what which is represented in slash 255.255.224. Again, that is what it is representing. Okay, so we are only focusing on the first 19 bits here. So whatever value that we have, we are just converting that into decimal to binary. You will get it 172.22.32.0. That is what I did in step 4. Any confusion on this? It's okay if you have it, we'll repeat it. Understood?
So one doubt actually.
Yeah, please.
If /20, for example, 19, you take three the 3 bits. So if it's /20, you'll take it 4.
It's not class 20. There is no class called class 20.
No,
Okay.
I mean like /20 slash.
Okay, we'll try that. So tell me an IP address.
The same like 172.22.38.
172.22. This time I'm taking 90. Okay, this time I'm taking 160.1/20. That is the value that you need, right?
Yes.
Yeah, /20. Okay. Should I do it or should I give you 2 minutes then I start doing it?
No, you do it.
Okay. But if I do it, next question you will have to do it. So how many of you guys can do it? How many of you guys here know how to do it? Is anyone? Okay. Guys, what is the first step? First step is to convert the IP into binary. Okay. So since it's written as, since the /20 that is written as 255.240 240.0. Okay, so 240.0. So this is just one reduction in the previous step. So if 255.255, I know that this is complete octet. So even if I do decimal to binary conversion, it is not going any change. So in which octet the change is happening? The change is only happening in the third octet. Right. So I'm going to write the decimal conversion only for the third octet. So 255.255, it's the complete octet. We don't want to worry about it. So 160, what is the value? The value of 160 is, so 1 0 then 128 plus 32, it's 160.
101
Then
remaining zeros.
101 remaining zeros. So it's 1, 2, 3, 4, 5. Okay, dot 1, that is our answer. But again, so when I'm writing it, so I get, okay, so here using slash, okay, slash 20, how many bits I changed here?
4.
4 bits. Okay, so how many bits I have to care in the third octet?
4 bits only.
4 bits only. So 1, 2, 3, 4. Okay, so the next step, I'm converting it into decimal again, 128.22.160.0/20. So this was an IP address. This was my first valid IP address in this network. And this is my network address 172.22.160.0/20. Understood? Guys, understood or not?
Okay, so a part of caring of any number of bits, you are going to write 0 there, right? If you care half of the bits, but you are mentioning there 0, right?
Yeah, because I already got my answer, right? Okay, so let's take one more example. 172.16.16 dot 168.168.1. Okay, no, let it be 170. Okay, 172.1/20. Okay, first I will do the basic conversion. So basic conversion, if I do 170 will be, we'll do step by step for every single thing. Okay, first step is what? Converting into binary to decimal. Okay, no, decimal to binary. So it's 10101100. Okay, next one is 16. So it's 0 0 108 64 32 16 1 2 3 4 dot 172. Okay, so here we only need 170. So it's 1 0 1 160 160
0 1 0 1
0 1.
0 1.
Okay, 16 32 16 8 68. Okay, 1. Okay, no, that's not answer.
It's 1 0 1 0 1 0 1 0.
1 0.
All 1 0. 1 0 1 0 1 0 1.
1 0 1 0 1 0 1 0. Okay, so 128 plus 32 160 168 168 plus 4. Yeah, 1 0. Rest is 1. So it's 1 2 3 4 5 6 7 8. Okay, and my decimal equivalent for this is 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 no 1 2 3 4. Okay, so /20. 16 plus 4, it's 20. So again 1 2 3 4 dot 1 2 3 4 5 6 7 8. Okay, so network portions are represented by 1. So which means we are only bothered about how many bits. We are only bothered about this many number of bits, which is 19 bits. So in the 32-bit IP address, in the 32-bit, the previous IP address, we are going to convert the first 20 bits into decimal. Okay, so that is 172.16.16. So previously it was 170. Right now it's, what is the value? 160. 160.0. This is the network address. Understood?
Yes, sir.
Okay. Guys, there is a website. Also, I'll share you two questions. This I'll share it in the WhatsApp group. Okay. By the time I open the website, can somebody please share the WhatsApp group link in the chat? Subnetting. Okay. So this question in this website, go and try solving the questions. So when you're coming, please find out the number of questions that you're not able to find it out. Okay. And I know that to ease your work, some of you guys might use OpenAI or Gemini for research purposes, but in subnetting, they're still weak. You might not get the accurate answers, especially if you're using Gemini. Their mathematical approach is not right mostly. ChatGPT fairly reasonable, but you won't get the right answer. So try, but whatever answers which is mentioned over here, that is mostly the right answers. Please practice here your subnetting. So someone already asked me where they can practice it. So okay, you can check the practice test here. Then you can check from there. Okay, I'll share the WhatsApp group. Hi guys, there is a small topic in subnetting that we will finish it on another day. It's because half of the class, like you lack a little bit of practice on subnetting. So it won't be an ideal time to start variable and subnet at this time. Okay, even now you are a little bit confused. So yesterday I've shared one link. Please practice. So whenever you're getting an error, if you don't get the answer for it, please let me know. We'll work on it, and next week we'll complete variable length of that master. Okay. So since it's been a while that we are dragging with theory, so today we'll be starting our first lab session. So today's class, this will be an introductory lab. So the main agenda for today's class is first to install Packet Tracer. And a few of you guys haven't installed Packet Tracer. So by 9:15, I expect all of you guys to install Packet Tracer. Then by 9:20, in case you guys are facing some issue during the sign-in process, we'll finish it by 9:20. Then we will start introducing with how you can build your own topology, all those things. We will have a walkthrough of Packet Tracer in today's session. Then how to get into console, what are the different modes, all those things we'll be seeing. So I think all of you guys have the drive access. If not, you can check in your student portal. You will find a drive access. So inside the drive, how many of you guys actually installed Packet Tracer? Can you give me a thumbs up or the confirmation in the chat?
How to install the Packet Tracer?
No, how many of you guys installed it? Okay, Hudson installed it. So there is a Cisco Packet Tracer software in the drive. So once you go, you can see the software for macOS, Ubuntu, and Windows. For Linux also, you can use the same one. And so I think majority of you guys might be using Windows. So please download the software over here. And like any software, you need to press install until it get installed. Okay. How many of you guys haven't done this? How many of you guys didn't install Packet Tracer yet? Anyone?
Me, sir.
Okay, can you please do it now?
I'm doing it, sir.
Okay. I have installed Packet Tracer last year. I need to reinstall with the link. No, if you have Packet Tracer, please don't install it. But make sure that it's working. Okay. Okay, no problem. Is there anyone yet to install Packet Tracer? Okay. Sure, why not? Your wish is my command. Now, once you open it, are you on the same screen that I am in? If not, please update me in the chat. This is how ideally you should be seeing it. It's working fine, Ram, no issues. Okay. All of you guys, are you guys in the same page? Okay, cool. Now, first things first. First, we'll start seeing how the devices are working over here. Okay, how devices are actually working. So first of all, to start with, you need to select N devices. So N devices are next. The first thing that you will see is networking devices. Next to networking devices, you will see N devices. Here you can add PCs, laptops, servers, printers, IP phones, voice over IP phones, TV, tablet, basically all the smart gadgets you can take. So let's start taking a PC. How to take a PC? You can simply drag and drop it there. Okay, just drag one PC, just drag another. You can get this. Okay, now so all the PCs they need some basic configuration. So first of all, we need to give the desktop index. We can go to the desktop and do the IP configuration. These are the basic essential that we need to configure. So I'm going to assign one IP. This IP is 192.168.10.1. Okay. So if since we are not doing any changes, any subnetting, so it will go with the default class C subnet mask, that is 255.255.255.0. Okay. So the next PC also they need one IP address. So let's assign one IP. Go to desktop IP configuration. So there are two methods. One is DHCP and one is static. So freshers, so DHCP is dynamically to assign. So when there are like larger devices, we will be using a server to assign IP addresses. It will automatically find and identify and configure this IP addresses. But for now, for the time being, we are preferring with static. Static means manually we are entering the IP address 192.168.10.2. Since we are not doing any changes, this is the default class C subnet mask, and we are done. Okay. Now, in order to connect this, we need a cable or any other networking devices. First, we'll start using cables. You will see cables in the lightning symbol. Once you press the lightning symbol, you can select the different. There are different types of cables. We'll walk through different types of cables. But right now, for the time being, you can start selecting the lightning symbol. It will automatically select the best cable for you. And for now, you can see this is the fast Ethernet cable. This is the fast Ethernet cable. So based on the network devices performances, they automatically selected the devices. Okay. So in today's class, I'm also going to introduce one command. That one command, which we will be discussing in depth, the command is known as ping. Okay. So ping is just a command which is used to test the connectivity of a device. Okay. So I'm just going to use ping 192.168.10.2. Okay, since I'm getting reply, which means I am having communication to the end devices. So in the ancient days, when people they were going on sail in the sea, they used to send pigeons, and if the pigeons come back, if they see any shore nearby, like they'll come back with a leaf that indicates that there is land in the nearby area, like that. So here we are sending a few types of packets. These packets are known as ICMP packets. So the ICMP packets will go there, and if it's coming back to us, we'll be receiving few details which will be indicating the quality of the connections. So while looking at the details, you can see there is a TTL. So there's a time to leave, and with the time it took. So we sent 4 packets, we received 4 packets, which means our communication is 100% proper. We lost 0% of data in the communication. Approximate round trip time in milliseconds, that is 0 milliseconds, maximum is 8 milliseconds, average is 2 milliseconds. So this also indicates that how far the end device is from your place. So that is something that you can either calculate with the average time, also using the TTL value. So the TTL we will discuss once we start discussing ping, but it is a protocol that is used to avoid a layer 3 looping, time to leave. So after a certain time, your packet will automatically drop. For example, if I am pinging, okay, so we'll explain this in detail in some other class. But let me ping on this IP, ping 128.1.1.1.1. Okay. So I have that IP. So I'll ping some other IP, ping 200.200.1.1. Okay. So here you can see request timeout. Request timeout. So after every packet, they spend a certain amount of time. After that, if it's not coming back, they will remove. Once the TTL is over, the packet will drop. Again, second packet is sent. Once the TTL is done, it is dropping. Again, the TTL is dropped. Then it's the dropping. Then again it's dropped. So the TTL, it can be used in many ways. One is of counting the hops. Okay. So TTL, it's basically time to live. So these are the details. We will discuss in Monday's class. We will discuss this in detail, the TTL. But for now, why I introduce ping is because first I want you guys to build a topology. Then you have to make sure that there is connectivity. To make sure that there is connectivity, you can use the help of ping. Okay. So now, like we discussed in network devices class, to connect multiple devices. Okay, so in behind every CPU, you will see something that is known as network interface card. This is where you will be connecting your LAN cable, or whenever you wanted to connect between multiple devices, you'll be basically connecting to this particular port. So in every system, you might have seen this in backside of your CPU. Okay, so they will install in backside of your CPU. So we'll be connecting the cables over there. So in every computer, we have around, okay, sure. In every device, there is only one network interface card. So we cannot connect multiple devices. So if there is a third device also, we cannot connect three devices at the same time. Why? Because there is only one single network interface card. So for the same reasons, we are connecting this to a switch. Again, we are going to connect it with a cable. So I'm selecting the cable from the lightning symbol. I'm pressing it, connecting it. After that, you have seen that it is automatically removing, right? So I also wanted to connect one more. Sometimes I might have to add multiple devices at the same time. So in that case, when I'm selecting the lightning symbol, I will press Control. Okay, now the selection is locked. So now if I have to come out of selection, we'll be just using escape. Okay, so now our switching concept is basically done. We connected these devices via switch. Okay, now first of all, little assignment to you first, then we will discuss. Okay, today's practical you will also do it with me. 10.3. Start taking 4 PCs, one switch, and assign IP address to all the devices. Is it clear? Take 4 PCs, take a switch, connect those devices. Yeah, it's basically a crossover cable. Okay, you can forget about that now. Just use the lightning symbol. Since I disconnected this, it automatically selected. Okay, you can use the lightning symbol. So right now, all the tables will be a straight table. Okay, why this is because to connect between different devices, you are using different types of cables that we will discuss. So right now, you can see this straight cable. This is the one, the copper straight through. And once you connect it, you have to basically use something that is ping other IP address. So ping 10.3, you are getting the reply. Ping 10.4, you need to get the reply. So once you complete this, you can just give me a confirmation. Then I will discuss how simulation mode works. Okay. Guys, is it same for everyone? Is my screen visible? Is it?
Yes.
Okay. Okay. So if you don't see port numbers like this, F0/1, F0/3, F0/4, F0/2, you need to do something. So before that, make sure that all of you guys have it. If you don't have it, please pay attention. Go to option. In option, select preference. In preference, you will see something that is known as always show port labels in logical workspace. If you untick it, you won't see. If you click it, you will see. So make sure this is important. You click it because this is important when you're working with the topology. So you need to know which interface is in which side. So that will actually help you to configure devices and make no errors. Okay, Sagar, make sure that you are doing a ping test and actually getting the output. Mostly you should be getting the result.
Yes, John, we got a ping result.
Yeah. Okay. Now I don't have F0/1. Okay. Now need to discuss something that is simulation mode. Okay, this is the biggest advantage of using Packet Tracer. So using Packet Tracer, you can actually use a simulation method. In the simulation method, you can actually see it's basically a simulation. It will actually show you how the packets are actually moving from one place to another. I would recommend you guys to use it, but when you're using it, you have to be careful. Okay, you have to be careful as in, since it's simulation, it's showing every bit of simulation, so it is going to be slow. Okay, once you press enter, you can see a packet is created. A packet is actually created in the PC. 1 second. So you can actually adjust this packets over here. You can drag it here so that you can see what type of packets are being active right now. So like I told before, ping is a command which is using ICMP protocol. So you can see there is an ICMP protocol. If you click it, you can see the details. So it will be like this. So if you press forward, you can see from there where the packet is moving. From there, we were communicating to 10.4. So the packet reached 10.4. Now the packet is going back to the PC. Going back to the switch, once it reaches to the PC, it actually, we can see that to and fro communication in the simulation mode. So once you, okay, there are other protocols also, but when you're working with this, don't get confused. Since we are going step by step, we won't be able to discuss all the protocols at the same time because this is a protocol which comes at the end of the session. Okay, so but like you might see a different other protocols like STP, DTP, CDP. So these are the protocols that are there to make sure that the system is running effectively. Okay, so for the time being, please understand that. So that's it in the simulation mode. So once the simulation mode is done, you can press the real time. But if you don't want to see this STP, so normally in the beginning of the classes, so since I don't want people to get confused, I will just go to this and remove all the filters. So mostly these are the protocols that are coming: CDP, DTP. Then one more protocol we will see, that is STP. Okay, yeah, this is STP. Once you remove that, you can see all the other protocols that you don't want to see over here. That is removed. So this is actually good for filtering the traffic. It's because you press the simulation mode at a different time. So I'm pressing real time now. If I press ping, then if I come to simulation, I might also not see any packets. I might see a different packet right now. See, since I removed STP, okay. Since I removed STP, I'm not saying that also. Okay. So you have to be there at the right time. So to clear it, so you can see what is the scenario that is going on. So if such scenarios happens, first I will delete the current scenario. So you can see this delete button over there. So I'll delete that scenario. Go over here, do the ping test again. So in that case, I can see ISMB protocol is back in action. It's communicating. That's about simulation mode. Can I move forward, guys? Ram, Grace.
Yes, John.
Okay. Okay. Cool, guys. One more thing that you can do in simulation is rather than doing the ping, first you can go to the simulation, press P, it will create a PDU. Press P, then select the PC, which is a starting PC and the ending PC. You can create a packet like that. You don't have to do the ping. Press P and click on the devices. So it will be actually listing out all those details. So once that is also done, yeah, please remove it if you don't want to see it. But these are the other protocols that make sure that there are no errors that happens in switch. Those are layer 2 protocols. So once I've seen what I have to see, I'm just deleting the current PDU. So coming back, press real time. Okay. So one more lab for today's class. So once you complete that, you have to send me a snap uh, either in the WhatsApp group or here you can share it, then you can leave. Okay, so this is basically your LAN number one, LAN one. Okay,
What do
and
you
you
mean PDU?
protocol datagram unit.
How it works, or it's just a packet?
It's same like a packet. It's same like a packet. Ping one, so 192.168.10.0/24. Rita, the question is not clear. I'm going to build one more local area network or one more small network. Okay. So this network, I'm going to use this network address 200.200.200.0/24. Okay. Taking 4 PCs for the same. Connected with devices via cable. What is open packet? That's what I didn't understand. What do you mean by open packet? So you are saying what I'm doing over here is this is the packet that I'm sending. So do you say this is an open? So this is basically a message. So PDU stands for all the protocols that we are basically using. So it's a dummy version. You can see there are no open packets here. No, this is the PDU packet. Start assigning IP 200.200.200.1. To and 4. Okay. So if I want to connect multiple devices, I need to use a router. Okay. So I'm going to use this router, this particular model right now. So once you're familiar with all the commands over here, you can change it to a different router. So this is the model number that we're using, 28111. Okay, so you are free to use any routers, but if we are troubleshooting this in the class, so it's better that you use the same router. So once you're confident of yourself, you can start following your footsteps. Okay, so I connected routers also with the switches. So on the two interfaces, you need to assign IP address in F0/0 and F0/1. So here I'm going to assign 10.10 and here I'm going to assign 200.10. Okay, so these are the IP addresses that we need to assign. Okay, so first of all, you need to understand this is a brand new router. Okay, I hope everybody is paying attention. This is a brand new router. So the moment that you enter, you need to go to the CLI for the configurations. First, you are going to the CLI. So this is where you will be typing all the commands. So here, since it's a brand new device, it's asking you, would you like to enter the initial configuration dialog? No, we are not going to change any default settings. So we are pressing no. So now you are inside a mode in the router that is known as the user mode. Okay, so user mode is something like you are working or you are basically not having any much privileges. You are just a user. Okay, so here basically what you can see is you can see few details about this router. So like R, CDP, class map, clock, controllers, crypto, frame, relay, host, interfaces. You can see few details, but you can't see all the details. So to type any commands, first you have to get into the privilege mode. Okay, so first you have to get into the privilege mode. So to get into the privilege mode, you have to type this command enable. Okay, guys, please take note or notepad. You should have these commands with yourself. Okay, so here this greater than symbol that you see over here is this is the user, which is representing the user mode. So the moment that you type enable, we can see this hash symbol. So only if you see this hash symbol, you are in the privilege mode. Please take notes. If you see this greater than symbol, you are basically in the user mode. If you want to do anything, so if you want to get privileges, first of all, you have to come to the privilege mode. So if you see this hash symbol, you are in the privilege mode. So here you can see many details. So compared to the previous one, you have much details that are available over here. You can type show IP, route, all these commands. You can basically see the routing table, IP information, all these configurations, everything that you will be see in the privilege mode. Okay, so first of all, since this device is a brand new device, we have to get into the configuration mode, right? So the command to get into the configuration mode is configure terminal. Okay, you have to type this command configure terminal. Only this command. Please don't type CONFS then configure T, because I've seen people doing that. So this is the command configure terminal. Okay, once you type that, you will be in the configuration mode. So how do you understand that you are in the configuration mode? You will see this message that is config. Any doubts till now? Any questions? Any clarifications? Guys, yes or no? Okay. Now, okay. Before doing anything in the router, first in the privilege mode, what is something that you have to see is, so you can come out of the privilege configuration mode. If you type exit, you will be coming back to the, you can decrease the levels that you are in. So from if you type exit again, you will again go back to user mode. So first thing that you want to see in the router is how many interfaces are there. Okay, guys, please take notes. This is, I have also shared this commands in notepad file, but you will not look it and it will be trouble for the first few days. So please take notes. So the first and foremost thing that you have to do in a router is type the command show IP interface brief and see the status of the devices. Okay, so here you will get a clear idea about the interfaces. So the router has two interfaces. One is F0/0 and F0/1. In both the interfaces, IP address is assigned, which means we have to assign IP address. Also, we have one more details that are there, that is known as administratively down, which means we have to turn this interfaces up. Okay, so in this particular switch, we are having fast Ethernet 0/0. In some devices, they will be having serial interfaces. In some devices, they'll be having gigabyte interfaces. So based on the devices, this interfaces will change. So in our model, it is fast Ethernet 0/0. Okay, so let's configure this devices. So first, if I have to configure it, please take note of this command. The first command to check the interface is show IP interface brief. Okay, then I am going back to configure terminal. So again, I see the configuration message. So I am in the configuration terminal. Now to assign IP address, first I have to select the interface. Interface F0 F fast Ethernet 0/0. I can type it like this, or I can type like this interface F0/0. This both are representing the same thing. Okay, so how do I make sure that I am in the interface configuration? The moment that you type interface number, you will see interface configuration. If config if, this is the interface configuration which it is representing. Okay, the first detail that I need to configure is, of course, the IP address. So in this interface, I am going to configure the IP, that is IP address 192.168.10.10, and you have to mention the subnet mask. Which class IP address is this? Class C. So the default subnet mask that we use for class C IP is 255.255.255.0. Okay, this is used to differentiate what is a network address and what is a host address. We haven't done subnetting, so this is basically the default subnet mask which we are using. Okay, so along with the subnet mask, once you enter the IP, your IP address is configured. Okay, again, if you type do show IP interface brief, you can see IP address is assigned, still it's down, administratively down. So if I have to turn this interface up, I have to type this command, no shutdown. So once I type that, and again if I type do show IP interface brief, we can see 192.168.10.10. It's manually up. But look at the other interface, it's still unassigned and still it's administratively down. Okay, now I'm going to configure it. So first I'm going to exit from that interface. Then I'm going to select the next interface, that is F0/1. IP address is 200.200.200.10.255.255.255.0. No shutdown. Exit. Show IP interface brief. You can see we have assigned two IP addresses and it's up. So right now, once the interfaces are manually up, you can see this green symbol over here. Any doubts till now? Any questions? Okay. The next part is that first thing that you need to do is okay, PC config. In PC config, you have to give the basic details. First one is IP address. Second one is subnet mask. It will be given by default. Third thing is default gateway. This is important because whenever you're communicating something which is outside the network, you need to use the default gateway. Second thing is you need to configure the router config. So how do we do that? Go to config mode. So how do you go to config mode? First, when you are in this mode, when you are seeing this button, you have to type enable. So after that, you will be getting into the privilege mode. So from in the privilege mode, you have to type configure terminal. You will be going to the config mode. In config mode, you have to type interface F0/, just I'm typing one for an example, F0/0. IP address is 192.168.10.10, and the subnet mask, that is 255.255.255.0. So once you enter that, your basic, that's it. Okay, the router config. Once you've done the router config, you are basically done. Okay, you are basically done for this particular topology. And if you make errors, how do you troubleshoot it? The first thing, check PC config. Everything that I mentioned, IP address, subnet mask, and default gateway. Check router config. In router configuration, you need to check IP address are configured to correct interface. If you want, please take it. If you are new to this, I would really recommend that you guys take a screenshot of this and practice rather than depending on anyone. You can just use this. Okay. So, like I told, this is not something like a rocket science. If you follow step 1, step 2, and the troubleshooting process, you will absolutely make no errors. Okay. So, it's completely up to you. So if you know how to do this, you don't have to look at it. But if you don't know, what I would recommend is first follow the step 1, then step 2, then do the troubleshooting process. Process and procedure is very important for the people like who are completely new to this. Okay, and you don't need to have rocket science, or you don't need to have like massive amount of IQ. Just follow the simple procedures that we are telling. You will make up no errors. Okay. Now, since I will explain what is default gateway one more time. If I want to send this packet outside my network from LAN 1, if I want to communicate from LAN 1 to LAN, that is basically outside my network. So this message can only pass through this 10.10 IP. That is basically my default gateway. And if this network LAN 2 wants to communicate to LAN 1, so they will have to send the packet to 200.10. That will be the default gateway. So the IP address that is configured to the router's interface, that will be mostly the default gateway. So please configure the default gateway here. So in my first network, it's 192.168.10.10. Okay. So in my second device, it's 200.200.200.10. Okay. And how do I make sure I have connectivity now? I will have to go to command prompt and do a quick ping test to make sure I have connectivity. Ping 200.200.200.1. I'm pinging, but first I have to check I entered the right IP address. Request timeout and getting the reply, which means I have connectivity. Finish this lab, take a screenshot. So there is a feedbacks that we have to submit individually for all the people who are undertaking the training. So your participation is very important to get the course completion certificate from the institute. And since they are also having some reputation, they are also very strict with whatever the output that we are getting. So please maintain a file. So all these labs, whatever you're doing, you can save this as lab 1, and it should be saved at the end. Since if there is a valuation that is happening, we might be asking. Normally that won't go, because in all the classes that I used to take, people give feedbacks on time. So normally at the end we don't have to ask it, but just keep a file saved in your device. Okay, any questions? If not, you can start doing it now. That's it for today. We are discussing. Even if you're leaving, please let me know that in the chat. Then you can leave. Or if you're doing also, please confirm what is your status.
So after giving the gateway, we need to ping a same network, or we need to ping for other network?
Show me one PC config. PC0 LAN 1 IP config. You mentioned it's 1.1, 1.10. Okay, cool. Close it. Close it. Second network. You see the yeah. IP 200.1, 200.10. Okay. Put the cursor on the router. Close this. Close this. Put the cursor on the router. 1.10 and 200.10. Okay, basically everything is right. So you can just ping on one PC to another PC in another network.
In another network, right?
Yeah. The first packet will dropped here. Now it's working. You're done. That's it.
Share this file.
No, you're good. You can share it. I mean, I have strong memory. Aram, please minimize it. Minimize the router configuration. 1 minute. Okay. First of all, this is guys. If anybody is seeing, please pay attention. First of all, you are not able to see the router's interfaces here. Okay. Go to view. Now go to options on the top. Options. Next to before view, you will see option. Preference. Select always show port labels and logical workspace. That one. Close it. Now you can see the IP address that you're actually configuring, it's of F0/0, not F0/1. This is the mistake that I was saying. So whether you are configuring it on the correct interface. No, press escape. Yeah, double click it. Okay. Clear it and enter 200 dot whatever IP that you are configuring, enter it there. No shit. F0/0. Okay. 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 All right. Hi guys, welcome to today's session. Today's session we are discussing about spanning tree protocol. What is spanning tree? What is STP? STP is spanning tree protocol. So in order to work STP, there are three criteria that STP makes sure. First is that it is going to select the root bridge. What is root bridge, guys? What is root bridge? Any idea what is root bridge? Anyone? How root bridge is selected?
Priority and MAC address.
Priority and MAC address. What is root bridge? Root bridge is nothing but in spanning tree, like the all other switches in this particular segment, they are going to elect one switch as the root switch. This switch will be the focal point of communication for all other switches. So in spanning tree protocol, there are two types of switches. One is root switch and one is non-root switches. Understood, right? So apart from the non-root switches, all other switches, they will be known as non-root switches. So what is root port? The second criteria in spanning tree election is that it is going to select the root port in spanning tree protocol. What is root port, guys? Why do we use what is root port and how do we calculate the root port?
Based on the cost calculation and paths.
Okay, yeah, based on the cost calculation. Okay, so based on the cost calculation, as in, so all non-root switches, they will try to reach the root switch via root port. So root port is actually selected based on the least cost which the interface will took to reach a certain place, that is the root switch. Okay, what happens if there is a tie in the cost? What happens if there is a tie in the cost?
Then they will go to the lowest neighbor bridge.
Then they will go to the switch which is having the lowest neighbor bridge ID. What if there is a tie in the bridge ID?
Lowest port number.
Lowest physical forwarding port number. Okay. Now understand this. Okay. This all we have. We'll discuss the PPT that is there in the drive now. After that, we are going to select the designated and the non-designated port. That's the third step. We will discuss that. Okay. What is designated port? A designated port can be on both root bridges and non-root bridges. All the ports of the root bridges are designated port. A designated port is the one that has the lowest cost to the root bridge. It will be marked as the forwarding port number. All the designated port number ports, they will be marked in the forwarding state. Okay. Now I'm taking three switch connecting between three different switches. Okay. Now let's wait for the election. Now hopefully, not hopefully, this switch is our root switch. Looking at the topology itself, we can say that show spanning tree. Yeah, this bridge is the root switch. Okay. Now we are going to do the last criteria, that is selecting the designated and non-designated ports. All the ports in the root switch, they will be in the guys. Elliot. Okay. All the ports. Okay, guys, this is our root switch. Okay, this is my root switch. All the ports of the root switch, that will be the designated port. It will be always up. Both the ports of all the ports that is there in the root switches, that will be always up. That will be in the designated state. So F0/1 will be in the designated state. F0/2 also will be in the designated state. So you can see this will be in the designated state. Also, this also will be in the designated state. Okay. all the root ports will be in the designated state. So this is one of my root port, and this is also one of my root port. This also will be in the designated state. Okay. Now it will be calculating the switch which is having the least cost to reach there, so again it will check whether if they are traveling like this, what is the cost, or if they're traveling like this, what is the cost. So since you can see there is a tie there, so the second criteria that we will be looking by default, that is going to be the bridge ID. So here looking at the bridge ID, this which is having the lowest bridge ID, so this port become active, and to avoid this, the other interface, they went into the non-designated state. So this is actually the non-designated ports that will be known as the block port in spanning tree protocol. Understood, guys? Yes or no?
Yeah.
Now, if so, we will discuss the PPT. Spanning tree. Oh, okay. So since you will only see this PPT in the drive, so I'm just explaining like the PPT wise. What is spanning tree? Spanning tree protocol is a switching protocol that prevents layer 2 loops created by redundant links. STP enables switches to become well informed about the neighbor so that they can negotiate a loop-free path between the network. How spanning tree protocol works? STP chooses one of the switches in the network as a root bridge, which is used as a reference point to calculate all other redundant paths to the root bridge. Picks up one path which is best to forward frames and blocks the other redundant paths. Due to the redundant path block happening, switching loops are prevented. Okay, what are BPUD messages? So BPUD messages, yesterday also shown, that are the messages that are actually exchanged between switches. This is actually sent in certain intervals. We are going to see that. Okay, all switches switch over information to select the root bridge for the configuration of the network. This is done through message. The message called bridge protocol datagram unit. And each switch compares the parameters of the BPUD messages. Then it sends one neighbor switch with one that it receives from the another neighbor switch. What are the types of BPDUs? One is configuration BPDU. Configuration BPDU are used for spanning tree protocol assessment. And there is one more, like whenever there is a topology, when interface is going down, or if there is any change that is happening, the next type of BPDU that comes is known as topology change notification. This TCN BPDU is used to state the changes in the network topology. What is bridge ID? So bridge ID is something which is 8 byte long. So out of that, 2 byte is for the MAC address. So in that, both the priority and MAC address of the device in STP domain, the bridge ID is used to elect the root bridge. So how root bridge is selected? We have seen that. What are the steps of STP working? So elect the root bridge, then assign the root ports and non-root ports, assign the designated ports on all bridges, and assign the non-designated ports. Okay. So what is root port? Root port is always on the non-root bridge. It is always the port on the link that is directly connected to the root bridge, or the port on the link which is the shortest path to the root bridge. It is always in the forwarding state. Then we have designated port. A designated port can be on both the root bridge and non-root bridge. Also, all the ports of the root bridge are designated port. The designated port is the one that has the lowest cost to the bridge. It will be marked as the forwarding port. Okay, then you have forwarding port. A forwarding port can send and receive, that is basically to forward and receive frames. Then you have block port. A block port is a port that is used to avoid switching loops. It is also known as a non-designated port. Okay, the port that you have seen that is in the non-designated port, that is also known as the block port. It only listens to BPD messages. It cannot forward information, but it actively listens BPD messages So if there is any other link which is going down, immediately this particular link will come up. That is the reason why they are listening to BPD messages. Any port other than the root and designated port is always a block port. Okay, explain the type of STP timers. STP uses 3 timers. One is hello, forward and delay, maximum age timer. These timers make sure that the switched network coverages properly before bridging loop can form due to redundant links. Hello timer, this is the first message that will be sent in an STP message. The time interval between the configuration BPD messages sent by the root bridge, it is 2 seconds by default. They will be sending the configuration messages. So forward and delayed message, the time interval that the switch port spends in both listening and learning state before going to forwarding state. Okay, so as you can see that immediately when we are opening a topology, you can see that it is not directly going up. Okay, so you can see like the switches, all the interface of the switches, it's by default off, but for the router it is always on. You can see that, right? But it will take some time for the switch to turn up, right? So it is going through the different spanning tree protocol, and which means the stages in spanning tree protocol. After that, it will go to the listening state, then it will go to the learning state, then only it will come to the forwarding state. Only in forwarding state, they will be able to send and receive frames. Okay, now you can see that after all the states in spanning tree, finally all the ports are come up. Okay. Then maximum age timer, maximum length of time of a BPD information can be stored before discarding it. It can be defined as a time interval that the switch stores BPD information without receiving any update. By default, it's going to be 20 seconds. And what are the different port states in STP? One is disabled. A port in disabled state does not take part in spanning tree protocol. Listening state, a port in the listening state send and listen to BPD messages. Make sure no loops occur in the switched network. The port also arranges to forward data frames without populating the MAC address table. It is also known as MAT table. Both are the same. Okay. Then it will go to the learning state. A port in the learning state populates the MAC address table but does not forward data frames. This port still send and receive BPD messages as it is in the learning state. Okay, so if you check here in the switch, you might be able to see enable show spanning tree. You can see they have, okay, no, show MAC address table. Right now it's empty. Ideally, they should have been learning that. Let's check after some time. Yeah, you can see that we haven't pinged between any of it, but due to the STP protocol that is happening, in the learning state, they have learned one MAC address. If we forward this to so much many times, this might go down and okay. In real devices, it's even more faster than the packet tracer. Okay, so in learning state, they will learn, populate the MAC address table, but does not forward data frames. The ports still send and receive BPD messages as it is in the learning state. Okay, after it learns the MAC address and the connected devices and all the BPD information, then only it will be going to the forwarding state. A port in the forwarding state can send and receive data frames, collect MAC address table in its address table, and send and receive BPD messages. The port is now a fully functioning switch port within the spanning tree topology. Okay. Then you have a block state. A port in the blocking state does not forward frames. It only listens to BPD messages. The functions of block state is to prevent the use of loop path. Okay. You have also seen like what is root port. These are the different paths STP will take for different types of segments. If you want, you can take a note. I'll just get a sip of water. I'll be back. We are going to learn about two different topics, that is BPD guard and BPD filter. Okay. Once BPD is enabled, it will keep an eye for any BPD entering in the access port. Our main aim is to have a predictable topology and not allow other switches outside our control onto our network. If a route switch is introduced in our topology, it will be most case transmit BPDU. If the rough switch has a better value than the existing root bridge, which will cause topology change of the switcher network. Any topology change is a bad news for the users. By configuring BPDU guard features on the access port, uh, enables the spanning tree protocol to shut the port down in case of a BPD packet receives. Okay, so here again we will work with the topology and understand what is that. Okay, so BPD guard is something which is very important. Okay, since this is theoretical topic, and I know some of you guys are already getting bored with the topic, so that's why we are again building the lab. Even for exam, this is theoretical topics only for spanning tree. Now you can see after the spanning tree is happening, one of the switches selected as what? Selected as the root bridge. Okay, you already know which is a root bridge. This is my root bridge. Okay, now I am connecting to this switch, a rough switch, which means imagine this is a okay guys, the easiest way to hack into a network is the easiest way that you can hack into a network is just connect your get an access to the cable. I mean, you might think that is difficult, but that is also something which is very easy nowadays. Okay, like we already know, in one spanning tree protocol, one switch will be always the root switch. We only have one root switch in a spanning tree protocol. Okay, right now this switch, this is the hacker switch. Okay, they can easily get a small mini size. This switch is actually a hacker switch. Now enable configure terminal interface F0/3. Second. Okay, we need to enable BPD guard there. Okay, 1 second. Need to recall. BPDU no spanning tree BPDU. Yeah, it's spanning tree only. Spanning tree. Yeah, spanning tree broadcast. Then BPDU guard. Spanning tree broadcast BPDU guard. Is there something that is known as enable? Yeah, default enable and all other things. Now I am BPDU guard is there. BPDU guard.
I think it's just type default. Maybe it's works.
Default. But normally I used to type the other command. Okay, let's see with this. Okay, we are applying this here also. Enable configure terminal. spanning tree, forecast, BPD guard, default. Okay, right now, BPD guard is enabled. Now, once BPD guard is enabled, what happens is that if a rough switch is happening, and if they are trying to access, uh, or change the BPD values, what they are trying to do is like they'll be changing the priority value in the hacker PC. So if the hacker PC is having a lower priority value, what will happen? They will become the root, which means they will have a complete access to the topology. Now, I'm going to the hacker PC. CLI enable configure terminal. Spanning tree VLAN 1 priority 0. Okay. Ideally, this should not be happening because we have enabled that. Okay. Let me type this in the interface also. Interface F0/0/3 spanning tree BPD guard enable. Interface F0/3 spanning tree BPD guard enable. Okay, so you can see that since we have entered BPD guard in this particular thing, so it will not accept any other switches who are trying to. Okay, so the command was actually like we were trying in the interface before, but we should have actually been typing the full commands. That's why they were not getting it. So we were actually using spanning tree in the interface, but it was not working. But when I typed it fully, it is working. Okay, so the command is here, spanning. Okay, so use spanning tree BPD guard enable. Once you enable, what you have seen that the hacker PC, when they tried to send the lower BPD values, immediately all the interface, that particular interface which is connected to the hacker PC, they went down. Immediately all the interface which is connected to the hacker PC, they went down. Okay. Now that is what we were discussing with BPD guard. Now we are going to discuss something BPD filter. BPD filter, on the other hand, filters BPD in both direction, which effectively disables STP on BPD port. BPD filter will prevent inbound and outbound BPD, but will remove the port for state and on a port if BPD is received, which means that BPD filter, if you are enabling BPD filter, like what happens is that immediately it will be jumping into the port for state rather than port for state means port. So you have seen that it is spending a lot of time in the listening and learning state. So which means immediately your interface will come up. Okay, we will show that. Okay, not seeing that. We'll try it from here itself. Go here. Okay. I'll remove the last two command. Okay. No, let it be there. We'll build one more lab. Two switches. Okay. Right now, both the switches are up. So once we enable this, we'll see the difference. Okay. Enable, configure, configure terminal, enable, configure terminal. Okay. Now, spanning tree, forecast, BP, PO, BPD. This should be something BPD filter. Okay. So only BPD guard, BP, spanning tree, forecast, BPD filter by default. That is the command. Okay. The command is not taking, so let it try from the interface. Okay. Interface F0/1, interface F0/1, spanning tree, BPD. Okay. Okay, these two commands are not actually supporting in Packet Tracer. So let's me see if there is any other command which I have mentioned in Notepad. So I was not really working with spanning tree, but I might have mentioned this commands here. Okay. For security, EtherChannel. Okay. No worries. I'll show you this in tomorrow's session. I'll see this commands. What is command? But that was the previously, like what are the commands that we typed? That was actually the real commands. So either I will have to work with a different model, or we'll see. Like I'll discuss that in tomorrow's session. What is the main advantage is that rather than spending the time in listening and starting state, like it immediately the port will be coming up. That is the main advantage of that. Okay. Now types of layer 2 protocols. One is STP. STP is normal spanning tree. Again, STP is applied to the VLAN. Then we have PVST per VLAN spanning tree. Then we have RSTP, that is also a rapid spanning tree. Okay. Now again we have rapid PVST, that is uh, again like a more advanced per VLAN spanning tree, that is rapid spanning tree. Okay, so here why there are so many difference. STP, it's the normal spanning tree which is not developed by Cisco, it is developed by the 8.2.1d. I mean, they are the people like who developed it, and all other vendors, they are also using this 8.1d protocol. So on Cisco devices, if you want to use, you can use PVST per VLAN spanning tree, or on other devices, mostly for all other common vendors, like what you will be seeing is something that is known as RSTP, Rapid Spanning Tree Protocol. And even for Cisco, we have Rapid Spanning Tree, but we also have Rapid per VLAN Spanning Tree Protocol. That is the difference. Okay. Again, Rapid Spanning Tree, it's slow. Per VLAN Spanning Tree, it's again it's slow. One for every VLAN. Okay. Then RSTP, again it's fast. Again, it's one, and rapid PVST, it's again for Cisco. The resources needed, it's very high, and convergence, it's too fast, and one for every VLAN. Okay, that is all about spanning tree protocol. This BPD filter command I will show you in tomorrow's class. Okay, apart from that, any other questions or any other doubts? If you do have, please ask. Guys, any questions? Naveen, what happened? Like, when did you join?
Yeah, I joined 10 minutes late. Yeah.
Okay. We were discussing about the other few scenarios. The end portion, like what was the major thing? Like most of the other things, like we have discussed in yesterday's session, but we were also discussed like designated and non-designated. Was the initial bit? If you are watching the recording. Okay. Hi, Rita. Now, the next topic that we have to discuss, that is nothing but EtherChannel. Okay. So if you look at the current topology, guys, you can see that here in the first link, I have 100 Mbps bandwidth. In the second link also, I have 100 Mbps bandwidth. Okay. Now, because of spanning tree, I'm actually my 100 Mbps of bandwidth I'm not able to use. Okay. So if when you're working in production, you know that every single bit of resources that you have, you should be using. Okay. You don't, if the wasting is a crime over there. Okay. So how can you actually make use of these two interfaces without spanning tree coming into active? So in networking or in switching, we have a certain scenario that is known as either channel. What either channel does is, either channel is used to group physical links. Either channel is something which is used to group physical links. Physical link as in, so we'll be saying that this F0/1 and F0/2, we'll go inside the switch and we'll say it's not two, it's one, like VR1, like F0/1 and F0/2, they both are one device. That's what we'll be doing inside the switch. So by doing that, what happens is that the spanning tree will not occur because that is one single link. Okay, so they'll be negotiating a lot of information, and the information will be passed only through one single link. And whenever there is like a more bandwidth or more amount of traffic that needs to be sent, they will be leveraging that between like the two links and making use of the 200 Mbps of bandwidth at the same time. In order to do this, we have basically three protocols. One is PAGP, one is LACP, one is not a protocol, that is a method that is known as static. Okay, but what is either channel? Either channel is a port link aggregation technology or port channel structural design used primarily on Cisco switches. Either channel allows or assembles a number of real Ethernet links. By assembling them, it establishes a logical Ethernet link for the assurance of providing fault tolerance and high-speed links. Either channel can be established between switches, routers, and servers. A maximum of 8 fast Ethernet or 8 gigabyte Ethernet ports can be assembled together while forming an Ether channel. Okay, up to 8 links. Even if you're using gigabyte fast Ethernet or whatever it is, like you will be able to do that. Okay, what are the available mechanisms for configuring either channel? There are 3 mechanisms that you can choose to configure either channel. One is PAGP, like we told, that is if you're using Cisco devices, mostly you might be using PAGP. But if you want to use the standard internet protocol, that is the IEEE protocol, we'll be using LACP. Okay, link aggregation control protocol. This is an IEEE protocol which stands, which is a standard, and LACP working modes are passive and active. So working mode means if on one of the interface it's auto and one of the interface it's desirable, either channel structure will form. If one of the interface is passive and if one of the interface is active, again either channel will form. And for static, all the two sides has to be on. Okay, so here what I'm going to do is, I'm going to do 3 methods. I'm going to do three methods. Now you can see on the 3 segments, STP is active and one of the link is down. Okay, so one of the side I'll be using PAGP. One of the side I'll be using LACP, and one of here I'll be mentioning static. Okay, so what I'm doing is I'm just using either channel to logically link this 3 switches. Okay, so here, in order to configure it, in PAGP, what are the working modes? Auto and desirable. Here, active and passive. In static, only one method, that is on. Alright guys, now first we'll go inside the switch, go to the configuration terminal, interface range F0/1 to 2. We are going to create something that is known as a channel group. Channel group, and we will be naming one number, channel group 1. Mode is auto. You can see that immediately the two of the interface went down. So right now, only with negotiating with the other two interfaces, they will be forming either channel. So we'll be configuring that there. Interface, we'll see what are those two interfaces. Again, it's 1 and 2. Interface range F0/1 to 2. Channel group 1. Mode is desirable. Okay. Right now you can see it's coming up. Okay. Enable configure terminal interface. Interface. Okay. This interface is F0/1 and 2. Yeah, okay. We didn't mention 2 over there. That was issue. Okay. So interface range F0/1 to 2. Channel group 1. Mode is auto. Now you can see they will negotiate. Now this interface should be coming up. We'll see what happened. We'll configure the second channel groups here. Okay, this is for LACP, guys. Okay, there is an issue. Enable show either channel. Show either channel summary. You can see interface F0/2. It's in PAGP mode, but one of the port is in block state. Okay, it might be an issue with the lab. I will just rebuild it again. Sometimes the devices that we use might not be reliable at that time. So here, building the same lab. Okay, same commands. Enable configure terminal interface range F0/1 to 2. Channel group 1. Mode is auto. And here I'm doing making it desirable. Okay. So again, enable configure terminal interface range F0/122 channel group 1 mode is desirable. Okay, now all the 4 interfaces have gone down. Yeah, now you can see now there is no STP. If you check in the first switch, you won't even see 2 links. Okay, again, exit, show spanning tree. You can see there is only one port number also which is mentioned here. So here I am going to mention the PAGP, guys. Okay, enable configure terminal interface F0 interface range F0/122 channel group 1 mode is here, it's active and passive, right? So active, we will have to also bind it from here. So interface range F0/3 to 4 F0/3 to 4 channel group 2. So first I made it here I think I made it active. So here I'm going to make it passive. Now after some time, those 2 interfaces also have come up. Now finishing the last EtherChannel configuration with static method, enable interface range F0/122 channel group 1 mode is 1. Okay, here the last EtherChannel, guys. Exit channel group 3, 5 to 6. This is channel group. Okay, I should not have typed that. This channel group, the method is on, and that's it. Now these 2 ports have gone down, and you can see there is no spanning tree in any of the segments. Okay, why? Because we are logically linking those together. Okay, so if you're checking it from the first switch also, you're typing show spanning tree. You can see there are only 3 ports. Like how many links are there by there? Like there are like 6 different links, but you can only see how many links? 3 links. Now the second advantage is that there are no spanning tree which is effective, and you can use the maximum potential of the link. Okay, show EtherChannel. You can see there are 3 different groups that you created. One is for PAGP, one is for LACP, and one is for static. And you can see like what are the ports also that is assigned. So how EtherChannel summary. Okay, so this is basically layer 2 EtherChannel that we did today. In tomorrow's session, what we'll be discussing is layer 3 EtherChannel and configuring the speeds of the different links, all those things that we'll be discussing in tomorrow's session. Okay, also after that we'll be in discussing some few security concepts like port security. After port security, we'll be discussing DHCP snooping attack. After that, we'll be discussing VLAN hopping attack. With these 3 methods, we'll be discussing in the coming days. Okay, after that, Yeah, after that, our switching topic also will be over. Okay, any questions, any concerns? Please ask.
What I might miss that. What is the use of this? I mean,
Use of the link is that you can increase the productivity of the network, right? You can use like the maximum efficiency of the network because there is no spanning tree which is active there. So we will be sending traffic. I mean, we can, if there is a heavy load of traffic, the traffic will be actually sent via F0/1 and F0/2. What is the use of a 4-lane road via 2-lane road? You will be able to send more vehicles. More vehicles will be able to travel at the same time, right? Naveen.
yeah. So we can consider it as an active and a standby also. I mean, if one link goes down,
No, both are active.
both are active.
Both are active. If
What?
active and standby concept is there, like that is spanning tree by default is in an active and standby concept. I mean, not in theoretically or not practically, but in a metaphorical way, STP is there in an active and standby state because when the active link fails, like the standby link will immediately come active. So here both the links are active. So in layer 3 ether channel, I'll be showing like how to set up speeds, like what is the speed that you will be able to send in one particular link, what is the link speed. So you can actually configure like what type of traffic that you need to send via F0/1, what type of traffic you need to send via F0/2. So there might be different requirements also for you to send. So there might be like voice over traffic, there might be data traffic, there will be some other type of traffic which will be there. So traffic will be actually categorized into different segments, and based on that, you can even use either channel to send traffic like that also. Like in customer care surveys, like the most of the traffic that they'll be using is voice over IP. Like you might have heard in LinkedIn also, like people are actually hiring for CCNA people like who know like voice over IP network configuration, right? So these people like they'll be managing the voice traffic inside the network because that's going to be a huge data.
What in that scenario if one link goes down? Suppose
The other
F0.
link will be active. The other link will be active.
Okay.
So here.
I mean, if any one link will goes down, then communication will work with the other link also, right?
Yeah, you can. I mean, I'll show you, bro. Shut. Okay. You can see the other link also goes down because the communication just stopped between like these two links, but the other link that is active now. We shut down F0/1, F0/1 shut down, but F0/2 is active, right? Up to 8 links you will be able to configure in either channel.
I mean, what we can do with the one link and what we cannot do with the two link. I mean, my question is that.
That is what I told Naveen. You can send different traffics based on different links if you want. Okay, different types of traffic will be there. Traffic will be actually categorized into different segments. I mean, that is again like more advanced topic. But again, what I am telling you is that if you have two roads at the same time, you will be able to, more vehicles will be able to travel at the same time, right? Like you can say that like in morning there is
I
no traffic,
completely
so
agree
we
with
don't need
you.
a 4-lane road, right?
If you're giving an example of a road, I agree with you. But
Yeah. But
if
what you're
that
saying
traffic,
is that like in morning we don't have any traffic, so we don't need any 4-lane road.
no,
But
what I'm saying,
what if there is more
if
traffic? What if more traffic in the switch?
if that will only work with the one link, why we need to configure this multiple of links? That is my question. Unnecessary. See, so the same traffic, if you're going with the one link, then that is the point.
No, I'm saying if you have more traffic, it is not going via one link, right? It is going via two links. Just because you asked me to shut down it, I shut down it. Right now, it is considered as one single link.
Fine, then fine. No question.
Okay. Guys, any other questions? Close PD means like Rita, are you talking about this packet? Yeah. I mean, nothing you do, just press P. Okay. 1 second. Okay, either you can select it like this, click on the device that you want to send, and click on the device which wants to receive. Okay, because we are sending into ports, you're saying here, open. Okay, here, if you want to see the travel also, you can see here, just, okay, delete the packets, create a packet from 10.1 to 10.4. The packet is sent. Okay, so open PD, but you won't be able to see the packet is traveling. Even open PD, okay. And okay, the open PDUs is not working here. It might not work in Packet Tracer also. Here, I mean, in open PDUs, all the protocols that we are actually using, it will be not visible. Okay, so here actually we need visible packets. So, and even I haven't used this before. Animation. Okay, so this is like a create a complex PDU, like you can mention. So here, the main difference is that like you can actually mention like the source IP, destination IP. You just need to mention like what are the destination IP address that you need. So I'm just mentioning 192.168.10.2. The source IP address is 192.168.10.1. And the detail, let it be by default. Sequence number, okay, size. Okay, create. This time. Yeah, 10 seconds. Create PDF from 10.1 to 10.3. Okay, it's not happening. Okay, I'll check that. I haven't used it, but here, like if you're using this, you won't be able to see the packets, how the packets are actually traveling, and it will be encapsulating all the protocols also that are actually being used. So you won't be able to see. Let me check again. Destination IP address is 192.168.10.10.2. 192.168.10.1 MS. Ten seconds. Okay, it's not going. I'll update you in tomorrow's session. Okay, whether we can actually use this here or not.
Hi guys, welcome to today's session. In yesterday's session, like we were actually facing one issue with the command. So the command that we were using, we were not able to. We were not able to. We were not able to use a spot fast command on the switch. So I've saved one lab here. Yeah, port fast. Okay, so the port fast command either you can apply directly on the switch or you can apply on the interfaces. On the current model that we are using, we are not able to apply it on the switch. We'll be only able to apply it on the interfaces. So as you can see that right now, the moment that we open the packet tracer, all the interfaces are up. Okay, I just wanted to show you that before. Okay, so or else what will happen? Or else like it will go through the spanning tree process and it will take a lot of time to come up, right? You can see here, you're connected between this to this. Okay, only after a certain time it came up. Right now with port fast, the moment that you open up, I can show it again. There. Open. No. Yeah. For first command, you can see the difference between like the two scenarios over here. The moment that we actually open the switch, open the lab, like they are immediately on the forwarding state. But if you look at the second topology, they are actually going through the different state of STP, and after certain time only the spanning tree will make sure that it will come to the forwarding state. But the device that we applied port fast, immediately it came up. Okay, so how do you do that? Again, enable configure terminal. You can select the interfaces. Since I'm selecting both the interfaces, I'm just using the range function, interface range F0/1 to 2, spanning tree, port fast. I've enabled port fast on that interface. Enable interface range F0/1 to 2, spanning tree, port fast. That's it. That's the only command that you have to type. Okay. Now we have enabled it. Now if I open this again, you can see the difference. Both of this thing will be opened at the same time. All the interfaces will be coming up. So there won't be any delay. So port fast. Yeah, port fast. So you can see the moment that you open the lab, immediately they went into the forwarding state. Only after getting into the forwarding state, its STP election also happened. You can see then only it blocked the port. First all the ports were initially up, then it went to the block port. Even in port fast state, it is that the port will not wait for the spanning tree states, but even then, like the spanning tree STP BPDs will be sent between like all the switches that are connected in the network. Okay. Now, in yesterday's session, we were also discussing about what we were basically discussing was we were discussing EtherChannel. After that, after STP. In today's session, nothing but just a small addition to yesterday's lab, that is nothing but layer 3 EtherChannel. Okay. So I'm hoping this 2 switch will work. If it does not work, we will have to switch it. Okay. Okay, checking this. Yeah, we'll use the second one. We'll take this 2 switches. Okay. In layer 3 switches, always you will have to power on the device. So I'm just using the power module, dragging and dropping the power module there. Okay. Once you drop the power module over there, I'm just using one command to configure it. Okay. So how do you differentiate? Okay, this is basically a layer 2 switch. In switches, like there are layer 2 switches and layer 3 switch. This is a layer 3 switch. This switch is also known as multi-layer switch. Okay, the main difference is that this switch can support routing. This switch can actually support routing. So to do that, like we'll be using the command enable routing. Okay, but here in this topology, we don't want it now. Now, what I'm going to use is I'll just configure EtherChannel for switch 1 and switch 2. Okay, you can use any mode, but there is only one difference. I can show you that. Enable configure terminal, interface range F0/1 to 2. Okay, that's not the range. The range is interface range G1/0/1 to 2. Okay, after you mention this command, we are using this command no switch port. Okay, this is just a command which is used to tell this is a layer 3 switch and has the layer 3 properties. Then what you do is you can create a channel group. CHNNEL channel group 1 mode is you can choose any mode. I mean, there is no difference between the mode that you are choosing. So here I'm just choosing static. Okay, channel mode 1 on. Once I mention that, okay, since this is having layer 3 properties, what I'm going to do is I'm going to assign an IP address also to that. Interface port channel 1 IP addresses 192.168.10.1 and subnet mask is 255.255.255.0. No shit. Exit. Coming to this particular switch. No. Enable configure terminal. Interface range G. Okay, we need to check that. G 1/0/1. G 1/0/1 to 2. No switch port. This is to make sure that this is basically a layer 3 device. Then channel group 1 mode is on. Exit. Interface port channel 1 IP addresses 192.168.10.2 255.255.255.0. No shit. Exit. Show either channel summary. You can see G 1/0/1, 1/0/1 to 1/0/2. Okay, we connect this in real time. This is not configured properly. There is issue with it. Enable. Second. One slash 0/1 to 2. Okay. So, okay. Show either channel summary. Okay. But anyway, the pool is mapped over there. I'm not sure like why STP is still showing. Like ideally it should not be showing. Like maybe it's a glitch. I'll update this also tomorrow. Okay. But let's see multi-layer switches. There are no STP messages that are actually passed. It is sent as a single link only. You cannot see any STP messages also that are actually passed between these devices. Okay. So just deleting it. But if you check in this show either channel summary, you can see the either channel is actually formed. Okay, the group is L2. Now, it's working. Show either channel summary also. Okay, it's configured properly only. So if maximum that if you have to do anything, just mention like IP routing. That's the max to it. Okay. Get out. Okay, okay, guys. Anyway, it's configured. So tomorrow we'll do an advanced lab with this. Like we'll be configuring like we can configure like multiple topology for tomorrow's session. Like some all the topics that we have combined together. Like by this by the next topic that I'm going to take, we are officially actually ending the switching topic also the routing topic. So whatever we have learned so far, we'll be integrating that into a practical lab tomorrow. Like NAT, ACL, TCP, DNS, like whatever it is, like we'll be including all of that in one particular lab, and we can discuss that. Okay, in tomorrow's session. Okay. So if you have any questions, please shoot. Before that, this layer 3 Ether channel, the main responsibility is that so in switching network, so there will be like layer 2 switches. Layer 2 switches will be connected to layer 3 switches for the core layers. From core layers to access layers, they will be connected via multi-layer switches. So in layer 3 switches, why you are applying either channel, it's basically for routing purpose so that they can effectively handle more data at the same time. Any questions? Any questions, guys?
Hi, John.
Yeah.
Actually, this multi-layer switches, we can configure all the routing protocols like OSPF and VGP.
Yeah, you can do that. Yeah.
So it will look like a router, right?
Yeah, do show IP route. You can see the routing table also inside the same switch.
Yes.
But first thing, you have to type this command IP routing again. Do show IP route. You can do that. In tomorrow's session, that's what I told. Like we can include that. Like we can include like once we mention port security also, the topic will be done. Then we can include that. If you want to include OSPF, the command is simple. Router OSPF process number 1. Network is 192.168.10.10.0 again 0.0.0.255 area is 0. Router OSPF person number is 10. Person number is 10. Network is 192.168.10.0 0.0.0.255 area is also.
Network spilling.
Yeah. Now exit to show IP route. You can see C only. Why? Because this is a directly connected network. So if you have like multiple networks per se, if you want, you can configure networks in each of this interface itself. So if you want, you can do that. And mostly when you're configuring like multiple links between switches, okay. So for redundancy purpose, like you can configure these 2 links at the same time, right? So once you configure these 2 links, if you have like multiple networks, you can configure multiple networks on each of this link. Then the next job will be easy. So in production network, like mostly for handling more traffic, people will be always using layer 3 switches over router because it can handle more computational power compared to a traditional layer 3 router. Any other questions?
No, thanks.
Now, the next question, the next topic that we want to discuss, that is nothing but port security. Port security is nothing but enabling security in each of the interface of the switch. Okay, like we were discussing in the previous day, day after the other day, all these days, the easiest way to for a hacker to get into your network is, for example, this is our hacker. Okay, just connect to our switch, they'll be having the complete access. Okay, so how we can remove that? Like one scenario we already discussed, one is using ACL. Okay, even in using ACL, what happens is ACL only do filtration on the interfaces level, right? They only do filter. They only do the. Okay, 1 second. They only do the filtration in the interface level. Okay, so here I'm going to take one server. So this is the server which is inside our network. Okay, so even ACL won't help us here, because even if there is an ACL we are primarily applying to the router's interface. So the traffic is not reaching in the router's interface. I mean, the server is within the network. Okay, I'm just assigning an IP to that server, that is 192.168.10.10. Okay, and if the hacker is also connecting to this network, okay, before that, let's assign few IP address. 192.168.10.1. .192.168.10.2. 192.168.10.3. If the hacker, they are also connecting to here. I mean, they might also can use any IP address in the subnet. Even they can use an IP spoofing and use the same IP. So if I can mention the same IP, even if I mention the same IP, then also we'll be having reachability. Okay. First, what this hacker does is he connected. Okay. So just to explain port security, what we are saying that is that he directly disconnected this device who is working inside our network, and he connected. The hacker is connected inside the network. Okay. Now the hacker is also trying to reach the server, that is ping 192.168.10.10. Okay, so when the frame is actually received in the switch, because this is basically inside the network itself, the packet won't go to the router. The packet will be actually processed by the switch. Okay, so once the packet is processed by the switch is not aware about the IP address. Switch is only looking at the MAC address field in the ICMP table. So once switch processes frame, switch will immediately see like what is the MAC address. Do I have the MAC address in my MAC address table? If yes, I'm going to forward it. Okay, right now even the hacker has complete access here, right? Which is something which is a vulnerable scenario. Okay, now in that case, we wanted to apply port security. Port security as in like we wanted to apply some security to each of the interfaces that are actually inside the switch. Okay, how do we do that? Any idea? By any method, like so far, like we discussed so many scenarios, how we can include port security in interface level. What will be the criteria, guys? Any guesses?
VLAN trunking.
MAC address binding. I know. VLAN trunking also won't help, because that also happens at the later stage. Because yeah, again within the VLAN, like again the network attack can happen. So the best and the most effective way is to configure MAC address binding or static MAC. Both works effectively. Okay, so here enable show port security. You can see there is no port security which is enabled. If there was port security, you would have been seeing this port security. Okay. Show port security interface F0/1. You can see the complete details. Interface F0/1, what is the status? It's disabled. So when something is happening, it's secure and down, but since it's disabled, we are not going to read any of it. Okay. So first we have to make it enable. So how do we do that? Configure terminal interface sysport okay interface F0/1 sysport port security. Sysport port security. First, what we have to do is we have to enable. Okay, so it is by default rejecting because of the DTP. So I'm just changing the mode of the switch. Sysport mode access sysport port security interface F0/1. Okay, port security. Okay, first thing you just have to mention sysport port security. Now check the command do show port security. Port security is enabled. If you want, you can check on the particular interface also. Interface F0/1. Okay, port is enabled, guys. Port security is enabled. Port status is it's secure. So if somebody tries to violate it, what will happen? It will shut down. Aging time is basically 0. Aging type is also absolute. Again, secure static address aging, it's disabled for now. Okay, maximum MAC address that we can configure. Right now it's 1. If you want, you can change it because depending on the number of shift people are using, depending on the number of devices that are actually connected to the port, you can actually add or decrease it. Total MAC address that is configured. Okay, this is which is important now. So how many MAC address is configured? So even if port security is enabled, what you can see is that even if the hacker is connecting here right now, even now port security is enabled, right? Now also, okay, STP guys. Now you can see they're getting the reply, which means port security is completely not enabled. Now what we are going to do, we are going to enable port security. Switch port security, MAC address. MAC address of this device. What is the MAC address? Let's see. Physical, desktop. This is the MAC address of that device. Okay, so I'll copy it, paste. Okay, found a duplicate MAC address. Okay, this is one glitch that you will get from Packet Tracer. So what I will do is I'll be using this command that is known as sticky. Okay, so it will dynamically capture the MAC address. Okay, it will dynamically capture the MAC address of the device. How do we do that? We can just use a ping test. Okay, so it will actually capture. Okay, so the first thing that you have to be very clear is immediately you configure it, you will have to ping on that interface. Ping 198.168.10.10 or any IP, but the packet has to reach there. Okay, it will only learn the first MAC address it receives. Okay, so if you just configure port security with sticky and if some other people they are pinging it first, that MAC address will be captured. Okay, just to make it sure. I am actually trying it again. Now what happens is I'm connecting to the hacker PC. Again, the hacker is trying to ping. Okay, there's a glitch. Now, what you might observe is this is a packet tracer glitch. If I try to ping back from the legit device again, they'll drop it. Okay, this might be the scenario. Immediately, this interface. Exit. Okay, 1 second. Show port security interface F0/1. Okay, the problem here right now is the MAC address is not capturing here on this device. Okay, even after multiple pings, the MAC address is not getting captured. Okay. Interface F0/1. No switch port security. Disabling it. Clearing it again. Interface F0/1. Switch port security. Switch port security. MAC addresses. Okay, since we have like multiple devices in packet tracer, that is the reason why we are getting this duplicate MAC address. This address is actually of the PC1 itself. Okay. Now, how we can overcome is this by using the command sticky. But the problem with sticky command is switch port, MAC switch port security, MAC addresses, sticky. Okay. So once I mention that, I have to immediately ping. Okay, replay is coming. Now what I have to see is to show port security interface F0/1. It's not happening. Okay. I had to clear it again. Nine 8.16.10.10. 8.16.8.10.1. 2 and 3. Okay. Now trying the same commands again. Sometimes we will have to come out of the lab, close it and do it again. That's some problem with the simulations. Okay. So configure terminal interface F0/1. Switch port security. Do show port security interface F0/1. You can see. Okay. It's disabled. Okay, so what we do again, go to interface F0/1, switch port mode access, switch port security interface, switch port security. After that, try looking it again, do show port security interface F0/1. Now it's enabled. Okay, maximum MAC address is 0, total MAC address is 0, configured MAC address is 0. Okay, now let's copy the MAC address. Go to config, interface fast Ethernet 0/0. That's the MAC address of the device. Control C. Okay. Switch port security, MAC addresses. This Okay, guys, see this? We did the same thing, but right now it actually captured the MAC address. So the problem was that the previously the MAC address was not capturing. Now what you can see is that, okay, ideally when some other devices they try to access, for example, let's say this is the hacker. Okay, and the hacker is trying to access it. He is disconnecting and connecting on this particular port. Now, right after STP, he is trying to ping desktop, ping 192.168.10.10. Okay, he is trying to ping, but you can see what the request timeout, and request timeout. Okay, now there is one more issue that is actually happening in the simulation right now. That is, this interface should have been going to shutdown mode. Like there are actually three modes. I don't know what is happening with the software right now, but immediately, so the violation mode that is actually mentioned here, if you could read, you could understand that if somebody tries to violate this particular rule, it is going to shut down. So how do we see if somebody tried to violate it? Okay. So again, show port security interface F0/1. You can see it is enabled. Violation mode is shut down, absolute, and security violation count is actually mentioned. Okay. For shutdown mode, you won't get it, but for protect and restrict, you will be getting it. Okay. Now, when you're connecting back to the same device, let's see what is happening here. Ping 192.168.10.10, you are getting reply. Okay, but when the hacker is getting connected, they won't be able to connect it. Why? Because port security is enabled. You can see the request timeout, but again there is a glitch with here because like there are three security violations. First one is shutdown, restrict, and protect. Okay, by default this is in shutdown mode. Now what I'm going to do is enable configure terminal interface F0/1 this port security violation. Okay, so manually again mentioning it, shutdown. One second. Let's actually try it from a different software right now. So this is another similar software like Packet Tracer, but this one's name is known as EVNG. This will give us like more advanced scenarios, but you won't be able to see the simulation mode and all other modes when you are working with this. Okay. So how do you log in? Like you need to log in via this IP 192.168.92.31. Okay. So 192. Yeah. Now, for security. The main problem with this is it will take so much time to load one single device because like this is working on the actual devices. Okay, so no, I don't need that now. Okay, so taking one switch. Okay, we have one switch right now. I will add few more nodes here. Okay, what I need instead of this, I will be using PCs. Taking 3 PC. Take 4 PCs. Okay, this is going to be my server. Okay, so this is how it's going to be. Now, first, before doing anything, we'll assign IP address. To do that, we need to start the devices. Okay, just mention to start the devices. Once the devices are started, again here the problem would be even when we were working with Packet Tracer, the main advantage is we would be able to see the interface lights, so that we will be able to understand. But because the shutdown mode, the main drawback is that when you're pinging, like this is actually working like a different mode. So even in shutdown mode, in actual scenario, what would happen is if you're pinging back from the real device again, you won't be getting reply. Okay, even on the real device, you won't be getting the reply back, but here you're actually getting it. Now, since the devices are on, okay, now we'll configure IPs to on. IP address is 192.168.10.1. 255.255.255.0. Okay. We'll configure the right IP. Now, coming here, configure IP for the second device. IP is 192.168.10.2. Here, the IP is 92.168.10.10. Okay. Now, this is the switch. Okay. Think the switch is booted up right now. Okay. Enable configure terminal interface. This is gigabyte Ethernet. So interface G0 slash G0/0. Switch port mode access. Switch port security. Switch port security. Port security MAC address is sticky. Okay, so I'll just capture the MAC address now from this device. So the first ping that will work. Okay, so ping 192.168.10.1. That is the same IP. And now we are getting a reply. Now we'll check the status here. So how to check it? Show ports port security interface F0/1. To show port security interface G0/1. Okay, now show port security. What? Yeah, okay. G0/0. You can see it's enabled. Okay, configured MAC address is 0. Sticky MAC address is 1, which means one MAC address we have already learned. Okay. Now, what will happen if some other device? Okay. Again, the drawback is that here you will have to actually shut down this device. Then only it will work. Okay. Now, to do that, again, there are problems. Once we shut down, the configuration will be lost. If you want to save this configuration, we need to write it. Only if you write the configuration will be stored. Okay. Now they're saying that it is configured successfully. So what I'm going to do is I'm going to stop this device. Okay, stop the switch. Once the switch is, and this PC also I'll put back in the stop mode. Okay. Starting the device now. The device is started. Okay. Waiting for the switch to come up. Okay, so how do we start? Now the switch will come. IP address is 194. IP is 192.168.10.8. Okay, now let's say we are pinging 192.168.10.10. Okay, so this is again booting up, so that is why it is taking so much time. Normally, if you want to see this, even in Packet Tracer, even in EVNG, you won't able to. I mean, you will be able to do everything like the normal device, but to show like the interface is going in shutdown mode, since the simulations are not there, it is little difficult now. Okay, this VPC, it's not reachable. Okay. Again, now I hope, yeah, host is not reachable. Now, if you plan to connect it back to the other device, again, you have to stop it. Once you stop this two device, you can disconnect this cable. Now connect back this device. Okay, start it. Start it. Okay. Once you start it, again, you will have to power on this. This is the issue, right? With this. I mean, on real devices, you can just unplug and connect it, but here, working with images is the problem. We cannot do a modification like while the switch is actually powered on. It has to come up. Okay. By this time, I'll just replace the switch with another switch and see if we have any luck. Okay. Related. Security violations shut down. Now, pinging on the device, you're getting the reply. Now, verifying it, show, do show port security interface F0/1. Configure MAC address is 1, sticky MAC address is 0, total MAC address is 1, shutdown enabled, secure up. Okay. Now, the hacker is connected. Hacker is trying to connect. Okay. This is the problem that is here. Now, let's see back from the other device. Okay, our switch, our topology. Now, I hope I'll be able to show it, or else we'll work with a different thing in tomorrow's session. Okay, we will figure something to do it. It's a small topic, but it used to take like hardly like 15 minutes to explain, but today it got completely missed. Thing 192.168.10.10. Yeah, this is what I wanted to actually show you. Okay. So even from the legit device, when you're actually pinging up, you are not able to ping. Okay, this is what I want to actually show you in Packet Tracer. Even if you're pinging from the legit device, you are not able to ping back. Why? Because the port has actually went into shutdown mode. Okay. Now I'm going to the configure mode and doing some changes. Okay, this will take some time. Guys, who is watching this recorded video, please don't watch today's session. We'll be repeating it tomorrow. Okay. So if not, if it is not fixing, like let me uninstall Packet Tracer and install a newer version. If there are any bugs, I'll be removing that bugs by tomorrow session. Okay. Now, enable configure terminal interface G0/0 shut and no shut. Okay. I'll explain why I did that in tomorrow's session. Okay. Now, let me go to the PC back. Okay, even if there is a timeout. Okay. Today we are not going to discuss port security. I was trying so much time in the same lab and changed few configurations, but even now it's not working. So I thought of I've reported a few bugs with the Packet Tracer. Now I'm waiting for some response. So by Monday, hopefully, I think we will be able to solve it. But if not, we will explain that theoretically. So port security is something which, if we explain theoretically, like you will get a little confused. That's why I wanted to explain it practically. So once the bugs are getting fixed, I will be teaching that port security. Now, there are like after that also, like for some like layer 3 EtherChannel, like a NAT, PAT, all those things, like I had designed a topology. Even for that, like some of the commands are not working now on the current version. So I've just reported that, like, so we will discuss that like once we discuss all the other topics. So the only lab that seems stable today was the lab for wireless. It's a very basic lab which we'll be doing it for today. First, we will discuss the theory portion of what is wireless. Okay, so in CCNA syllabus, how wireless is actually defined is on the basis of like you have absolutely no idea what is wireless. But that's not the scenario. All of you guys who are attending this class, not almost, like I believe everyone, you must have used wireless devices in. I mean, without using wireless devices, you won't be here, right? Yeah. Anyway, so we are talking about wireless devices, wireless networks. So, like you can say, like I am connected to a network. You will be connected to mostly a Wi-Fi, or you might be attending it from a network. But again, that will again like wirelessly connected, right? How I don't believe like any of you guys are accessing internet right now with LAN cable or Ethernet ports. But yeah, maybe you must have done that. But of course, you have used wireless in your career, like at some point, right? So in the syllabus, actually, it is defined on the basis of why wireless and what are the advantages of wireless, which are some of the things you might be already aware about. Anyway, since it's there in the syllabus, like we will be just discussing it and moving forward. Okay. Now, first thing is what is a wireless access point? Okay. So mostly everyone, before doing CCNA back in 2019, even I used to call the device that gives the Wi-Fi as a router, right? Almost everybody might be calling the same name for access points. So the device that actually facilitates us, or the device that actually gives us internet, it's not actually the router. It is known as access points. Okay, you might have used, even it's branded as router, so it is actually getting confused with the name. So this device, it's not just a router. This is basically an access point. Okay, this is basically an access point. But if you look at the same switch, what you can see is that the same, the same access point, it has the properties of a switch, DHCP server, and routing is also enabled here. That is why we are calling this as a router. But in correct perspective, this is actually known as an access point. What access point does? Okay, so like the picture that is shown over here, what access point does is that like you will be able to connect to a network wirelessly. So this person who is using mobile, he is not connected to any wire, right? He is actually using internet through or the connecting the network through the Wi-Fi router. So the Wi-Fi device is emitting certain type of bandwidth, like radio spectrum bandwidth. So till the connectivity is there, you will be able to connect into the network. What is the main advantage with this compared to the traditional network? Okay, in traditional network, for example, when we have an office, okay, in an office, like there might be like 20 people like who is visiting the office who wants internet. Okay,
So if there was no wireless, like we want to have like more switch ports which are free, which is available for the guest. Again, like we don't want switch ports which are actually in our core network, because we can't trust the people like who are coming into the network also, right? So what we do, we might be having like extra few switches which is connected to a different network. From there we'll be drawing LAN cables. At the end of the day, it is going to be a Spider-Man tunnel, which is not something which we want. But the help of wireless, you can reduce the cost, the time, and it is easy for you to manage also. Okay, you can just deploy an SSID like you see over here. This name that you actually see over here, that is an SSID. So when you are actually using Wi-Fi, you might be connecting to a service set ID. The name that you see is known as service set identifier. Okay, so this SSID, like multiple SSIDs will be deployed. When you go to your office, you might be seeing SSIDs named as IT, admin, business, HR. Different names will be given for different service set identifiers. So you can deploy a certain type of SSID based on the network that you actually want. It can be actually deployed from this small device. Okay, so in offices, we are not actually using the traditional access point like the one we actually use in our home. Okay, so here in offices, what we actually use is business grade access point. Business grade access point will let people to connect. More than like 60 people will be able to connect at the same time. So when we were in college, like we had an access point. So we had around like 80 people like who are inside the class, like who wants internet, right? So 80 people, like they'll be able to connect to one single access point without having any problems. It will be a little exaggerated if I say like without having any problems. There were of course problems, but it was not so much, because like there is another access point which is there, which is actually in the staff room, like which from where also like we might be getting connectivity if there is an issue with the bandwidth, right? So what is an access point? An access point is a wireless access point, which is a networking device that allows wireless capable devices to connect over a wired network. It is simpler and easier to install WAPs to connect to all computers or devices in your network to use wires and cables. An access point is a device that creates a wireless local network. Like a physical network, it will create a wireless network. Okay. WLAN, usually in an office or a large building. An access point connects to wired router, switch hub via Ethernet cable and project Wi-Fi signal to a designated area. So it will be projecting, the access point will be projecting the signal to a designated area. So if you are not near to the access point, what will happen? Like you might not get that connectivity properly, right? Because like less bandwidth will be given to you. Now, advantages of using wireless access point. This is something which we already discussed. When both employees and guests are connecting to desktop, laptops, and mobile phones and tablets, I mean, like more number of people who are coming into the network with more number of devices, it's going to be adding a lot of cost, because like you need to have free up ports. Again, like you need to connect LAN cables. Again, connecting LAN cables is always a hectic task if poor people are actually designing it. So you need to have a very good understanding about like how the network should be actually designed, where the systems are should be projected. Even with multi-grade or business access point, in many of the organization, what actually happens is that even in the big corporate offices, like they don't know like where to place this access point. This access point is something which is emitting radio spectrum waves, right? So again, like 4G bands or 5G bands, like if you want, you can say it like that, or some radio spectrum waves is going to be emitted. If it's somewhere near the wall, it is actually blocking the signal. If there is a metal which is happening, which is there, which is interfering the communication, glass, cement, it is all going to affect the communication of the access point. So it's very crucial. Advanced network engineers like L1 engineers who really have some knowledge, who are not field engineers, what they will do is that they will go over the building, see the area which gives the maximum connectivity. Once they find that what is the area which gives the maximum connectivity, they will install the access point over there. Then they will also have, okay, this is the very most crucial thing, like when you're actually designing a network. Okay, so again, the most crucial thing that you should be doing over there is like you should have an approximate idea like how many people are going to be here and what are the bandwidth that they will be requiring. Based on that, they will be installing business grade access point at different points. Using business grade access, okay, business grade access point can be installed anywhere. You can run an Ethernet cable. Okay, So if you are using an Ethernet cable, the only criteria is that like you can just connect it with an Ethernet cable. The power will be also drawn from that particular model. Newer model also compatible with power over Ethernet cable. Okay, why? The newer version of access point, the main advantage is that like you don't even need a power. It will be actually drawn from the LAN cable itself. The certain type of LAN cable that we are using over here, that is known as power over Ethernet cable. So with signal, like power also will be given to it. So if you're working, how many of you guys have actually seen an IP phone in office? How many of you guys have actually used IP phones? Anyone? Any of you guys remember it?
Yeah, we have IP phones.
Okay, how is IP phone connected in your network? Like it might be connected backside of your desktop, right? You are not using any other power which is
We are using POE cables.
PoE cables, right? So PoE cable will give power. I mean, you don't need any other PoE using the
We have
PoE
connected cables to POE switch.
a PoE switch. Okay, so it will give you it will give you an IP, it will give you the connectivity, it will give you the network, also the power. So that is a main advantage of using power over Ethernet cable. So even today's scenario, like this is the most common trend because to avoid power drawing, and it is actually very cost effective. Okay. Because security cameras, that was a huge hectic task back then, because like you need to draw power from multiple places. Even today the security cameras can be actually installed with power over Ethernet cable. You don't need an extra adapter or extra power source for connecting that. Okay, additional standard features include captive portal and access control list, which means ACL. Supports, you can limit the access without compromising network security, as well as easily manage the users within your Wi-Fi network. Okay, back in the day when I was using ACT, okay, so you will get a portal. In the portal, you can actually log in and see like who are the people like who are actually connected to your network. Okay, and what are they actually browsing. So you can get the cache, like you can see like what people are browsing, how much. Okay, again, what you can actually do is that you can actually limit the bandwidth for certain devices. So if you have used torrent, like you can see like you are setting upper limit and lower limit, right? So like that. So based on the nodes that you're actually using, so you can actually set, okay, what is the bandwidth which should be given to this node, what is the bandwidth which should be given to this node. Also, this ACL feature, it's already inbuilt in your phone also. So I mean, any of you guys remember when COVID was there, like all of you guys were working from home or working from working from home, like you might be having like a lot of roommates like who are free playing PUBG at that time, and they also need internet. Like when they are running out of the internet, like since we are working, like they might be connecting to our network and drawing this Wi-Fi. So to limit that, like what you do, like you made your Wi-Fi network not visible to certain hosts, right? Some of you might have done that. Uh, what you can do is that even on your hotspot, when you are powering on your hotspot, you can hide it from certain users. Like after only you unhide it, they can see that your network is actually up. And for some certain people, like you can block the access if you want. That is what you can actually do in ACL. ACL is what? Nothing but a packet filtering process. Okay. Now, selected access point include clustering point, a single point which IT administrator can view, deploy, configure, and secure Wi-Fi networks. A single entity rather than a series of separate access point. So in the access point that I'm connected to now, this is my home network. Okay, so you can see like, okay, let me 5G, it's from a different place, I don't know. Okay, you can see like two access points are, two SSIDs are deployed from the same access point. If you want, you can deploy like multiple access points, SSIDs, and mention what are the different networks and who are the people like who are entitled to use. You can deploy it from here. And what is the main advantage, guys? It's security. Okay, in yesterday's scenario, we were discussing about port security. Unfortunately, we were not able to discuss it further. But in port security, what was the main drawback? The main drawback was anybody could connect to the port, right? Until and unless like MAC address is configured. Here, the main advantage is that there's a username and password. Okay, even if the Wi-Fi is open, only if you have the username and password, you will be able to connect. If you don't have the username and password, you won't be able to connect. Okay, and when we were actually in college, okay, so what our network, it used to be it used to be open. It used to be like an open network, but nobody would be able to connect it. Why? Because it's MAC binded. Okay, so only the laptop or the PC or the phone which is having the certain MAC address will be able to access this. MAC address is a static address which is not changing, right? It's not some dynamic address like IP. So MAC address is a very static address which is not changing. So MAC binding will be done. So only the people like who are having that MAC address can access that particular SSID, even if you are actually putting that into an open mode. So you can import security in multiple perspectives. But again, talking about security, there is nothing that is called a security. Security is a myth. Okay, so whenever you build a security patch, in 2 days, like people will actually break it. Again, people will develop another patch. Then after that, it will going to break. So no point in that, because people will always break things. I mean, you can actually break into a network very easily if even if you are building like multiple prevention mechanism. Even now there is might be a new vulnerability that will be coming. Okay, and yeah, so that is a main advantage, guys. You can deploy multiple service set identifiers. You can have access list. You can use what? Yep, power over Ethernet, and you can use clustering features, and security is also included in access point. Any question for access point? Most of you guys already know what is access point and how it works, right? So any questions? Is it clear?
Then we will go it with deep, or it will only just the basics thing?
Basic things.
Actually, for in exam, I think wireless is also added, right? For this year?
Yeah, in wireless is also added. If you look here, CCNA 301 syllabus, exam topics. Connections. Okay. IP connectivity. We discussed all those things. IP services. There was a field called wireless.
Yeah, 3.4 in 3.4 section. Yeah.
3.2.
2.4.
Okay.
Yeah,
2.4.
Wireless architecture and IP modes. 2.6.
2.6. Yeah. Again, describes Cisco wireless architecture and AP modes. That is just access points modes. And okay, then describe the physical infrastructure connection like VLAN, AP, WLC access, trunk ports, LEG. That like basic things. Mean nothing more than what you are seeing basic. Also, there is one more thing that you will see. Yeah, discuss about WPA, WPA2, and WPA3, and configure and verify with GUI, that is on Packet Tracer, with WPA2 and PSK. That is what we are actually running for wireless. Very basic. There was an actually, okay, I did my CCNA in 2019. So when I was actually doing my CCNA, so there were actually different tracks that is known as CCNS, RNS. Okay, how many of you guys knew this track? CCNA, RNS, CCNA, service provider, CCNA security, CCNA collaboration, like different types of CCNA was there. See, for CCNP also said the same thing. It was not NCore or SCore back then. It was like CCNP routing and switching, CCNP wireless, CCNP security, service provider, all those tracks were there. And later Cisco integrated it. Once Cisco integrated this, they removed a lot of topics and put topics from all over the system. Okay. And if you actually learn wireless, there's going to be a huge opportunity, but you won't be actually learning wireless from here because like we only have a limited topic to discuss here. If you're actually learning wireless, there are actually good opportunities, really good opportunities. I mean, if I would not recommend anybody to write the CCNA exam, because like too many people are using different methods to clear the exam. So the CCNA certification is not so valid. But if you are writing CCNA wireless exam, it's going to be having a lot of value. It's going to give you a lot of boost in your career from the beginning stage, because wireless is something which is actually booming right now. Wireless, voice over IP, if you have the skills, it is easy for you, as if even as a fresher, you can land into an entry level job. And if you are actually planning to learn that, I do have some materials, but we won't be discussing that in class, but we can share it with you. Just ping me, I can give that. Okay. Any questions with access points? Any other questions? Can I move to the next topic? Yes. Okay. Now we are going to discuss something that is known as wireless LAN controller. A wireless LAN controller is a centralized device in the network which is used in combination with a lightweight. Just text me after this, we'll discuss. Okay. So wireless LAN controller is a centralized device in the network which is used in combination with lightweight access point, that is LWAPP. It is used to manage lightweight access point in large quantities by network administrator or network operation center. It is known as a fact access point. This access point on the network are managed and operated and configured independently. Why? Because it is a device which is used to connect all other access points. If you look in your corporate office, like you can see on the same floor at least like 20 to 25 access points are there. Okay, whenever you have to make any small change, you won't see the network admin or the system admin. They're coming with a ladder and doing the deployment from the access point, right? I mean, actually, you don't need that. You can actually log into the IP and do the changes. But what exactly happened in production is it's something different. All the access points, they'll be connected to the below device A, B, C, D. They are the access point. It will be connected to a device which will look like a switch. Which, okay, you can see this is a device which is looking like a switch or a router. So it will be connected to the wireless LAN controller. So wireless LAN controller is nothing but a device which is connecting to all the access points. Okay. Now that is also known as a access point. Because of its centralized position and brain power, wireless LAN controller is aware about wireless LAN environment. It provides us services that can lower the price of deployment, ease the management process, and add several layers of security. Now, functions of wireless LAN controller: traffic aggregation and processing for wireless devices function. And when all the traffic from wireless devices is routed by a controller, you can use it to encode it, divide it, and send it to different networks to be filtered to prioritize according to the establishment quality of policies. So in the next section, we are going to discuss about quality of services. So different types of traffic are actually there inside your department. Okay, so this will be something which you'll be actually learning once you go deep into wireless. So different types of traffic, once you learn QoS also you'll get few idea. So based on the type of traffic, routing will be done. Okay, so how you need to prioritize one traffic for one network or another network. Okay, for even in an office, office would be a bad example. College, okay, because like we can compare of an enterprise architecture, because like multiple buildings, multiple classrooms, multiple blocks, right? So all the people like who are in that building or in that space, students like anyway, like they will be giving the less bandwidth for the students. Okay, but in the same building there will be teachers, like the staff network. They'll be giving like more priority or more bandwidth. But in the same system, like there will be like IT admin or like any other people, like the system accounting systems, or the admission, all the systems that are actually running to make sure that the institute is actually working fine, or the server room, all those places, like they'll be getting the maximum connectivity. So all those things, like traffic is aggregated based on the quality that you actually need. So that is something that you can actually do it from the LAN controller. Management and operation function. These two functions enable you to utilize, manage the wireless local network in much simpler manner. And local wireless function, in case of radio features of wireless technology, it is preferable to utilize the coordination and protection mechanism in the radio spectrum for more efficient use in a particular area. Benefits of wireless LAN controller: it is secure, because it is secure. Nothing but like the same points for the access point. You can, with all the daily news about hacking and data breaches, a security is an essential factor to have in mind for an organization. Wireless LAN controller WLC finds all kinds of threat to your organization based on user ID, location, and thanks to its inbuilt characteristics. So different wireless LAN controller, they do have different types of security features, and all other access point also they are actually trying to use different types of security. But again, this is something which is easily breakable if we are not using proper wireless LAN controller. Again, wireless LAN controller you can limit it, but you cannot completely restrict it. Okay. It is centralized because you don't have to deploy configuration individually on each devices. You can deploy it on wireless LAN controller. Later, the configuration will be deployed to the access points. It is simple. Having a wireless LAN controller will help the administrator to supervise your access point in a centralized hub. Any questions for wireless LAN controller? Okay. Now, we are going to discuss Wi-Fi security protocol. We're going to discuss Wi-Fi security protocol. Okay. So, if you click here, you can see, okay, the SSID, that is a service set identifier, that is a name, don't bother about it. You can see protocol is Wi-Fi 5, since this is 5G, this is Wi-Fi 5, 8.2 LLAC, that is the protocol that is used for the encapsulation. And the security type, you can see it is mentioned as WPA2, that is again personal. Manufacturer of this network, Wi-Fi is Intel, and description is Intel Wireless. And you get the driver information. Network band also you get, it is 5 GHz. Network channel like you have 36. Link speed is right now 585. So maximum you will be able to use 5G 585 MB per second. And there is also an IP v6 address which is given, that is link local IPv6, which we'll be discussing how we are actually doing it in tomorrow's session. Now, after that, we have IPv4 address. So this is something, since there is a DHCP server which is already present in my Wi-Fi, what happened is they have given me one IP, that is 192.168.1.32, and there is a DNS server. Okay, this is like 100.3.163.112.48. So the moment that I use any translation, it will be sent to the IP DNS server, which is actually given from my SSID, and this is the physical MAC address. Okay, so once you get this, like the most important thing that we are going to discuss now is known as security type, that is WPA2. Okay, so before discussing about WPA2, discussing about WPA2, we discuss how Wi-Fi was actually developed. Okay, Wi-Fi was initially actually developed in the times of in the time of World War itself, because there were two scientists, like there were some models or actors who were actually tried to develop a radio hopping mechanism, which later turned into Wi-Fi protocol. Okay, so in Wi-Fi, since security was an important factor, people decided to add certain type of encryption for the messages and all other information that are actually used over here for usernames and passwords. So the first Wi-Fi security protocol came. This first Wi-Fi security protocol came in 1999. It was soon replaced. It didn't last for like so much time. It was replaced in another 4 years. WPE stands for Wired Equivalent Privacy, which was the first Wi-Fi security protocol, which was approved in 1999. It was initially expected to deliver the same security level as wired network. A secondary function of WPE is said to prevent unauthorized access to wireless network. However, it has been found that it is not secure as desired. WPE2 is used to two lower layers of Wi-Fi model, which means data link and physical layer. Therefore, does not offer end-to-end security. Nevertheless, at this time, cryptographic technology was restricted and Wi-Fi devices were limited to 64-bit encryption. Even though the limitation was broken and increased to 128-bit, there were many security issues with WPE that made keys to easy crack, and WPE was highly vulnerable. Wireless security protocol, it was replaced by WPA. Okay, so WPA came in 2003. Okay, so the first protocol, it only lasts like 4 years. Then WPA came in 2003. As WPA gradually performed its weakness, WPA was adopted by Wi-Fi Alliance as an alternative for WPA. 256-bit encryption technology was introduced to WPA. which is an obvious increase compared with 64-bit and 128-bit encryption in WPA system. In WPA standard, there is a diversity between two models like WPA Enterprise and WPA Personal, which is used in different encryption methods. WPA Personal is common method to secure wireless network, and it is suitable for most home networks. WPA Enterprise provides security needed for wireless networks in business environment where radius server is actually deployed. Okay, so we are really not talking much about this. This is the basic information. We are actually going to talk about WPA2. Okay, so WPA2 came right after 1 year. After 2003, even the encryption standard, like since it is 256-bit encryption, that is the reason which I'm not discussing that. So immediately it got replaced because that was not sufficient. So WPA2 was ratified as a new Wi-Fi security standard, which came in 2004. But if you look here, even now, we are actually using what? WPA2. We are actually using what? WPA2. Again, this protocol was also replaced, but the protocol which replaced couldn't perform much, so people are actually not using that so much. The most significant improvement in WPA2 security as a standard is the implementation of advanced standard encryption, AES. So FBI, all these people, like they actually encrypt the data with AES encryption. It's one of the most hardest encryption. It was said to be the most hardest encryption standard, which provides higher security and performances. There is still vulnerability that brings security problems because hackers can get access to secure WPA2 networks and get access to certain keys and attack other devices on the same network. It is a security issue that matters enterprise network instead of home network. Okay. If you have used Kali Linux, like there is a tool that is called as Wi-Fi. Is there anybody who has seen that tool like Wi-Fi in Kali Linux?
John, even in mobiles also they have provided apps to crack the Wi-Fi.
Yeah, crack the Wi-Fi. So how do you actually crack? Do you understand the science behind that hack?
No.
Okay. So the science behind that hack is first they will deny all the services for all the people. There are different types of attacks. Like the most common attack that actually happens is known as the dictionary attacks. Dictionary attacks, it's much simple. When the ISP is giving you the first Wi-Fi password, mostly what happens is that they might configure the password as your mobile number itself, right? So some of you guys who are attending this class, if yes, you don't have to say it, but you know that some of the Wi-Fi service providers, like they have configured your configured what? Configured your Wi-Fi password as your mobile number, right? For you to remember it, and you can blame them because like people like they will ask them to put that as the password itself, and since they put this as a trend also like to configure that, okay, because even for ATM like you will still use the different types of marriage or birthday or like any particular dates which you will be easily remember. So what happens is that I'm just taking a random number 987654321. Okay, 987654321. I'm assuming this is somebody's mobile number. Okay. So what happens is that like there will be a dictionary which will be mentioning all the passwords, all the 9-digit passwords or 8-digit passwords or 10-digit passwords. It will be starting from 8. If you are using a dictionary of which is consisting of numbers, it will be trying all the sequence of these numbers, which is starting uh, from any number, which will be covering all the numbers which are ranging from 1 to 0, like all possible numbers. In the first digit, like there is only like 10 possibilities, right? In the second digit also there is 10 possibilities. In the third digit also there are 10 possibilities. Like that, it will flush try to break the device with flashing so many passwords at the same time. This is known as one kind of dictionary attack. And if you use another, okay, word list, dictionary attacks, word list. So you can actually download like the most common word list, which are there. Okay, I mean I have to download the GitHub, so that will take time. So we'll download some word list from somewhere. Okay, WP2 word list.
That is also the GitHub links. Okay, you can't trust because you have genuinely no idea what is their intention. But what I want to say is that, like, some people, okay, we'll explain with this. Some people, they will have the password as password. Some people, like, they will have the password as their religious. They will have God is love. Okay, so whatever it is, they'll be having a lot of passwords. So in dictionary attacks, what happens is that it's mainly a collective of all the hackers, all the security engineers. Like once they found or try to get able to breach a password, like they'll be adding to that word list. The next time they're actually attacking, so 75% of the passwords that I can be actually broken with dictionary attacks, because the password that you are using is might be actually using from some other place, and that password might have actually been broken by some other place. So what happens is that what happens is that uh, they'll be using this dictionary and they'll be flashing it to your system using a Wi-Fi or any other tool. So what happens is immediately they will be breaking into the system. Once they're in the system, they will be able to take down your network. That is one way. So don't put numbers. If you put any number or any 9-digit number or 10-digit number or an 8-digit number, it will be broken in less than like 60 seconds. Your password can be actually cracked. And the other attack that people will be doing is that they'll be targeting this connected system that are there in the network. Okay, once they find out like who are the people like who are connected in the network, they'll try to attack those particular things. If that is also not working, social engineering is a very good tool. I mean, if you just go to the profile of your Instagram account, LinkedIn account, Facebook account, or whatever social media platforms that you get, people have a tendency to reveal so much information. So you will get some certain keywords, certain dates, certain numbers, certain number, like even so Instagram and Twitter, like they used to give so many numbers. So with human psychology, this numbers is something which will be keep repeating in their passwords, in their ATM pins, lot of other places, and which might be something which is linked to the vehicle number. So social engineering attack, it is one of the easiest most attack. And the easiest social engineering attack is like you will just ask the person to give the password and they will give. So all these attacks, it is actually breaking what? It is actually breaking WPA2. Okay, so we tell this to everyone when we are actually teaching CC and not CH. What we used to say is that like security will be weak without you. Okay, security will be weak without you. Then the next generation of Wi-Fi security, that is WPA3, with the aim to simplify Wi-Fi security, enable more robust authentication and deliver increased cryptographic strength. For higher sensitive data markets, WPA3 was proposed by Wi-Fi Alliance in June 2018. There was a very huge advertisement that from 2004, okay, see, from 2004, there were no change. And still we are using WPA2 and still we can break it. In 2018, it came. The advent of WPA3 remedies the protection against the flows of WPA2, such as dictionary attacks. For public networks such as coffee shop portals, WPA3 has a good security because it will automatically encrypt the connection without needing any credentials. So this is not even implemented because the connection, what they're actually planning is something which is not using credentials, which is using like cryptographic ciphers to understand the data. Like how when you're accessing a website, there is a certain certificate that is helping you to access it and encoding this information. Like that, they were planning it, but even now it's not implemented yet. Okay. Any questions for this Wi-Fi security protocols? I'll just share one link with everyone. Okay. Have I been pwned is a website. Okay. So just type your email address. Okay. And press pwned. You can see whether how good is your passwords, because if your password is weak, if you're using Canva, okay, I'm not mentioning my email address because again for security reasons. If we mention this email address here, so later back in the day when I was using Canva, so we always have this tendency to sign up using sign up with Google, right? So if you're doing like that, like use a separate Gmail account which is not linked to your mobile number or which is not linked to any of your email address. Use that for that if possible. Don't use it. I mean, if you're doing that, like don't use that on any other thing. So what happened was like Canva got hacked.
once Canva got hacked, the hackers, they took this information, like what are the user IDs, passwords, and they shared it in the dark market. So everybody, they're able to access the username and password. Then you had to consistently check like whether your email address is being compromised, whether your security is being compromised. If your email is compromised, like everything can be broken. The next thing is that renter was something that I was using back then to rent furniture in Bangalore. So what happened is like renter mojo got hacked. So once it got hacked, what happened? Like again, like using social engineering attack, like what I can get is like I can just get this person's email address. Once I get this person's email address, I can just see from where if its data is breached or not. If it's breached, I can buy it from some other place. I'm not telling you how, but if you want, you can check your passwords. Okay, just type your email address and see. Okay, not to run. Okay, just check and see. If it's spawned, just comment. But don't mention your email address. Okay. Now we'll do the practicals for wireless. To do the lab, I'm taking one switch, one PC, one server, no, one wireless LAN controller. If you are doing these practicals, just make sure you are using the same wireless LAN controller. I was trying from different other things. Apart from 3504, all other is not working. You will see WLC, but it won't work. 2504, that will also work. This seems to be little stable. Okay. Now you need access points. Again, go to end device. Once you go to end device, you can take 2 tablets for connecting it wirelessly. Now go to wireless again. Take one access point. Okay. Network devices, switches, wireless devices. Come here. Yeah, lightweight access points. But this lightweight access points needs power adapter. Now we are going to configure this. Okay, to give the IP address to the end devices, I'm using a DHCP server just to give you an overview about how the DHCP server works. So my network is 192.168.10.0/10.0 and the gateway is no need, same network. Services DHCP 10.0. Okay, to make on it, add it. Okay, just save it. Now let's see if I'm getting IP address. Go to desktop, ipconfig, DHCP. I got this IP address. Okay, brilliant. Now I will configure the wireless LAN controller. Go to config, address management, correct the IP address. Okay, subnet mask is 255.255.255.0. I corrected it. Previously it was wrong. Now I'm mentioning 10. Now mention that. Now what I need to do is I need to configure the wireless LAN controller. So if I want to configure this, I will have to actually log into the wireless LAN controller. But how can I do that? If I want to do that, what I would need is I need to log into that particular IP. So how do I do that? Go to the web browser, type the URL, that is 192.168.10.10. Now it will immediately give you a connection. It will take some time. If it's not working, I'll fast forward it. Check this address again. Config 10.10 255.255.255.0. Yeah. Now you're actually logged in. Now you have to create a profile. You will have to create a profile. The profile is, okay, I'm creating admin. The most secured username, password is Cisco. Okay. Capital letter C, ISCO at 123. Cap C, ISCO at 123. Start. Okay. Now you can actually set up the system. So system name, I'm going to give a name which is not very important, that I'm giving as CCNA. Now it's the time zone is already given to you. Who is managing this IP address? A DHCP server is who's managing it? WLC is managing it. So 192.168.10.10. Subnet mask is 255.255.255.0. Now the diff, okay, 255.255.255.0, and the default gateway is 192.168.10.1. That is a DHCP server. Now next, name of the network, I'm making this as Pluto. Here I'm giving the password. My password is 9876543321. Okay. Again mentioning the password 9876543321. Next. Okay. So you can see the details. V2 WPA2 personnel. We have given a password. This is to the manager VLAN. We are going to apply it. System will reboot. This will take so much time. Now what I am doing is I'm just fast forwarding this. Now I am actually connected to the network. So what I do, I will just turn on my access point. For that, I'll take the adapter, connect it. Once I connect the adapter, it should be able to power on. Okay, now it's connected. Now you can see the device is powered on. So how do I make sure it's working? So I'll see if I'm getting IP address. And so I have get the IP address. So what is the IP address that I've given for the management device? Wireless LAN controller. Now I have received this IP address 192.168.10.3 and 192.168.10.4. Okay. Now I need to connect these devices wirelessly. So how do I do that? Go to desktop. You don't have to do the IP config. It will be automatically given. So I am selecting wireless. Here in wireless, WPA2 PSK. I am mentioning the password. Password is 9876543321. Okay, and the SSID name is Pluto. Now let's see if it's connecting. If it's not, we'll have to work. PLGPO 9876543321. Enter. You can see two devices, they're actually connected. Okay, so don't look, because in Packet Tracer, this is just, since this is a logical topology, you might not get connected to the same device. Okay, even if you connect it here, it won't get connected because it's a logical topology. Like once if you press real time mode, okay, no, if you press the physical view, you can see it is, I mean, you won't be able to understand this. I mean, there's a huge data, even I don't understand that. So based on that only, it will be actually connected. So going to the real time mode, logical. Okay. So how to make sure that the other access point is working? Just go to the switch or power off the device. Okay. If you power off the device, I'm taking this back. You can see the Wi-Fi is disconnected. It is actually connecting to here. And even if you connect the device back, this might be still connected to that particular segment only. Okay, that is all about wireless. Any questions, any doubts, please shoot. Do you guys understood how we do this? Okay. If yes, that's for today. We will. Hi guys, welcome to today's session. Hope you all are doing good. Okay. In today's session, we are going to discuss about something. Hello. Okay. In today's session, we are going to discuss something that is known as IPv6. What is IPv6? Nothing but IP version 6. There are two major versions of IP addresses that we are using. One is IP version 4 and one is IP version 6. The reason which we started using IP version 6 is because you already know we are already run out of IPv4 address. We don't have any more global IPv4 address to assign. Okay, so we need a new IP addressing because like the more number of people are there who wants to access internet line, they need to get the resources, right? So we need a different set of identifiers. So IP version 6 came. So if you look at the request for commands like IP version 5, IP version 6, and IP, different version of IPs have came, but practically none of them seems feasible. So the only thing that could become feasible was IP version 6. So like whenever a new version is coming, like I told in before, right? Like there will be the report will be submitted to the request for comments. Like once they read to the request for comments, like they'll be doing their own trials. Like after that, only one protocol will come into the picture. Like that, after IP version 4, the most effective IP address formatting that we have seen is IP version 6. Okay, so what is the main difference between IP version 6 and IP version 4? Okay, what is the main difference is that more number of IP address. That is a major difference. In IP version 4, what was the maximum number of IP address you could have? You could have maximum up to 2 to the power of 32 number of IP address. That's around like 4 billion something. So currently like we have like around 7 million people, like which won't be sufficient for all the people in the world. Okay, and all the people like even they are actually using more than like 2 or 3 devices for different purposes. So they will be needing like multiple IP address, right? So coming here, okay, what is an IP version address? IPv4 address is an address which is written in binary. It have 4 octates. Each octate have 1 is 8 bit. 1 octet is how many bit? 1 octet is 8 bits. Is 8 bits, and it is separated by a dot. Then each octet is actually ranging from 0 to 255. Each octet is actually ranging from 0 to 255, and the maximum number of IP address that you can have is 2 to the power of 32. This is the maximum potential like we are talking about, and this is the maximum potential that actually we are talking about for what? An IP version 4 address. Okay. Now, when coming to IP version 6 address, the major difference is that here we have hex state. Each hex state is actually 16 bits. Okay, so if you look here in IP version 4, like we have like 32-bit numbers. In IP version 6, we have 128-bit addressing. Okay, so how many bits are there? Like 32 plus 32 it's 64. 64 plus 64 it's going to be 128, right? So thrice of what like we used to have with IP version 4, like we have for IP version 6. In IP version 4, like we told, like we have octet concept. Now here we have hex state concepts. So each octet is how many bits? Each octet is actually 8 bits. So here one hex state is actually 16 bits. Okay, so after one hex state, we'll be having the second hex state. Like that, 1, 2, 3, 4, 5, 6, 7, 8 hex states will be there. So adding this 8 hex states, you will be getting how many bits? Like 128 bits you will be getting. Okay. And IP version 6, IP version 4, it is written in what format? It is written in binary, where IP version 6, it's actually written in hexadecimal. Okay. So let's take a moment to discuss hexadecimal. Anybody speaking? Okay, let's take a moment to discuss hexadecimal. I hope all of you guys already know what is hexadecimal. It's a different type of numbering system. But just in case if you don't know, in decimal, like we have numbers which is starting from 0 to 9, and the base of decimal is 10. In binary, how many numbers you have? You only have 0 to 1, and the base is 2. In hexadecimal, you have in hexadecimal, you have numbers which is starting from 0 to 9. After that, you will be having numbers from that are A, B, C, D, E, and F. So basically 0 to 9, then A to F. So the base is 15. Is the base for hexadecimal numbers. Okay. So we'll see how it is written. We'll see how it is written. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is represented as A, 11 is represented as B, 12 is represented as C, 13 is represented as D, 14 is represented as E, and 15 is represented as what? F. Okay, I made a mistake. The base is actually 16, not 15. Okay, corrected. The base of hexadecimal is 16, not 15. It's actually 16. Now, what base is, like all the numbers which are starting from 0 to 15, you have actually 16 digits. So the base of hexadecimal is always 16. Okay. Now, since it's written in hexadecimal, you will be seeing IP version 6 in the format like 2001, 0DB8, 000, 000, A111, B222, C333, ABCD. Okay, then where is this 128 bit? Like how is this 128 bit? How are you going to actually figure out? Each of this digit, it is actually consisting of 4 bits. Each of this bit, it is actually consisting of how many bits? It's actually consisting of 4 bits. Now, when an IP version 6 is converted into binary, so you will be converting each of these bits as 4 digits binary. Like let's take one IP version 6 address. Okay, now we'll take this address itself, 2000 0DB8 00010. So an IP version 6 address, it's actually written in which format? It is actually written in hexadecimal. Okay. So the next value is 0DB8. I hope next few updates are actually zeros. Yeah. 1, 2, 3, 4. 1, 2, 3, 4. 0. A111. Okay. A111. B222. You can see instead of this dot in IP version 6, we are using this double colon to separate it. Okay, hex state. So we are using this double colon to separate the hex states B111 and C3T.
triple T, and ABCD. ABCD. Okay. If I'm converting this value, first I will have to convert this 2. Okay. If I convert to what is the binary value, guys? If I convert to what would be the binary value? 0, 0, 1, 0. Yeah. 0, 0, 1, 0. 0 is again 0, 0, 0, 0. Again 0 is 0, 0, 0. Okay. And 1 is actually, okay, we will have to actually count it. Okay. 0, 0, 0, 0, 0, 1, 0. Then 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Now 0, 0, 0, 1. Okay. Now you will get 16 bits. Okay. Now the next hex state again 1, 2, 3, 4. Again, okay, what is D? What is the value of D? What is the value of D? We have discussed. A is 10, B is 12. What is the value? Okay, I mean, what is the decimal equivalent of that? D. What is the decimal equivalent of 13? No, yeah, I told the answer. Like it's 13. You're right. Okay. All other people who are attending, are you understanding this? Guys, please confirm. Okay. Now, yeah. So B is the value of B. You already got. It's actually 1101. Okay, 1101, and 8 is nothing but 1000. Okay, again 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. That hex state is completed. Moving to the next hex state. 1 2 3 4, 1 2 3 4, 1 2 3 4, and 1 2 3 4. Okay, and moving to A is 10. 10 is nothing but 8 plus 2. So 8 0 1 0. Okay. Yeah. 8 0 1 0. Then 1 is nothing but 0 0 0 1 0 0 0 1 0 0 0 1. And what would be the value of B? Okay, B is what? 10 11. Okay, so we will get V 8. Then 8 plus 4 is what? That is 12. We don't want that. 10 11. Okay, now 0 0 0 1 0 0 0 1 0 0 0 1. And what is the value of C, guys? 10 11 12. Okay, so 12, it's nothing but 1 1 0 0. Then D stands for 10 11 12 13. 13 is 1 1 0 1. Okay, 1 1 0 1 1 1 0 1. Then again A, that is nothing but 1 0 1 0. Then B is 11, so that is 1 0 1 1. C is, yeah, C is 1 1 0 0. Then D is A B C D 10 11 12 13. Okay, that is 1 1 0 1. Okay. Yeah. Okay. I'll give you one question. Okay. You don't have to do the complete one, but just finish few of it. Okay. I'm just giving few hex state. I am not asking you to complete the complete one. FE88. Yeah, no, you complete the entire one. FE88. ABCD. Then CEFF. AF7 6. 1 2 3 4. Then 1 2 3 4. 1, 2, 3, 4, 0, 0, 0, 0, 7. Complete this and give me the answer. If you have any questions, you can ask on this, doubts regarding this. Okay. The answers are mostly everybody's answers are right. Okay. Hope you got it. Moving to the next session, we are going to discuss IP version 6 shortening. This is very important because it's a 128-bit value, so you won't be able to remember this value. Okay, we'll take the same IP address before. Okay, and we'll try to shorten it. The next topic that we are learning is IP version 6. IP version 6 shortening. Okay, the first rule is that remove the starting zeros. Remove the starting zeros. If you remove the starting zeros, you will get 2001. If you remove the starting zero, you will get DB8. 000, it is 0000, it is 0 itself. Then 0000, again it's 0. Then A111, it will be exactly like that. So A111 slash B111 slash CDD slash ABCD. Okay, ABCD. Now, the second method to shorten this, once you finish this, you can move to the second step in the shortening process. Remove the repeating zeros and replace it with column. Okay, so if you do that, you will get 2001 DB8. There is 2 zeros which is repeating. I am replacing that with double colon. Then again A111 B222 and CDD and ABCD. Okay, but there's a catch to this. You can only apply this once. Why? We'll discuss the next question in that method. Okay, and tell you why that is the case. The next question, we are making a few changes. DB8 0 ABCD and 0 0 0 1 2 3 4 5 6 7 8. Okay, so we need to remove something. We'll be removing this value 2001. First hex date, second one, third one, fourth one, fifth, sixth, seventh, and 1. Okay, if I try to shorten this, okay, so what is the root? I can actually use 2001 double colon ABCD, then 0 0 0 1, or I can use it like 2001 0 0 ABCD double colon 1. Okay, why this is very important? The second point is very important. You can only apply this once. So you can see that like in here like 3 zeros are repeating at the same time. So it was better to replace shorten there, because like you can memorize like this many values. Like what is the actual value that we have reduced? Like this, it is actually reduced to 2001
0, comma 0 dot abcd double colon 1. It is shortened like this. Why this is very important? If you put in two places, like when they expand it, router or the end device, they will get confused that like where the zeros should be getting added. That is the main problem. So you can only apply this in one place. Okay, you can decide where you want to apply, but you can only apply this once. There are only two rules. First, remove the starting zeros. Once you remove the starting zeros, you can replace the repeating zeros with a double colon. Here you can see 2001 0 db8 0000 A111 B222 000 ABCD. So they removed 2001. The 0 is something which they are actually removing in the first place. 0 db8. Then this continuous 0, it is replaced with a double colon. A111 B222 and this 000 it is reduced to 0. Then ABCD. So the final answer you are getting like 2001 db8 double colon A111 B222 0 ABCD. Understood this? Any questions? This might sound a little confusing, but if you have any questions, please ask. It's very simple. Any questions? Yeah.
So can you repeat this again, especially the second one?
Okay. What I'm saying is that you can see zeros are repeating at two places, right? In the second hex state and third hex state also zeros are repeating, and you can see here also zeros are repeating, right? That is on the 5, 6 and 7th hex state. Okay, so either you can remove this continuous 0 with a double colon, but as mentioned here, you can only apply this once. So either you can shorten it like 2001 double colon ABCD 0001, or you can shorten it like 2001 0 dot 0 colon 0 colon ABCD double colon 1. So why I prefer this is because we can shorten it more compared to the previous address. Like we can shorten it to the more efficient way. So if you put if you shorten both the places, the end devices, when they are expanding, they will be getting confused. Okay, if you shorten on both places, like the address will look like something like this. Okay, 2001 double colon ABCD double colon 1. This is how it is going to be. So there is no subnet mask or no other information which is mentioned with this. So the end device is just looking, okay, first octet, second octet, third octet, and there are like, okay, 4 more, okay, 5 more hex states that has to be added. But there are double colons which are mentioned. Okay, so it might be like if it's 5, it might be 3. So one place it should be definitely 2. But the end devices, they are actually not understanding where to add the zeros. But if you look here, 2001 first hectare, second one, third one, fourth one, fifth one, sixth one. Looking at that, they understand that this continuous zeros are happening here. That is just two addresses. We just have to add there. If you look here also, first hex state, second one, third one, fourth one, and fifth one. So 5 plus 3 more hex states needed to be added. So they'll be adding 3 more zeros. Like when they expand it, this will become 2001 0. This is the first one. Second hex state, ABCD, and so first, second, third, and fourth is there, and one more hex state is there. That is 1. So total, how many hex states are there? 8 hex states. Now it's very clear that we need to add 3 more values there. That is the point.
Okay.
Okay, Rita, I didn't understand. It's not 2000. It's 20. Yeah, yeah, that's correct. This is not 2011. It's actually 2001. Okay, Isaac, your doubt is clear.
Yes, sir.
Okay. Now, once shortening is completed, the next process that we have is conversion of MAC address to link local address. So in every devices, you will see something like once you just open Packet Tracer, there is something, an IP version 6 link local address is also added to every device. So how is it added? Why is it added? We'll see how it is actually structured. So just take one PC. Even in your PC, you can actually see this. Okay, go to config fast Ethernet. You can see a link local address. This is actually an IP version 6 link local address. So this is by default which is present there. Okay. So how this address is actually, they have received this address. So this address is actually something which they have received from the MAC address. They converted this MAC address to a link local address. So in the syllabus, like we have to actually learn how this is converted from MAC address to link local address. Here they're saying that okay, we'll take this MAC address itself. We'll take this MAC address which is mentioned here. Okay, we will not look at the link local address for a while. This is the MAC address which is okay. This is the MAC address, guys. Okay. The first criteria they are mentioning is that add FFFE in the middle of the MAC address. So the middle of the MAC address is nothing but this place. Like there are okay. So the middle of this MAC address is nothing but it's a 48-bit address. So we have to actually make this address to a 128-bit address. Like so, how we are actually doing that? We are actually adding an. So you can see that there are only 3 hex states. Like we need like 5 hex states, 8 hex states, right? So FFFE. They're asking to add an FFFE in the middle of it. Okay, right? FFFE in the middle of the MAC address. Now asking to inverse the 7th bit and convert to decimal. Okay, so the 7th bit is okay. The first bit is actually consisting of how many numbers, guys? The first bit is actually consisting of 4 bits. The second bit is actually consisting of how many bits? Again 4 bits. So we are going to expand the second bit because the 7th bit is actually coming in the second digit. So it's 0, 0, 0, 0. Okay. Inverse the 7th bit means this is the 5th bit, 6th, 7th, and 8th. So I'm inversing this to 1. Okay. So I have inversed the I have inversed the 7th bit. Once I inverse the 7th bit, add an FFFE and convert into decimal. Okay. If I convert this value, what would be the value? 0, 0, 1, 0. Any idea? The value is going to be 0, yeah, 0 to 09. 0 to 09. Okay. Then we'll write the other value 7C FFFE 27.161637. Okay. Now what we need to do? We need to add an FE80 in the starting of an address. If you see this FE80, immediately you can understand that this is a link local address. FE80 0209 7 C FFFE 27.1637. Okay. Now after this, what is it mentioned? Remove the dots and group them. Remove the dots and group them. Grouping means okay. After this, we'll have to add one colon. Then after this value, we'll have to add one colon. Then 7C FF colon FE27. There also after that we'll have to mention one colon. Okay, FE80 1 1 2 3 4 5. Okay, now what it is asking is add a colon after the first segment also.
So we have added one more colon in the first segment and removing the starting 0 to shorten this address. And we'll see if we have done this correct. We'll just go copy paste this address and see. Okay, this is the link local address which is given. Okay, FE80 double colon 209-7C-FF-FE271637. This is the link local address. Any questions how we did this? Any doubts, any confusion? We'll just repeat the process. First, add an FFFE in the middle of the address. So this is where we added the FFFE in the middle of the address. Then we inverse the 7th bit. The 7th bit is the green bit. So I inverse that bit and convert it back to decimal. Okay, once I convert it back, this is the value. Here, what I did was actually group the first. I added a colon in between, like all the 4 digits. We removed and grouped them with a colon. Then after that, add a colon in front of FE. After FE is 0, like we add one more colon. Then remove that starting 0. That 0 to 9 was there, right? 0 to 09 was there. We removed that 0. Then we got 209. Then rest all the values like we have written, just like that. Okay, guys, any doubts, any confusion?
How do you select the 7th bit?
Okay, in the beginning we discussed in an IP version 6 address or in hexadecimal, each digit is how many bits? What is the maximum value that we can have in hexadecimal? 15, right? Guys, who asked the question? The maximum value that you can have in an IP version that is 15. That is like 1, 2, 3, 4. That means each bit is having how many digits? The maximum digits that we can have in one digit is actually 4 bits. So in the first, if you expand this, you will be getting 0, 0, 0. In the second bit, if you're expanding, you will be getting 0, 0, 0. So for the second bit is actually 5, 6, 7, 8. That is why I expanded the second digit. So that's where the 7th bit is coming. So then I inverse the 7th bit and I made that into decimal. Okay, that is why 0, 2. Okay, 0, 0, 1, 0 is nothing but 2. 0, 2, 0, 9. Is that clear?
Yes, it's clear, John.
Okay. Now, do you want to practice one or we'll move ahead?
We'll practice one more.
Okay, then I'll give you one question. Okay. Convert this into link local address. Convert this MAC address into link local address. You know, like how you got 6-4? Is it 6-9? Rita, you have a small mistake. It's where did you add FFFE? It's FE80 double colon 203 E4 FF colon FE FE yeah FE 5E and B269. E4 269. This answer is right. Yeah. Yes, that's it. You should add FFFE in the middle of the address. Okay.
So John, we can also hear double colon, right?
Yeah, we need to use.
Okay.
Okay. First, we need to find the middle of the address. That is 0003. That will be exactly like that for a while. Then E4. This is where the split is actually happening. Where what we are adding? FF.
FE.
FE. Right? FFFE. Then 5E. 5E. Then
B269.
dot B269. After that, we have to inverse the bit. That would be like 0202 03. Yeah, 0203. Then
E4.
Yeah, we'll copy paste. This is the value. After that, what we have to do, we have to add FE80 in the starting. FE80. FE80. Then
group.
We have to add this values. Then we'll group it. Right. FE80 colon. Remove the dots again colon. E4FF colon. FE5E colon, and after we have done everything, we'll add one double colon and remove the starting 0. Once you remove that, you will be getting same value. That's regarding. There are a few more topics we need to discuss. IP version 6 routing. So since we don't have time today, I'll show you something else. Okay, how to assign IP addresses in devices. Okay, so for example, when you might be purchasing an IP address, you will be getting IP address like 2001 double colon 1. Okay, so if you expand this, how you will be getting the IP address? If you expand this value, how you can get IP address? Okay, so here also you will be getting like this slash notation will be there, so which is indicating like the network bits and the host bits. Okay, so here if you are just getting 2001 double colon slash 64 is your value. Okay, 64 means if you expand this value, what you would get is, if you expand this value, rest all is 0, right? After 2000, like when we expand, it is easy for us to understand that next 7 hex state, it is 0, right? Is any doubt? When we are expanding this 2001 double colon slash 64, which is indicating that when we expand this 2001 0 0 0 0 0 0 0 1 2 3 4 5 6 7, right, and slash 64, which is indicating nothing but the first hex state is 16-bit. 16 plus 16 32, 32 plus 16 48, 48 plus 16, 48 plus 16 is what? 64, no? So this much portion is actually representing our network portion, and rest all is actually representing our host portion. Okay, so when we are assigning IP address, if we will be writing simply like 2001 double colon 1, which is indicating nothing but 2001 double colon 1. Okay, how we can assign to devices? You can just assign to packet tracer for now. Go to config, desktop, IP config, go to IP version 6 address configuration 2001 double colon 1. You have assigned the IP address and just mention the network portion, that is /64. When you're purchasing it from ISP, you will be getting a value that is /48. You'll be using /64 to and /64 to subnet, then you will be using that value. Okay, nothing complicated. It's much more simpler than the IP version 6 subnetting. Any questions, any doubts? We are not discussing any more topics. All your doubts we will discuss now. Okay, it is showing us IP version 6 address is invalid. Let's see what happened here or here. 2001 double colon 1, that was address I have given, and 64. Now there are no issues. How to check? We will just use a ping test. Okay, go to desktop, IP config, we'll give 2001 double colon 2 and again /64. We'll see if it's reachable or not. Now once we connected, you just go to command prompt and ping the device. Ping 2001 double colon. Yeah, this is actually 2. The other device is actually 1. I mean, if you ping 2, that is the same. Okay, that is again the same device. In the same device only, I think we have given that address. Desktop. Yeah, this is where only we have configured that. But the IP address is working. You have seen that it's reachable. The communication is proper. Okay, understood, guys? Guys, any questions? Network address, you will be using the / mask, which is used to understand the network address. For example, if somebody is saying, okay, you are getting an IP address like 2001 0 ABCD 0 1. Okay, no, 1 1 1. Again 0 0 0 0 0 0 0 0 0 8. Okay, /64. How to find the network address? Network address is simple. Just find out what is the network portion. Okay, till where the network portion is. So 16 plus 16, 32, 32, 48, and 64. So the network address is nothing but 2001 0 ABC 111 double colon /64. Host portions, every bits are 0, right? When we are writing the network portion. Rita, is it clear? Any other questions?
Then for this MAC address converting, is it will be there in real scenario?
In exam, it will be there.
Okay.
I have seen people are asking that in exams.
For IPv6 /value is starting from?
IP version 6 starting value, we will discuss that portion. Like we have to discuss that, we will discuss that in the next class, not today, because like that's a topic we have to discuss. Okay.
Yeah.
Any other questions? If not, first host and second host IP. Okay, why don't you tell me that? You can easily do that. How? Okay, since we find out the network, if we are, okay, the complete network, when you're expanding, you'll be getting 2001 0, ABC, 111, then 0, 0, 0, 0. This is a network, right? So the first address is going to be 01. The second address it's going to be 02. Clear? Okay.
So the IPv4 will be starting from 0 to 255, right?
IP version 4.
Yes.
Yeah.
For 6, it is also same.
Why IP version 6 address is actually starting from 02 to 55?
No. If it is a range we have for IPv4.
That is a range, right? Because the maximum value that you can have in an octet is what? The maximum value that you can have in an octet is 255, because if you are writing like all ones. But here, what would be the value in one hex state? That is all F. This is a large value, right?
Okay.
This is all F. That is actually the maximum value that you can have in octet is 15, 15, 15, 15. So 0 to this many values you'll be getting in one octet. And there are no classes. I mean, I already answered your previous question. There are no classes like class A, B, C, D. There are no classes. We only use network mask and network mask, that is like /64, 32, 48 to identify what would be the value. Clear now?
Yeah, clear.
Okay. Hi guys. Okay. Just an update on the topics that we are actually discussing. Today is 18th. Okay. By 22nd, hopefully we'll be finishing our topic. Again, we will be extending our classes till 27 if required. Okay. So the topics that we have to cover, hopefully we'll be completing it by 22nd. And if you have any other concerns, we'll be extending this till 27th. So after that, how many of you, if you guys have enrolled for CCNP, you can check with Gaurav or any other people when it's the next batch. If you're doing this other courses like Polo or any some courses, you can check with them when are the dates available after 27th. Okay. Just giving an update like when the course is going to end. Okay. Do you guys have any other special requirements from your side, okay, during this 3 days that we should be covering apart from the actual syllabus? Do you guys have any special requirements that you would like to incorporate here in this? Any other suggestions? Anything? What is it, Rahul? BGP we cannot cover. BGP it will. I mean, we can do the introduction like even packet tracer. We can only do eBGP configuration. We can just do a basic demonstration what is BGP. We may not be able to cover because happening in the CCNP. But I'll just give an overview about BGP, but not in depth. OSPF multi-area also we discussed, Rahul, like OSPF multi-area configuration also discussed. In the current scenarios, like we have gone like a little far ahead from there, like we discussed the multi-area concept in the syllabus, like we already covered that OSPF multi-area, like how to configure OSPF multi-area. I mean, what I mean in general is like if you guys, a VPN there is in the syllabus, Isaac, don't worry, VPN we are covering. This Wednesday or Thursday, we are actually covering VPN, so no worries. VPN, Cisco actually developed the topic for VPN. Yeah, there will be, depending on which you are choosing, Encore or NRC, you can actually know that. Did you enroll, Ronit, or do you plan to enroll? Like, if you are okay, which course you enroll, then I will update you.
I already enrolled for CCNP and Palo Alto.
In CCNP syllabus, actually, it is mentioned, but just have to check like what is the specialization that you have taken.
Hi, John.
Yeah.
Actually, I have a question apart from this syllabus. Actually, I want to go in the fully security.
Mm.
So I have enrolled for master classes
Mm.
for 1 year, but I'm in confusion that a CCNP data center is better or CCNP security. I'll go.
You're throwing the hard questions. Okay. Rahul, the thing is, which one you like the most? Okay, so do you remember the time like when you were like finishing your PUC? That's the time that you're actually taking big decisions in your life, right? Like which stream I should be choosing, like science, commerce, or
Yeah.
computer science or biology science. And people will say that okay, go for me. If you study nursing, like you will get PR abroad, like study nursing. But if you are too bad in biology, and if you don't like biology, and if you hate the subject, like you can't be happy in that particular job, you might be getting a PR. Like so many people are moving across the country. Like if you done nursing also, but how many people like that particular job? That's a different question, right? Like where is your interest lying? And somebody who is hating the circuit board, if they are doing electrical engineering, they are also gonna hate that thing. But if you are solely relying on the opportunity perspective, data center has opportunities. At the same time, security also has opportunities. So I have seen people who have done CCI enterprise, then CCI data center comes into security. I mean, today also I was talking to a dual CCI person, like for another opportunities like we were discussing today morning. Okay. So he told me like he's coming from an electrical background. He was working with 5G, 4Gs. Then he was moving around like different sectors. Then like first he started with CCI enterprise, then he moved to CCI data center. Then later, like after 2 or 4 years, like he understood that that was not his true passion. Like he jumped into CCI security. So CCI security is like every people like who go to the mechanical engineering, they used to have this trend, right? Okay, I will be a mechanical engineer. So security always has the fashion, like it will never gets out of the trend, even the data center. Because why data center is very important? The main fact is that cloud is coming, like cloud is getting more active. When cloud is getting more active, what happens is so many data centers should be there, right? So the opportunities will be there if you're actually focusing on that, but you need experience for like getting into data center. Like you need to get like some other kind of experience, then you have to migrate, or you will have to completely focus on your CCI data center. First, for that also, like enterprise is gonna be the backbone of data center. I mean, if you don't have any particular experience in any other sector, I would prefer you start with security rather than jumping into data center. But if you already are a person who is aware about how enterprise network works, then if you're moving into data center, then that works for you. If you're already working in production, who are actually familiar with how the advanced routing and switching goes. I'm not talking about the one that we are actually doing over here. I mean, this thing, the entire thing, you will not even remember like when you do your CCI thing, because this will be in your muscle memory. Like so many other things you'll be prioritizing, like over the metric cost and other things. At that time, yeah. So the in nutshell, what I'm saying is that as a fresher, if you're going, that won't be an ideal track. Go for enterprise, then data center. That is my requirement. At currently in India, the most demanded CCI or the most demanded certification in terms of CCI, that is enterprise today. After enterprise is data center, then comes security. But security has always the market because like there are vulnerabilities, right? So that is answer, Rahul.
Yes.
Okay.
Actually, I'll if I'll go for the in network field. So basically, I'll prefer as a fresher because right now whatever I'm doing in the hospitality sector, that experience won't be count.
Yeah, you will be counted as a fresher. But then what I would recommend is you're doing this master's course. I hope like there is Palo Alto which is included with it. Learn Palo Alto once you finish. Once you learn Palo Alto, learn this overswap, this top 10 vulnerabilities. That will be a short question for security. Then understand the different types of VPN like SSL VPN, TLS VPN, SSL version 2. I can actually share some materials. If any of you guys who are actually planning to give a security role interview, just reach me out. I have some good resources that I will be able to share with you. I mean, like that is like the Fortinet expert interview questions. So if anybody over here who is actually planning for security profile, like network security roles, like if you actually refer that one PDF, I mean that would be really good. Because if security, they will also ask VPN. I mean, it's not just firewall that they are asking. Like they will ask different types of domain, like IPsec protocols, tunnel mode, transport mode, all those they will ask. So you can actually refer one PDF I can share you. Okay. When you are going for your interviews, like I mean, even after you finish the course, please don't hesitate to reach out. You can share your JD, like so I can just guide you if you want, like what are the things that you need to prepare if you're just giving an interview. Okay.
Yeah, actually, one day I was browsing the Palo Alto carrier site, and they had an opening for the security level. I don't know. I took the screenshot and now.
Okay. Again, just not to discourage you. Okay. Even I applied Palo Alto, but I got rejected. I mean, my in resume it never even got shortlisted.
Any
Okay.
particular reason?
Yeah, particular reason like particular reason I didn't had experience in security. I didn't have like 4 or 5 years of experience in security. Okay, so I'm teaching enterprise, right?
Yeah.
I'm teaching enterprise. I don't have experience in security. I mean, just giving a heads up on how things are working. But if you try Sophos, like they are little more open. I mean, there you can actually reach out. I mean, if you get any references in Sophos, like that would be an ideal thing to start with. Whenever you are seeing any job profiles, okay, I'll tell you like few companies that you should, all of you guys, after finishing this, can start reaching out, connecting this, building your LinkedIn network. That is a good start. Find out the companies that are actually suitable for you. Like some companies which I like very interesting. One is Sophos because they work completely remote. The main advantage is that you don't have to go to office, even if there. I mean, like the rotation shift. Like if you're working in knock or tack, it's hectic. On the top of that, if you're going to office like on shifts, it's going to ruin your health also. Again, Sophos work culture wise, it's really good. Akama is really good. If you have experience, only then they will hire. If you should be having at least 2 years of experience in production, then only they are going to hire. But Sophos is not like that. Sophos, they are very open. Accenture, your resume might not get shortlisted. Why? Because of the internal politics. Because they are actually looking for some other vendors for this hiring process. So, but if you get I mean, even the manager, even the senior managers, like when they refer, then also like your profile is not getting noticed in Accenture. I mean, I'm not talking about any, but I mean in general, in specific, like yeah, I'm talking about in general, like nobody's profile is actually getting shortlisted in Accenture. But if you manage to get there, that would be good. Accenture, Sophos, then Sophos is a good place. Then yeah, Akamai. So when you are actually seeing any of these opportunities over there, like Move8 also, but Move8 I think they are only operating in Chennai, and Pune also they have a yeah, they have a branch in Pune also. So Move8 is actually hiring for good roles. You will get good experience from there. So reach out to some people who are already working in there. Like just type Move8, then you will see a lot of people like who will be working there. Then send connection request of the same people who are actually working in that specific. For example, with Stack, send connection request to the people who are working in Tag. Then politely build connection, like while the time that you're actually studying your CCNP, politely build connection saying that, hey, I'm actually doing Palo Alto course security, I'm planning to join, ask this thing, like is there any particular tip that you can give, and how is your company's hiring process? So by the time that you actually finish your Palo Alto course, they will be able to give you a reference. So that will actually help you in the terms of screening your profile. Okay.
Yeah, actually, here I said one job profile in the group. Can you see it, please?
We will discuss this thing after the session because there are other people also. No, let's not waste their time.
Okay.
Because if it's not something which is informative to them, we are. It's like we are not respecting their time, right? So that would be a problem. So why we discuss so far is because we started this. Okay. Yeah, you will get certificate after the course. Okay, but for that you will have to email me the works that you have actually done. Then we'll be redirecting to the certificates. Okay. I hope all of you guys have saved your lab files. I asked you to save it back then.
right? My interview is going on security as network engineer. Okay. In the same CCNA folder, I will upload that files. Okay. Guys, in the last class, okay, we were discussing about IPv6 and IPv4 address. And I hope so many of you guys didn't attend that session because like we had very less head count in that session in the last class. Okay, so yeah, so we had very less head count. So I'm just summarizing what we were discussing is that in IPv4, it's a 32-bit number. We have 4 octates. It is separated by a dot. And the total number of IP address that you can have is 2 to the power of 32. Where in IPv6, okay, in IPv6, how many number of bits we have, guys? Anybody who listened to the class, do you guys remember? How many number of bits? Yeah, in IPv6. Yeah, yeah, good one, Isaac. Yeah, IPv6. Someone else also answered. I didn't catch your name, sorry. I think Fatima or Dileshwari.
128.
Yeah, 128 bit. Okay, IPv6 has 128 bit. Instead of octate, what we have in IPv6? Hexstate. Okay. How many bits are there in one hexstate, guys?
4.
Bits.
8.
16 bits. And it is separated by a colon. Okay. And how many hexstates are there? We have 8 hexstates. 8 hexstates. Okay. We have in IPv6, it's a 128-bit number. We have hexstate concept. It is separated by a colon. In the last class, we also discussed IP version 6 shortening, and we also discussed link local address. Then we also discussed something else. First thing was IP version 6. To expand an IP version 6. Then we discussed IP version 6 shortening. Then we started with subnetting by the time some of you guys actually left. Okay, so starting with that, okay, there is this IP address that is, this is an IPv6 IP address that is 2001 0db8 0db8 slash, okay, no, 0db8 1234 1234 1234 FFF CCC ABCD. Okay. First hexstate, second, third, fourth, fifth, sixth, seventh, eight. Okay. Slash 64. Okay. Find the network address. Okay. How to find the network address? Just find the 64 bits. Here, how many bits are there for the network? We are using this subnet mask value, right? Like slash 64 representing how many bits? 64, guys. 64, right? Any people who have any confusion on that? What is slash 64 representing? It's representing 64 network bits. Any confusion, guys?
No.
Okay. Which means 2001, how many bits we have? In one hexstate, how many bits are there? 16. So 16 plus, okay, 0 db8, if we shorten, we get db8, right? Both are same. So 16 plus 16, 32, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Then again, we have 1, 2, 3, 4. So 16 plus 16, 32, 64, double colon, slash 64, right? This is the network address. Any confusion, guys? Anyone?
No.
Okay. Now, 2001 double colon slash 64. Find out what the network address and the first valid IP address. This is the network address. You don't have to find it. Find out the first valid IP address.
$2001 double color.
Okay, 1 second.
1
2001 1, 2, 3, 4.
column.
Then
Double column.
it's 2001 0 0 0. Okay, 0 0 0 double colon 1. Right? And the second one is second one is 2. And can you tell me what is the last valid IP address or the broadcast address? 2001 0 to 0 0 0 double colon F F F F. Any questions? Yeah, 2001. Okay, Aju, there is a difference, right? Like 2001 0 0 0. There is a /64 also. Okay, that is indicating the network bit. Okay, this is the broadcast ID. This is the broadcast ID. And what would be the last valid IP address? Last valid IP address. Exactly. 2001 0 0 0 FF FFF E. Okay. Guys, anybody have any doubts or want any explanation on this? Please ask, or else we are starting with the practicals. Okay. This is a summarized version. If you don't attend, you still have to watch that video, then only you will understand. Okay. The first thing that we were discussing in the previous session was 2001 0 dB8 0 dB8 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, how many hex states are here right now? 1 2 3 4 5 6 7 and A B C D. Okay, just to give you an idea, hexadecimal is the numbering system that we are using in IPv6, starting from 0 to 9 and it's ending at 16. So 10 is actually represented as A, 11 is actually represented as B, 12 is actually represented as C, 13 is actually represented as D, 14 is actually represented as E, and 15 is actually represented as F. I hope there are no doubts here also, right? Rahul?
Yes.
And anyone else have any questions here? I'm just summarizing the previous session. I mean, a lot of people didn't attend. Anybody have any confusion on this, guys? If yes, please respond. If it's clear also, can you please confirm on the chat? Okay. Now, like we discussed in IPv6, we have 4 bits. Okay. Each single digit is consisting of 4 bits. Okay. Each single digit is actually consisting of 4 bits. Okay. So the 4 bits means the 2 single digit 2 will be expanded into 4 bits. The 0 will be expanded into 4 bits. The 0 again will be expanded into 4 bits. The 1 will be expanded into 4 bits. That is why we are actually getting 16 bits in one hex state. That is the reason why we are getting 16 bits in one hex state. Why 4 bits? Again, the reason is that the maximum value that you can write is 15. So when we are writing that in binary, we'll be using that particular thing to identify it. So if all values are 1, okay, 8 plus 4 plus 2 plus 1, 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. That is why we are making this as a 4-bit value for all of this. So when you expand this IP version 6 value, you will be getting, so 2, if you expand, what would be the value? Rahul? If you expand 2, what would be the value that you will be getting?
2 value.
0, 1, 0, 0, 1, 0. The 2 value.
Yeah.
If I expand, I will be getting, yeah, right one, Aju. When I expand 2, I will be getting 0, 0, 1, 0. Okay. Whenever you are expanding, always you have to expand in the terms of 4 bits. Then you are expanding 0, 0, 0, 1. Okay. That would be 1, 2, 3, 4, 1, 2, 3, 4. If you expand 1, you will be getting 0, 0, 0, 1. Any doubt?
No.
Okay. The next hex state, again it's starting with 0, 1, 2, 3, 4. Again D. What is D, guys? D is 13. 13 is 8 plus. Okay. 13 is first 18 plus 4 plus 1, right? Okay, 8 plus 4 plus 1. Okay, it's triple 1, right? 8 plus 4, 12, 12 plus 1, 13, and 0. Okay, B is, what is the value of B? That is 11, that is 8 plus 2 plus 1. So 8 plus 2 plus 1, you will be getting 11. Then 8, DB8, 8 stands for 1, 000. Any doubts?
No.
Okay, this is how we are doing the conversion. The same thing is actually repeating. Okay, again, since I discussed this in the previous session and to save time, I'm not repeating this again. Is that okay? You understood the process, right? Everyone?
Yes.
Any questions, guys? Any other questions on the same thing?
Clear, John.
Okay. Now, what we were discussing in the last session was, okay, we were discussing in the last session was IP version 6 shortening. Okay. So when you have an IP address 2001 0 BB8 1234 1234 and ABCD DBCD, okay, whatever. Then 1234 1234 1 2 3 4 5 6 7 and 8. That one is again A B C D. Okay, you have 1 2 3 4, first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. Okay, we are actually learning how to shorten one IPv6 address. Why we are actually shortening this address? The sole reason is that if this value is large, it will be so much trouble for us to remember these values. So what we do is we are going to shorten this value. So how we are actually going to shorten this value? We'll be doing something that is called removing the starting zeros. The first criteria is that remove the starting zeros. If I remove the starting zeros, I'll be getting 2001 DB8 0 0 0 DBCD 0 0 ABCD. This one is actually shorter than the previous value, and there is this value is actually not changing anything because like 0 0 0 we can write as 0 itself. Again 0 0 0 we can write as 0 itself because like the preceding zeros don't matter. That is why you ask your HR to increase the zeros after after the value, right? Like in the end, not in the front. So is there any doubt in the first step? This is the first step of IP version 6 shortening. Any questions?
John, why there is 30?
Yeah.
Okay,
I think
yeah.
mistake.
Yeah, that was my mistake. Okay.
Okay, ideally it should be 20. Okay, fine.
Okay. Now that I have removed the entire thing. 0 0 and okay, I am writing this value now. BBCD 0 0 then 1 2 3 4 5 6 1 2 3 4 5 6. Okay, previously there was, okay, I'll write this again one more time the entire question. 2001 1 2 3 4 1 2 3 4 1 2 3 4 BBCD 1 2 3 4 5 1 2 3 4 1 2 3 4 ABCD. Okay, now there are actually three zeros. Okay, 2001 1 2 3 4 5 6 7 8. Okay, only 7 hex states, right? So what was the first criteria, guys? Remove the
Starting
zeros. So 2001 0 0 0 DB CT and 1 2 3 no 1 and ABCD. Okay, no doubts right now, no? Like 1 2 3 4 5 6 7 8. Yeah, correctly. Okay, now the second criteria is that remove the
Okay, not remove.
Placing the zeros to columns repeated.
Replace the repeating zero with double colon. Okay. So when I repeat it, but there's a catch, not only apply this once. Only apply this once. This is very important because or else we will get errors. Okay. 2001, there are 3 zeros which is repeating. I am replacing this with a double colon, DB8, DB8, and I'm writing 0, 0, ABCD. Okay, 2001 DB8 00 ABCD. 2001 DB8 00 ABCD. So I can actually shorten like this, or I can actually shorten like this: 2001 0 0 0 0 0 0 DBCD double colon ABCD. The first one is more shorter, right? So I am preferring this one. So in your CCNA exam also they will ask like what is the most shortened version of this particular IP address. So like they will only ask the most shortened version. So we'll be seeing where we have more number of zeros. There we'll be replacing that with a double colon. The other one we will be ignoring. Okay, because we can only apply this thing once. What happens if we apply this twice? Okay, so what happens is 2001. Okay, so right now we are giving an IP address to a device. Okay, this device has no idea like what would be the value. Okay, so or I am giving a value 2001 double colon. Okay, double colon AB CD. Okay, double colon. This is a new value which you haven't seen. Double colon. Okay. Expand this. If somebody asks you to expand this, you will get confused, right? Guys, okay. If somebody asks you to expand this IP address, you will get actually confused. Why? Because of the fact that, okay, so you know that how many hex states are there in an IP address? IP version 6, 8 hex states are there. Right now, since it's mentioned as 2, okay, so there are like 2 places the shortening is happening. So you know that like, okay, there will be at least 2, here also at least 2. So 2 plus 2, that is 4, 4 plus 2, 6. Okay, but here you will actually see like how many number of, okay, you can either expand it like this, 2001. If I expand, like you don't know how many number of zeros you should be including it here. Okay, but if I only apply this once, okay, if I only apply this once, 2001 double colon ABCD. Okay, this is the value that they have given. While looking at this, you understood that they have given you 2 hex states. Then it would be 2001 0
Yeah.
0
0 0 0.
0. Okay, 1 2 3
Only
4
4.
5 6 6
Yeah, 6. Yeah, 7 8.
7 1 2 3 4 5 6 7 ABCD. We have 8 hex state, right? Like we are replacing the continuous zeros. So it is not saying that only 2 zeros can be replaced with a double colon or 3 zeros can be replaced with a double colon. So this is to shorten the maximum number of zeros. Now it's easier for you to understand. But if you apply this twice, the end device like the router or the PC that is using, they will actually get confused how to use this. Okay, so always prefer the most shortest one or compared to the larger one. Okay, so this is the criteria that you need when you are shortening an IP version 6 address. Any questions? Any questions that you want to ask? Okay. So that is the reason which we were saying that find out the network address of 2001. Okay. Okay. That this was the previous question that we were discussing, 2001. This might not be the same question. ABC. Okay. 2001 ABCD double colon. Okay. Double colon slash 64. Okay, find out the network address right now. Everyone, find out the network address of this device and put it in the chat. Okay, everyone, I need answers from you. Okay. because we were repeating this topic just because like I understood like half of you guys don't understand this and you guys were absent also. Please give the answers. Why we did rediscuss this topic is because a lot of people you didn't understand this, and I found that like if we discuss like a new topic, I'll be wasting your time. So I'm respecting your time, so you should be respecting it back also. Okay, Aju, I asked you to find out the network address. Okay, 234. Right, you're right. You're right. Vileshwari, you're right. Ram, you're right. Sagar. Sagar, there is, check it again. You made a mistake. Sagar. Okay, Junaid, Samir, right. Rahul, right. Isaac, right. Yep, Sagar, now it's right. Okay, guys, now find out the first IP address, last IP address, and broadcast IP address. First valid IP address, last valid IP address, and broadcast address. Actually, the first one is right. The first one is right. The last one and the broadcast IP. Aju, your last one is right. Last value. Aju, yours is right. Bileshwari, I have one doubt. Like, where do you get this FFFE BC 2001 ABCD and all? ABCD 00FFF. Okay. Okay. Yes, you made a mistake. 2001 ABCD 0.0:0. This is my network portion. This is my network portion. And my host portion is actually starting from here. Okay. That is again 0.0:0:0:0. This is my network address. Okay. When I expand my network address, the first valid IP address I'll be getting is 1. Okay. And the broadcast IP of this network I'll be getting as 1234, 1234, 1234, 1234. Okay, this would be my broadcast IP. And my last valid IP would be FFFFE. Clear, guys? Any questions? I know. Okay, see, the problem is again, like, how many network? What is a network bit? Okay, network we have how many hex state? We have 4 hex states, right? We have expanded that. That is why, I know is it clear like after looking at the example that I've discussed here? In IP version 6, 2000:/3, this is the publicly routable address, like the public IP address that we use in IPv4 address. This is the public IP address ranges that is actually happening in the IP version 6. FC00:7, this is routable in the LAN. This is the address that is routable in the LAN. Link local is FE80:10, which is identical to the link local address. In the last class, we also discussed how to find the link local address. For the people who didn't attend it, please refer to the last class video. Multicast IP address used in OSPF, EIGRP for multicast routing updates and all other information. We'll be using multicast range, that is FF00:8, and for anycast purposes we'll be using 2000:3. Okay, now we'll be discussing IPv6 routing. So to do that, we'll be using a static routing example. Okay, there is Packet Tracer, new. Okay, so here we have multiple networks. First one is 2001:/64. Here we have 2002:/64. 2003 double colon slash 64. Here we have 2004 double colon slash 64. Okay, we're going to do a static routing. So how to configure this? It's pretty much the same how we configure IP version 4 itself. Enable configure terminal interface F0/0. Now when we add IP address, we have to mention this is an IP version 6 address. IP version 6 addresses 2001 0 0 0 double colon 1 slash 64. Okay, so we mentioned this is the address that we are mentioning 2000 0 0 0, which is indicating the 64 bits. After we mention the 64 bits, we mention the host ID, that is 1, and we are pressing no shut exit. If you type do show IP interface query, you won't get reply because this is not IP, this is IP version 6. So whenever you are mentioning any commands that we are using for IP version 4, if you want to see the details of IP version 6, you have to specifically mention it. So once you mention that, you will be getting that values. Now going and configuring the second device. No, enable configure terminal interface F0/0 IP v6 is 2001 0 0 0 double colon 2 slash 64. IP version 6 address. Okay, then press no shut. Now that is there. Now we'll add the what? What? Router 1 I mentioned 2. Okay. No, this 2001 0 0 0 slash 1. This is 2001 0 0 0 slash 2. What is the problem, Ram?
Initially, you mentioned 2002, 2002.
That is in the loopback. These are the loopback IPs that I'm going to configure. Interface loopback 1 IP version 6 addresses 2002 0 0 0 double colon 1 slash 64 exit interface loopback 2 2003 then loopback 3. This is 4. Yeah, that is enough. Now exit show IP version 6 route. You can see the information is also present. Okay, now if you want to add route, either you can add route as exit. Okay, now configure terminal. Okay, first I'm going to reach out to 2002 network. Okay, so what is the command? IP version 6 routers. Okay, I have to type it. IP version 6 routers. The destination network is what? 2000 2002 0 0 0 double colon slash 64, right? And the next hop is 2001 0 0 0 0 slash double colon 2 slash. Okay, no, that is enough. Okay, now if you ping exit, ping 2002 double 0 0 0 double colon 1, you're getting the response. Why? Static route is implemented. Now I'm also going to configure one default route, IP version 6 route. Okay, for all the networks I'm mentioning double colon slash 0 /0 forward to 192 dot, not 192 dot, 2001 colon 0 colon 1. Okay, no, it's 2. The next stop is 2. Now exit. In 2003, you're getting the response. In 2004 also, you're getting the response. Any questions? Anything that you want to clarify for today's session? Please ask. Yeah. Then that's it. Now, Rahul, I've seen your job posting that you posted. Again, the problem with that is, they are asking experience, 2+ years experience in SEIM. SEIM tools, you need to have experience. That is a cybersecurity track. That is not a networking track. So you will have to learn that parallel if you are looking for that role. But I won't recommend learning random tools just like that, because SEIM is a very good tool. I mean, like just for an interview, like focus on the main core skills in security, like focus on firewalls, VPN. That would be a strong start rather than learning all other things. Because like once you finish your learning process, that opportunity might not be there, right? So that is the problem. Like for L2 analyst also, they're asking like threat hunting, L1 analytics requirement is +2+ years in cybersecurity, hands-on SEIM experience and incident response skills. So we currently don't possess those skills. That is a problem.
Okay.
And I also got a message from Ram. Okay. If you have interest in security, first finish your Palo Alto. I'll also upload one firewalls interview prep question. That would be helpful when you're preparing. This trial will be accessible throughout your lifetime, so you can refer that. Okay.
Actually, John, I have 3 firewalls in my course. So, any major difference between 3?
You might have ASA, FTD, then Palo Alto or Checkpoint.
Palo Alto, Fortinet, and Checkpoint.
Palo Alto, Fortinet, and Checkpoint. Okay, if you learn those 3 things, I mean, you will be the most demanded man in the market then.
Yeah. So I don't know when it will finish. It will almost 1 year.
It will take, almost 1 year. So Palo Alto, it will take 50 hours of training, right? 50 or 40 hours of training for Palo Alto. FTD the same. And 80 hours. So it will take like 2 months, 2.5 months, maybe. Or if you're lucky, it's 2
CCNP
months.
security, how many months?
CCNP, do they give a track of CCNP security?
Sorry, John?
Is there a track of CCNP security here?
In my course, it's there, I think.
Okay, maybe it's firewalls I mentioned. CCNP security, as in like there are no courses. S-core is there, like security core. See, not. Yeah, maybe they're talking about
CCNP,
S-core.
sorry, CCNP and core.
N-core, okay. N-core is enterprise, not security. They provide N-core, okay. N-core is there, N-core is another 2 months. But parallel, if it's possible, like start firewall, because if you understood CCNA, I would recommend you to start with firewalls directly if you understood CCNA. I mean, like, because you are not going into enterprise track, you are completely going to the security track. So the CCNP knowledge won't be matter. Like, there is a close friend of mine, like, who is a CCI, who is working for Amazon right now, who, I mean, like, he gone through all the modules, but I mean, like, even like when we are talking on a closed talks, like he's saying that, I mean, you just need to have like CCNA knowledge, because like you are working as a security engineer, not as an enterprise engineer. Like, you just need to know like the basic OSPF commands or the HLP commands and how the basic switching works, because you are not anyway, you are not doing LAN, VLANs, VXLANs, nothing, VTP, DTP, nothing you are doing over there. You are actually focusing on security and security firewalls like DNAC, Palo Alto, then I mean in CCI, it's basically like FTD, ASA, all other tracks, but you're not actually focusing on any other things apart from that. So you can start with because like you can have batches in 8 p.m. and 10 p.m. right? So you can actually have two batches the same day. So the same time you're looking for enterprise, just attend the class. But if you're focusing on security, focus on security part.
Yeah, but the problem is, I think they have classes on weekend mostly for the. So weekend I cannot attend in the morning classes.
Morning classes, weekend you cannot. Okay, 1 second.
Because weekend I'm working. I don't have off on weekend.
Okay. It might be a problem. Yeah, I mean, you should figure out a way. Okay. Sagar, you just have to expand it into 4 bits. Okay. Sagar, your question is 2001 0 DB8 ABCD converting binary. Please explain once. Okay. So where is that we explained it? Okay. 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 Sagar, you tell me like if you convert to what would be the value that we would be getting. Please give me the values. If you are giving me the values, I will explain. Convert 2 into binary and give me the values. Give me the answers in the chat and make it quick.
No, then actually we have converted to 001. Meanwhile, we have written 0010, right? For 2.
Yeah. 0010. Okay.
Yeah.
Then 0 is 000. Okay. Convert 1. Convert 1 into binary. 0001. Okay. In this, which part you didn't understand? You tell me.
No, how did this value for 2 0010?
Because we are using I told you each of this digit will be converted into 4 bits, because in binary the base is what, 15, right?
Yes.
No, in not in binary, in hexadecimal the base is 15. If we have 15, that is all values are like 111. Okay, so the base, like we will be having like how many bits here? Like 1 2 3 4. So you'll be converting 2 into a 4-bit value. So if you convert 2 into a 4-bit value, you will be adding 2 zeros in the front. That would still give you 0, right? 0010 is still 2. Okay. So but when you're converting this like this, you will be getting 16 bits in each hex state. That is what we are getting. Okay, do the same for all the hex state. You will be getting the 128-bit value.
No, I'm not understanding. You can repeat me one more time. So the
Okay.
base decimal is 15.
No, convert each, okay, forget everything. Convert each digit into 4-bit binary value.
Okay.
Okay, so if you convert 2, you got 1 0. So you're adding 2 more zeros, then only you are getting 4 bits, right?
Yes.
Okay, if you're converting 0, 0 is 0 itself. So you are adding 3 zeros. When you're converting 1, you are getting actually 1. 1 is actually 1, right? So you're adding 3 zeros in front, then writing 1. Now you have 16 bits. That is what I'm saying. Sagar?
Yeah.
Okay, that's it.
Sujan, for preparing, when we start for that preparation?
When we
start for preparation?
For what preparation?
No, daily we have continues this class, right? After class, is there any links to practicals for the same class?
No, but if you want, I can give you something else. Okay, last time I asked you to ask for some question bank that I had. Like I asked you to DM everyone to DM me, right? Like some question bank that we have for the previous exam, which we are not supposed to share in the WhatsApp group because some inspection happens from Cisco. That will be a problem.
For dumps, right?
Yeah, you are not supposed to say that also. Thank you for saying it loud.
Okay.
Yeah. Yeah, so practice questions.
Yes.
Yeah. Router IOS flash AAA are included in CCNA. I missed last week due to router IOS flash. All these things are included. We'll be covering it. Okay, we haven't covered it yet. Aju, I mean last week also we didn't cover it. We'll be covering it in the coming sessions. Okay. So AAA trackers included in CCNA, but again, it's not theoretical portion that we are actually discussing. For theoretical portion, you will have, I mean, we are discussing, but there are other videos that you will have to refer from YouTube. There are brilliant explanation. I can recommend some. But here in CCNA, as per the syllabus, like if you're going like that is completely theoretical, and we are not actually delving too much into the stackers, AAA, and the framework of it. Like we are just discussing what is AAA and how it is helping in the networking concepts. Then router iOS, we are discussing like how to recover it, like the different versions. We are discussing it. I mean, we haven't discussed all those things, but just giving a heads up. This is all like theoretical explanation that will be given for all of this. Okay. Okay, guys. Then that's it for today. I'll see you tomorrow. Hi guys, welcome to today's session. Today we are going to start discussing DNS first. Okay. Deep, I didn't see you also for a while. What happened? You were absent. So many new faces. Today, the main topic that we are going to discuss DNS. Any of you guys know what is DNS? DNS is known as domain name system, right? Okay. Now, let's open one lab. Okay, so this is one of the lab that we have seen, but I have changed some services changes and all I have made here. Okay, so if I see here, there is an HTTP server where I am actually hosting this website, CCNA. Okay, so if I'm from any PC, if I'm typing, if I'm going to the web browser and if I'm typing CCNA, ideally I should be getting the response. Let's see. Yeah, you can see that the CCNA website has been loaded on PC1. So this is something, so I just did some HTML script. I have inserted this HTML script over here. In services, you can see in HTTP, I have written some scripts. Okay, so here, if you see here, I have run this, save the scripts here. Okay, this is something which I randomly copied from some other place to demonstrate the purpose. Okay, but the moment that you actually see here, I am getting response when I am trying and checking over here. You can actually see here also. Let's see the IP config. Yeah, but if I type the same over here, okay, I have reachability over there, guys. I have reachability to that web server. The problem is if I type it from here, CCNA, I won't be getting reply. Did you see this problem? Okay, So in computer, everything works based on something that is known as IP address. But instead of CCNA, if I'm typing 192.168.30.1, I'll be getting reply. Okay, you can see the same website I have received over here. Okay, previously what was issue they were saying? The host name is unresolved. The CCNA is not resolved. Okay, and if you check from the third PC also, you might get it. Let's see. ipconfig. Yeah, no, you won't get it. Why? Still the host name is unresolved. Okay, you can show it from here. If I'm typing this, okay, so rather than doing that, we'll do something else. Okay, so ping one ping. Okay, google.com. Okay, when I'm pinging, I'm getting a response. Okay, so actually computer understand google.com or the IP address. Okay, so you can actually see there's a translation of that actually happened when I say ping google.com. It's 172.217.163.206. They're actually pinging on this IP and getting the response back from this IP. If I'm pinging linkedin.com, I'm actually pinging on the certain IP address. But if I'm pinging something which I don't know about that particular address, then it's going to be a problem. Okay, so DNS is something like your phone book in the internet. DNS is nothing but like your phone book in the internet. So it is known as, okay, 1 second. What is DNS? DNS stands for Domain Name System. DNS resolves domain names to IP address and vice versa. DNS is an application layer protocol. DNS works on port number 53 and uses UDP and TCP. So whenever we are saying, okay, www.google.com, since computer only understands what? Computer only understands IP address. So the domain name system, they will be acting on our behalf and actually converting this thing, because we won't be able to remember these values, right? Do you remember, like you might have remembered that we pinged Google, but how many of you guys actually remember this IP address 172.217.163.206? And again, after some time, this IP address might be changing. Okay, again, like we won't be able to know that thing, right? So you might have actually have a 10,000 plus contacts that might be saved in your phone. But how many of you guys remember like more than like 5 people's mobile number? I mean, in today's scenario, that will be really hard because everybody of us, what we are doing, whenever you want to call someone, what are you basically doing? You are actually taking that particular contact. Yeah, you're taking that particular contact and you're dialing that contact immediately. Immediately, what happens? A 10-digit, or in India, like there's a 10-digit mobile number which is used over there. It is gonna replace that name with a number, and it is going to give it for you. Okay, so DNS is like your phone book. Okay, so if you remember, how many of you guys remember this concept of phone book? Like before mobile phones were getting so popular, every house, like they used to have a phone book. Like in India, there is something that is a directory, like there is something that is known as telephone directory. I don't know about the people who are outside India, whether you might have seen or used this before. There is something that is known as telephone directory. So what was the use of telephone directly? Whenever you wanted to call someone, okay, so everybody's name and number will be there in the telephone directory. I'm talking about the time before the before this mobile phones were getting so popular. Okay, apart from the mobile numbers, all the landline numbers will be available in the directory. Okay, depending on the person that you actually want to call, you will find out where the person is located. Okay, so based on the pin code, you can actually see the pin code. Then once you find the pin code, you can go in the alphabetical order, see that person's name in the alphabetical order. Then you will search that name. Once you get that name, you will see what is a number which is associated with that name, and you're going to dial that number. Okay, the same thing actually happens over here. When you say www.google.com, what actually happens is that we need to actually resolve this. There's a resolution that should be happening between, there's a resolution that should be happening between you and the system. Okay, so in order to do this, in order to facilitate this, what we do is that we will be enabling DNS. Okay, that is domain name system. So here, when I'm typing here, you can see that I typed ccna.co. So nobody know what is ccna.co. Okay, so but here in the DNS server, there's an entry which is actually registered. Okay, in the services, if you check in DNS, you can just on DNS and DNS will be on always. Okay, and you can see there is a record. This A record is for IPv4 address, and you can actually see CCNA. Okay, so whenever somebody says CCNA in the register, in the A record, it is actually mentioned that send it to 192.168.30.1. Okay, so that is why whenever you are checking your IP config, always you will see IP config /all. You will see a DNS address also, which is mentioned with it. Okay, so first you will see DHCP is enabled. That's how I got IP address, subnet mask, link local, default gateway, DHCP server also is again there. Then there is the DNS server. Okay, this is 103.163.112.48. This is my DNS server. Whenever I'm typing a website which is not there in my computer's cache, the website that I'm consistently visiting, it might be stored in my cache. If it's not stored in my web cache, it will be redirecting this request to the DNS resolver. Okay, so right now I just configured one DNS resolver here, but nothing, just drag and drop one server, then select DNS and add what is a website that you want to add. Like based on that, you can actually uh, uh, reach on this particular IP address. But what you need to see is in every IP config, if you observe, the DNS record is actually stored. Okay, so I'm actually going to configure that address here. Okay, so whenever somebody is looking, whenever there is an address which is not there in my web cache, the resolution should happen. Okay, so my DNS server is actually present where 192.160.20.2. Okay, so always you should make sure that 192.168.20.2. Okay, my DNS server is located there and I have routing table which will help me to reach my DNS server also. Okay, now I enable that. Now if I'm requesting, okay, previously I didn't get the response. Now if I'm going back to my web browser, one second. CCNA, you can see it is resolved right now. Why? Because whenever the moment that I'm actually checking here, okay, in this PC also, I'll configure this first PC. This is PC0. No, we'll configure the DNS address. Okay, so go to PC config. The DNS server address is 192.168.20.2, and this is my web browser. And I'm typing CCNA. There's a DNS request that is created. Okay, in order to reach this packet, routing should be there. Since you already know those concepts, I am removing those packets from here because you don't need it now. CDP, BTP, also STP. Okay, so DNS request is created. Okay, what we are actually trying to do is that we are trying to resolve this. Okay, so we are actually trying to resolve this. If you go to the outbound PDUs, we are looking for okay, this information is not visible here. Okay, so the destination IP address is 20.2. 20.2 is a DNS resolver. So we'll be sending the traffic to the DNS resolver. So once the traffic is reached in the DNS resolver, Okay, they are going to resolve this. Okay, so right now they will say, okay, okay, CCNA is nothing but 192.168.30.1. Okay, now when the DNS request is coming back, once the DNS request is coming back, this PC will understand that there is a DNS entry that will be registered. Then, okay, I'm going to remove that also. Okay, TCP. Did anybody see TCP here? Yeah, TCP packet. Why TCP packet? HTTP works on TCP protocol. Okay, now HTTP request is created. HTTP request is going to here. From there, traffic is coming back. Okay, so the previous again, like it was on loop, the DNS resolution. So now, if you check, if I want, like the packet, the HTTP packet is reaching the HTTP server right now. The packet is reaching there right now. They are actually communicating directly, like post all these messages. We'll be getting it right now. Okay, this is not just what we are discussing, but so far what I discussed, any doubts?
No, John.
Okay. Now, any other people, any other questions that you want to ask? This is like your local DNS. Okay, your local DNS, as in like your ISP will be configuring one DNS. So some of the, so Google, any of you guys know that Google DNS IP? It is
8.8.8.8.
yeah, it's 8.8.8.8. Okay, so that is the one of the DNS resolver that we commonly use. That is 8.8.8.8. So whenever we don't know an IP, that is something which is not there. Look, this is an IP. So this is the DNS resolver which my ISP has given me. Okay, so this is the DNS resolver which my ISP has given me. They might be using a different DNS resolver, or the packet, or before sending the packet to 8.8.8, they might be using a different place to actually replace this. So this is also like one of the DNS resolver. What happens is that for the first moment it will check is, okay, do I know this IP? Do I know CCNA.com? If not, if I don't know CCNA.com, what I'm going to do is that I will be sending the packet to my resolver. Most of the times, the packet, the resolver will be in the your service provider. From your service provider, multiple people might be browsing google.com. Immediately, the resolution will happen from there. But if you are checking a website like, how will get DNS IP from any ABCD com? Please once again repeat. What? I don't understand. Sudesh, what is your question? I will get DNS IP from any ABCD com.
Just you have provided an example. Just suppose that CCNA.com. Okay.
Okay.
And so how will I get DNS IP address from this .com?
Okay. So this is like your okay. So if you need this DNS like for inside your enterprise, if you are trying for any HTTP services, okay. So if you are actually using any HTTP or REST API configuration, what you will be doing, you might be having a lot of internal servers, and you might not be hosting this website outside the world, right? So in the DNS server, you can create one record. Here, I have created a record that is known as CCNA. That is the website, and it's an A record. Okay, and I mentioned 192.168.30.1 is the IP address for it. So whenever somebody says CCNA, resolve that request with 192.168.30.1. That's what I said. If you want, if there is more servers, what I will do is I'll create more entries and I will add all those details over here. Sudesh.
So what is
Yes,
the
sir.
process of creating done?
What? Who is speaking?
What is the process of creating those records? How do you create them?
Okay. Remote. Okay. Just remove. Okay. So here in Packet Tracer, we can only create the A record properly. So I'm just saying CCNA, that is a domain. And I am also, okay, no, CCNA. And I am just mentioning the address 192.168.30.1. Save it and add first challenge. What? Okay, add it, save it. Okay, now it will be saved. There are multiple records that you should be adding. The A record is basically for IP version 4 address. Okay, that is the important thing that we actually want to resolve. So once you do that, you can actually change it. Okay, so even if I type this as okay, CCNP also, I will have to use CCNP in the species. So whatever the domain that I'm using here, the same domain name that you will have to actually use. Okay, we'll discuss this process in detail. This is just the very basic understanding what DNS does. Type of DNS servers. First, we have DNS recursive resolver or DNS resolver. Then we have a root name server, top level domains server, authoritative name server. Okay, when you're actually buying a website, when you're actually buying a domain, you'll be configuring those information where in the authoritative domain. And if you want to actually resolve an IP address, what you will be doing is that you will be using the DNS resolver. Okay, let's take a step-by-step approach to understand. Okay, you're typing www.facebook.com. Okay, first computer will check in the host records, do I have that information? If they don't have that information, they'll be sending it to the DNS resolver. Wherever it is mentioned, it will be sending it to the DNS resolver. So most of the times there will be in the ISP side, they'll be again checking in their cache, like is there anybody who have visited www.facebook.com. If somebody visited, it will be immediately replaced from there. Okay. If not, what happens is that it will be redirecting to the root name server. Okay, there are 13 set of root name server like for .com, .net, .10, .org, .edu. For all those like 13 sets of root level domain servers are there. Okay, from root level domain server, what happens is that it will be directing to the correct position of the, if it's .com, it will be redirecting to the .com's top level domain server. Okay, if it's .net, it will be redirecting the traffic to top level domains names .com's top level domain server. Okay, then what happens is that then it will redirect the traffic to authoritative name server. This is where actually all your hosting information is actually stored. This is where the IP address of www.facebook.com is actually stored. Okay, this is the process. Do you have any questions? I hope you will have. Please ask your questions. Questions?
No.
Okay. Let us first. This is all what we are actually discussing for CCNA. This is the thing that we should be discussing. But in interviews, they might be asking more questions. I'm not talking about the CCNA interview. See, DNS is like one of the most, DNS is one of the most commonly asked questions in the interview for network engineer positions. Okay, DNS proofing is something, nothing but Rita. Okay, so I'm actually having this DNS server. Okay,
DNS spoofing is actually spoofing the DNS records. So this is one of the common security attack that people are actually doing to break the vulnerabilities. Okay, so I actually want to go to CCNA.com. Okay, so CCNA record is actually stored as 192.168.30.1. So what if an attacker is actually changing this, is getting, getting this A record and actually replacing it with the IP. So whenever somebody is typing CCNA, again it will ask for resolution. So it will look at the DNS server. Once they are coming for the DNS resolution, we are actually saying, okay, don't go to, we won't be saying that don't go to 30.1. Instead of 30.1, okay, so I'll be saying go to 30.2. Okay, that might be the attacker's device, or send it to a different IP like 1.1.1.2. Okay, that might be the IP of the attacker. So once they reach there, the attacker will have the complete access. Okay, that is what happens in DNS spoofing. That is known as a DNS spoofing attack. Clear? Okay. Now, in DNS, there is a security. I'll show you that. All of you guys, rather than what we just discussed, I would recommend you to use this resources. Like Cloudflare is one of the best DNS service like they are offering. So here, like they are actually discussing like what, lot of details like that we are not actually covering in CCNA. What is DNS? DNS is a phone book of the internet, human access information through the online domains, like this entire things we discussed. What are the 4 DNS servers in loading a web page? One is DNS recursor. We already showed that in the picture. This is the DNS resolver. Okay. Or the recursor. The recursor can be thought as a librarian who is asked to go find a particular book in the library. The DNS recursor is a server who is designed to receive queries from a client machine through applications such as web browsers. Typically, the recursor is responsible for making ideal request in order to satisfy the client's DNS query. Okay, so what you will be doing is that, like when you go to any place, okay, if you have visited your college library, for example, you are saying that you are looking for this book, how to program with C. Okay, so you will be asking your librarian, okay, where can I find how to program with C? He'll be saying that, okay, this entire thing belongs to where? This entire thing belongs to the computer science section. Check over there. Okay, so once you go to the computer name server, okay, based on the type of subjects which are available over there, like programming is there, algebra is there, logic is there, networking is there, operating system is there, then electronics, some modules are there. Based on that, again there will be different racks which are actually separated for networking, operating system, programming. Again in programming, like it is again segregated to data structures. It is actually subclasses into like multiple sessions, right? So how to program with C, like immediately once you go over there, they'll be immediately saying, okay, there will be a, okay, that the computer section library will be in the second floor. Once you go over there, you'll be asking the person who is in charge there, where can I find program with C? Then they will be saying that, okay, this entire thing belongs to programming section. Go to this particular rack, check it. Okay, once you go over there, based on this numbers, serial numbers and ID index, you will be identifying that particular book. Okay, root name servers, the first steps translating a human readable host names into IP address can be thought of an index in a library that points to different racks of the books. Typically, it serves a reference to other more specific location. Here, the resolution is not happening. It is actually redirecting you to where exactly you have to go. Then you will be going to the top level domain. It can be thought of a specific rack of a book in a library. The name server is the next step in search of a specific IP address, and it hosts last portion a host name .com. Okay, then it will be redirecting to where? It will be redirecting to the authoritative. It will be redirecting to the authoritative name server. The final name server that can be thought of a dictionary on a rack of a book, which is specific name can be translated into definition. The authoritative name server is the last stop in the name server query. If the authoritative name server has access to the requested record, it will return the IP address of a requested host name back to the DNS recursor that made the initial request. So here is the resolution that happens. In DNS also there is security. Using the security you can stop this spoofing attack. That is known as DNSSEC. Okay, so this is what we are actually looking for learning in CCNA, but there are different things that you really need to understand. What is the 8 steps in DNS lookup? I mean, this is an elaborated approach, what we just discussed. What is DNS resolver, type of DNS query, and some other thing also we will discuss now, that is DNS records. Okay, what is DNS record? In DNS, like you have multiple records. A record is stands for the IPv4 address. So in Packet Tracer also, what we did is we mentioned the IPv4 address. Okay, you can see this is an A record. Using the A record only, the translation happens. But when you have an IPv6 record, you have 4A record. A record. This record contains the IP version 6 address. CNAME record forwards one domain or subdomain to another domain, does not provide an IP address. MX record, it is for the mail server. Okay. TXT records, like let admin store the nodes in the record if needed. NS record stores the name server of the DNS entry. Where is the name server which is located? It will be updating in the NS record. SOA record stores admin information about the domain. SRV specifies a port for a specific services. PTR provides a domain in the reverse lookup. So whenever somebody is saying that, okay, 192.168.10.30.1, okay, what is that? Like it is actually CCNA. So it will do the reverse functions. Okay, that is all you have to actually understand about records for now. Then there are other records also, but we are not focusing there now. Okay, securing DNS. This is something you will have to understand. Here we can use this DNS security protections, how DNSSEC works, all those things. Please refer by yourself. Okay, so this is the website that I would recommend for you to understand DNS. Go to the Cloudflare website, check the different types of records and also the security. Like if you are actually preparing for a network security engineer role, you should be referring this before you go to the interview. Any questions you want to ask? Any doubts? Guys, everyone has any other doubts? Okay. Now we are going to learn about FTP and TFTP. Again, this is one of the theoretical topic. FTP stands for File Transfer Protocol. This, okay. So all the practical sessions that we had to do, like we actually completed from today to like this Friday. Like we have some theoretical portions left. We are actually finishing that, and we'll be doing one practical that is only for VPN. Okay. So FTP stands for File Transfer Protocol. This is a type of protocol that is used to transfer or copy file from one host to another. And FTP is a secure channel that is used to provide file transfer, provide a transfer of files between host and system. FTP works on 2 ports, 20 and 21, one for data and one is for connection control. Okay, so FTP is a commonly used protocol in terms of file transfer. You'll be using a FTP server. Okay, again, we are not doing the practicals. I'm just showing that you can configure FTP like here. You'll be going here, going to the services, just select FTP. Okay, FTP is on. I have just created an account that is using CCNA. So in this FTP server, I have given all the permission for read, write, delete. All other operation I have given the permission, and just using the username and password, you can log into your FTP server. The commands are pretty much the same. You can use FTP, the IP address. You will be logging over there. Okay, FTP 192.168.30.2. You will be logging. You can enter CCNA Cisco. You are inside that. So from here, this is like a passive mode. From here, if you want to send, receive information files, this is the maximum that we can configure here. Like you can send and receive files. So this is just an application. FTP, nothing but file transfer protocol. It is a protocol which is used to send and receive files. It is a protocol which is used to send and receive files. Okay, then there is one more protocol that is known as TFTP. TFTP stands for Terminal File Transfer Protocol. TFTP is used to transfer files either from a client to a server or a server to the client without the need of FTP feature. Software of TFTP is smaller than FTP. TFTP works on 69 and port number and its services is provided by UDP. So because of its faster performances, it is using UDP. Okay, so TFTP, Tribal File Transfer Protocol. TFTP is used to transfer file either from a client to server or a server to the client without the need of an FTP feature. FTP is actually using TCP services. It is used to send like large files, send and receive large files. So TFTP is actually acting as a backup option rather than using FTP. So where TFTP is using to send smaller files, like when a router is getting stuck, if you want, like when a router is getting crashed, if you want to restart the router or reinstall the router with an ISO image, there will be a TFTP server. From the TFTP server, you can load and run the images and reboot the system. Okay, FTP stands for File Transfer Protocol. TFTP stands for Tribal File Transfer Protocol. The software of FTP is larger than TFTP, while TFTP is smaller than FTP. FTP works on port number 20 and 21, while TFTP works on 69 port number. FTP services are provided by TCP, while TFTP services are provided by UDP. The complexity of FTP is higher than TFTP, while complexity of TFTP is less than FTP complexity. There are many commands or messages in FTP. There are only 5 messages in TFTP. FTP needs authentication for communication, while TFTP does not need much authentication. Like in FTP, you have seen that we were using one username and password to log in, but here in TFTP, you are mentioning what are the actions that you need to perform. It will be it will be facilitating that. FTP is generally suited for uploading and downloading files by a remote user, while TFTP is mainly used for transmission or configuration used from networking devices like routers, switches. If you want to deploy the configuration that are actually smaller files, you can actually do it from a TFTP server, and it is using UDP, so it will be much more faster. FTP is a reliable transfer protocol because it is using TCP, while TFTP is unreliable transfer protocol. FTP is based on TCP, while TFTP is based on UDP. FTP is slower, TFTP is faster as compared to FTP. Any question? Anything? This might be the things that you have actually learned in your school days, I believe.
Yes, John.
Any questions?
No, John.
John, I have a question.
Yeah, please.
So for this FTP and TFTP, we need to enable anything on the router for
where you actually configure this, you need to enable it there. If you are configuring a TFTP server, see, I have actually configured FTP. I mean, here this is a demo version. Okay, this is not the actual FTP server. It's like okay, you will be going to the server. Here I am saying this is the server FTP server that I used. Okay, I just mentioned what is a username, what is a password. Okay, and what are the permission that I'm giving to it. I just mentioned read, write, delete, rename, and list it. Okay, these are the permission that I mentioned. I given all those permissions. That is why you are seeing read, write, delete it. Okay, so even I can create one more now. That is CCNE. Okay, I only want to give read and write. I don't want to delete any files. I mean, so based on this, we'll be adding it. So right now you can see read and write permission is given for CCI. Okay, then you will be using some credentials to access it. Okay, you just mentioned now CCIE. Okay, Control C, come out. 30.2. It is asking for username CCIE.
Cisco. VRM. Okay.
Yeah.
Any other questions, guys? Okay. Now we are discussing one more protocol that is known as CDP. You might have seen in simulation there is a protocol that is actually running. Okay. Either it's STP or okay. We'll open another lab. New. No. Okay. This is one of the topology that I designed now. Now you will see STP. After STP, you will see DTP. After DTP, might be seeing some other protocol. Okay, that is CDP. Okay. How many of you guys have seen this packet and wondered what is a CDP packet? We know like what is STP, DTP, all those things. Like what is CDP? How many of you guys have observed this CDP packet in Packet Tracer? Anyone seen this packet and wondered what is this? And if you know what is this, tell me what is it. Interface F0/0. Okay. CDP is just nothing but a protocol that is known as Cisco Discovery Protocol. What is CDP, guys? CDP is Cisco Discovery Protocol. Using this protocol, the main objective is interface F0/1 also. No shit. Okay. Using this protocol, it is used to understand what are the neighbor devices that are connected. Okay. So here, when I say enable show CDP neighbors, you can see what are the okay. This is from switch 0. Okay, in switch 0, F0/1 is actually connected to a switch whose model number is again 2960. Okay, again F0/2 is also connected to where F0 from, you can see from F0/1 it is actually connected to F0/1 port of a switch. Okay, and from F0/2 it is connected to F0/2 port of another switch, and you can see that model number is also 2960. And if you look here in F0/3, it is connected to F0/1 port of the router. That is also, that's model number is 22800. It is a protocol which is used to identify what are the neighbor devices that are connected. Okay. Understood what is CDP? What is a okay, after the certain time they will be removing that, because this much time only they will be remembering. Like after this, like they will flush it if they didn't get any CDP packets from there, informing their neighbors. They will understand that the link is going down, like STP. Like there is a hold on time, right? After the hold on time, they will be changing it back. Okay. Then you have another protocol that is known as, that we cannot show in here. That is known as link discovery protocol.
In Cisco devices, we'll be using CDP. On all other devices, we'll be using LDP. It is developed by IEEE, where CDP is actually developed by Cisco. Again, LLDP is something like a vendor neutral protocol because you can actually run on any devices. But if this is not enabled, okay, I can use this LLDP run config. LLDP run LLDP enable. On by default on Cisco devices, this will be disabled. Exit LLDP. Okay. Configure terminal interface F0/1 LLDP enable. Okay, on this switch we cannot run. Either you have to run it in interface or in the global configuration mode. In both the modes, we are not able to type in this particular switch. But one more thing, the last thing that I can check is show LLDP neighbors. Okay, so LLDP should be enabled on other devices. Let's enable it first. LLDP. By default, we'll be using CDP or LLDP. CDP only works on Cisco enabled Cisco devices. LLDP is working on all other devices. Yeah, that's what we are seeing. On some models, you won't be able to use it. Okay, you can say right now LLDP I'm using here, but here we are not getting the neighbor information. Right now, once I enable LLDP on all other devices, you're seeing this information again. Interface F0/1. You can see the hold on time is there. And the port ID is one, but you see limited type of information, local interfaces. But in CDP, what is the main difference is that you get a complete visibility compared to LLDP. In LLDP also, like we see like what are the devices that are connected on other devices, like in F0/1 and 2, you can see port ID that is connected F0/1 and 2. So it is more easy to look because being using Cisco devices, it's much more easier for us to understand like how this protocol works, CDP works compared to LLDP. But you can use the same command, show LLDP neighbors. You can see the device ID is switch. It is connected to the local interface F0/1 and the port ID that we are connected to, that is F0/1, F0/2, F0/2. The same information only that you are actually getting. But this looks much more easier to understand. Being using CDP for a while. Again, the main advantage is that if you just run CDP commands on all the devices with a pen and paper itself, you can able to draw the complete topology of the network. Just run CDP command here, CDP command here, CDP command here, and CDP command here. You can see in all devices what are the other devices that are connected to. Go and run the same command on other devices also. You can see what are the devices that are connected on other devices also. So it's much easy for you to draw the topology and understand that. Any questions, guys? Any questions? If not, that's it for today. Tomorrow we'll be discussing SNMP and AAA. Somebody asked like when we are discussing radius and tactus. Yeah.
John, have we covered the, how to upgrade the version or I missed it or something?
How to?
Upgradation of this version. I mean, is it in the course or not? Syllabus, I don't know.
Which one? I mean, like upgradation of what?
Any upgradation. I mean, switch upgradation or the router upgradation. Version.
No, that is not in the course. iOS update, that is not in the course. We'll discuss what is the different like NVRAM,
all other concept we'll be discussing, but the upgradation can be only done from a server. I mean, you need the image for. I mean, that cannot be covered in this course.
I mean, we can this process how to do that.
Okay, I'll see a way how we can figure out that. I'll update you this tomorrow. I mean, which one you want to know? Like which upgrade, router, switch?
I mean, router, switch, both.
Okay, we'll see that.
I think the process. I think the process will be same, right, for the router and switch.
Yeah, the process will be same. The process will be the same. Okay, we'll discuss that. Just have to check. That is not possible in Packet Tracer. My EVNG, like I had got an attack. I mean, my few of this, I downloaded some files from torrent, and I mean, the images that I had is completely crashed, and I'm just collecting those images back.
The process only, John. I'm not asking you to go with the. I mean,
practicals.
Yeah.
Okay, the process. Okay, process. Of course, I mean, process we are discussing for sure. I mean, I didn't say. Okay, I thought like you wanted the practicals. Yeah, the process I'll explain tomorrow also. Tomorrow also we can do that, but tomorrow we are actually discussing AAA and SNMP. Is there anybody who is using SNMP in production? Anybody who is using this SNMP? Anyone? AAA? Okay. Okay. No worries. We are discussing. But if anybody is working with AAA also, I need to ask like few questions for that. Okay. Yep. Okay, guys. I'll see you tomorrow.
Yeah, thank you, John. Bye.
Thank you, guys. Bye.
John, SNMP is used for its protocol. It's used for what?
Network management. Simple network management protocol. So it's one kind of automation like for monitoring network devices, like see the abnormalities. You'll
Yeah,
see the
161
metrics.
and 162 is the port number, right?
Yeah. Yeah. Are you using that?
I am allowing that port in order for the firewall rule somewhere. That's why I'm asking. It was a
It
requirement
is
from the
basically used for
time.
monitoring. You're not giving any permissions. I mean, I haven't personally worked with SNMP in production wise because I didn't get to work with SNMP in any of my opportunities.
No, I also not work, but I have seen this allowing on a firewall rule. Yeah, this port.
Okay, okay, need to check that. Okay, as per my knowledge, SNMP is just monitoring. There is already a rule which is already configured. So when the rule is actually broken, or whenever there is a threshold which is broken, immediately we'll be getting an update saying that there is a certain change, certain abnormalities are happening in the network. Give an immediate look at it.
Okay, like I mean, you said if there is a monitoring device which is there for monitoring all the device, which usually sends alerts if anything goes down, right?
Yeah, anything goes down, you'll be getting an update.
Okay, yeah.
Some devices consuming more bandwidth, you'll be getting an update like that.
Fine. We'll discuss it. Yeah.
Okay. Tomorrow we'll discuss. Okay.
Yeah.